Hello and welcome to DevFest 2020. I'm Jason Titus, VP of Engineering at Google, joining you from my home in California. Each year, we at Google truly feel the anticipation for DevFest. It's a one-of-a-kind series of developer conferences, and we're glad you can join us and the local developers within your community. Your local DevFest event this weekend is one of hundreds taking place all around the world right at this moment. And what makes DevFest truly unique is that it's run by volunteer community organizers on a mission to help other local developers grow and share a passion for Google technologies. Let me introduce you to my teammate, David, to share with you some great examples. Welcome, David.
Hi, Jason. Thank you. And welcome everybody to this year's DevFest season. I'm David McLaughlin, Director of Developer Ecosystems at Google. So I've been with DevFest since the very first year in 2010, when I was able to join a large percentage of them. Back then, they were a series of targeted events in just a handful of countries. In the years since then, we've had massive growth to countries all over the world. I'm happy to be able to continue this celebration of developers and tech in a new virtual format and bring people together to learn and to share what we're all building. Now let's take a look at a really inspiring story from Uganda. It shows how a community member started learning about machine learning and ended up building a really nifty app using TensorFlow that detects diseases in plants and helps farmers reduce crop devastation. Take a look.
Growing up in the city, I never expected to work in agriculture, but when fall armyworm attacked, it affected us all. Since its arrival in 2016, this crop pest has caused massive devastation. I've met farmers who have lost everything.
Tubadde tukozzaako ddagala okulaba nti akako okulya ki kasooli naye akantu ako tekayinza kumalawo obulwadde obwo ssebo.
So I wanted to use my skills as a software developer to help. At a Google Study Jam, we taught ourselves TensorFlow. We started by building an Android app on top of an open source API. The app allows farmers to spot infestations early, far beyond the capability of human eyes, and suggest an effective treatment. When I was younger, I didn't know what I wanted to do, but then I discovered app development, and I was excited to show people something they never thought possible. Machine learning gives us the advantage against fall armyworm, ultimately saving harvests and reducing pesticides.
Kunkyusizaamu kubanga taata oba jjajja teyalina ennyumba y'ebbaati. N'ebbaati nazimba ennyumba yange nga tetoonya. Tulina essuubi ne tufuna embeera ennungi mu kulima.
We are just getting started, and there are so many other sectors like health and education that machine learning could really improve. Farming is a crucial aspect of life in Uganda, and I feel proud I'm part of a team driving to ensure our culture can continue.
Earlier, you saw a beautiful inspirational video.
Hi everybody, this is Mota Gelani. Welcome to the mobile track for the DevFest 2020. So, while we are going to have a lot of fun today, there is also a few things that to keep in mind to be respectful about all of the peoples here. So please go through the code of conduct, and while having a fun, if you have any kind of experiences, like funny experience, you learn something today, put it on the social media, and we have a prizes for you. So be ready for that. Cool. Let's get started with the next session. Let me introduce Antoine and Hadis, who will help you to go through the schedule. Thank you.
Hey everyone, I'm Harris. I'm a DSC lead at the Brunel University in London, and I'm going to quickly go over our agenda for today. So we're starting with Hoi Lam, who is speaking about the 4 steps of Android machine learning, followed by Jay, who will be looking at unidirectional data flows, and finally finishing with Wajahat talking about making the Chrome's T-Rex game. So I'm going to give it to Anton to introduce Hoi.
Hey everyone, I'm Antoine. I'm an Android developer at CityMapper. and I will be one of your hosts today for the event. So the next talk is Hoi Lam, but we are a tiny bit early right now. So yeah, like you can see on the agenda, this talk should start at 10:15 a.m. And we are 10 minutes early. So for now, we have nothing. So if you want to talk about things, Harris, how are you?
I'm good. How are you?
Yeah, I'm good. I just woke up really early. So, yeah.
It's been hard organizing DevFest, but I think it's going to be a good one this year.
Yeah, it's going to be good, even if it's not in person.
Yeah.
It's going to be great. But last year, I was part of the in-person DevFest, and I woke up at 5 a.m. No, we had we had to be at the venue at 5 a.m. So I woke up so early.
Wow.
so today at 7 a.m. it's fine. It's fine.
Yeah.
So on the chat, for the people who are already here, if you have any question on how we prepare this event, how we manage to have this event today, if you have any question, don't hesitate to ask, and maybe we can reply, maybe we can answer. So yeah, today we have a lot of talk. There is also several other tracks if you are interested on cloud, on machine learning, on ethics and diversity, on web, on a ton of things.
And we have a hot tech section.
On
looking very interesting, yeah.
Yeah, this one looks really interesting. I think I'm going to see a bit during the afternoon. I see a talk that can be interesting. So yeah, it's going to be a good day. So yeah, me and Harris, we are your host for this morning for the mobile track. I know Harris will be on some other tracks as well. Host, he's a good speaker. So yeah, we are still waiting. Still not 10:15 a.m. So we still have to wait a bit. So yeah, what can we talk about?
Which one of these three talks are you probably most excited for? The ones coming up.
I really like the machine learning. I haven't played a lot with that, but I know it's going to be the future. We are going to have that everywhere. So yeah, the machine learning talk are even all the talks are interesting.
Yeah. I'm also the machine learning part. I agree with you. I think 100% that's our future. Everyone's going towards AI and machine learning, and we have a whole AI and ML track at DevFest today. But I also, the unidirectional data flows. I was reading up about it last night actually to understand the talk a bit more. Which it seems really important, something I didn't really consider beforehand.
It's the kind of thing that can be really interesting to see as well. So yeah, and the third talk about Compose, Compose is probably the biggest thing coming on the Android world. So yeah, and to see how we can use Compose to do funny things not to find how to use Compose in another way. It's going to be a great talk, I suppose.
Cool. I think Mamta has another video to show.
That's good.
While we wait.
Yeah, let me give it a try. Let's go back.
And to answer Martin, great. And yes, all the session will be recorded and available later, Ravisara. No worries at all.
Cool. I think it's about the theme. Let me just edit. Yeah. Sorry about that.
Follow @GDG on Twitter for highlights from DevFest around the world, and try out the DevFest AR filter and avatar. Share what you're learning or your favorite part about the event on social media with #DevFest.
Hello everyone, I'm Louisa from the Google Developers team, and I'd like to welcome you today to the very first UK and Ireland DevFest. We're really sorry we can't be together in person, but I know you're going to have a brilliant time with us today, as it's a rare opportunity to get to hear from and interact with developers from across the UK and Ireland and beyond. I'll hand over to Jen now, one of the main organisers of today, to tell you more about what we've got lined up for you. Enjoy DevFest.
Thank you, Louisa. Hi everyone, I'm Jen Ashley, and I'm one of the many GDG leads who are delivering this event to you today. There are 16 Google developer groups who came together to plan and create a wonderful event for you. We are also joined by 2 developer student hubs who have been very active in spreading the word to the student community in the UK and Ireland. I feel very fortunate and happy to have worked with these 29 other individuals to deliver this to you today. Please meet the team. So thank you to this wonderful team, and to you, our attendees and speakers. Thank you for being here, and enjoy the rest of the conference.
Hey, so we can introduce Hoi now. So we talk about the agenda already before. But yeah, now Hoi is here. Welcome Hoi. So maybe we can add him to the stream. Wait.
Hey.
So hello Hoi, how are you?
Great. How's everyone?
Yeah, good.
And can you hear me okay?
Yeah, we hear you perfectly fine. So
fantastic.
So yeah, we are really excited about the day and also about your talk, which I think is going to be really interesting to see. So for everyone, I'm going to introduce a bit you. So you are an Android a developer relation lead for the Android machine learning team. And you worked also on the Google Glass, on the Android Wear. You did a lot of stuff at Google. And yeah, today we are going to talk about the 4 steps of Android machine learning. So yeah, welcome, Hoi.
Fantastic. Yeah, no, really happy to be here. And as many of you know, I was part of the London GDG kind of organizer group before I joined Google. So London is always that bit more special to me. So yeah, really happy to see all of you here. Yeah. Should we wait for another minute, or should we kick off now to get our stuff?
You can take off now. It's fine, I think. Yeah.
Okay. Cool. All right. So today I'm going to, as you say, talk about the 4-step of Android machine learning. Some parts of this talk, if you have been to other machine learning talk that I've given before, you might have seen it. But I promise you that there are a lot of new material because there is a lot that happened over the last year or even over the last month. So hopefully I will cover a lot of those ground. And the purpose of this talk is to essentially introduce the full set of tooling and APIs from Google that you can choose from, so that you can concentrate on what works best for you. Yay, my slides is up. So another thing that I want to highlight is if you want to get more information or more up-to-date information, you can always follow me on Twitter. My handle is Hoitab, Hoitab. So with that, let's get started. So let's take a stand back and just say and ask two questions. The first one that I'm going to ask is, hey, why machine learning? We got perfectly okay and great programming tools. You're a bunch of great programmers. Why do we need machine learning? And then the second question I'm going to address is also why do it on device? Why do it on these tiny phones instead of your data center? So let's take the example of activity detection. So let's say you need to detect whether someone is walking, running, biking. Then you might do something like this and say, hey, what are the speed that they're going at? So if the speed of movement is less than 4 kilometers, then it's walking. And if it is kind of maybe more, then it is running. And then for biking, you might add in another if-else statement again. But then what happens if you do something really completely different, something like golf? But at the same time, those are all just activities. And the traditional way of programming mean that you need to pick on a certain feature, and if that feature kind of describe the differences between all your different activities that you're trying to detect, fantastic. But as soon as you stray away from that, then you run into the problem. And here's where machine learning comes in. So with traditional programming, you have rules and data coming in. Essentially, the rules are the if-else statement, and then data is speed in that case, and then the answer comes out. With machine learning, what we can do is we can tell the computer that here are the answers, whether they're running, walking, or golfing. And on the data side, we might feed in something a little bit more unstructured, things like your accelerometer data or your gyroscope data, and then out pops a rule. So once we have got those rules, we can then plug it back into the traditional programming realm of running through the train model. So we in machine learning, we essentially leveraging both. So on the training phase, we will basically be at the bottom of this slide where we put in the answer and the data, and I'll pop the rule. And then once we get those rules, we'll basically go back into the traditional programming realm of here's the rules, here's the data, and I'll pop the answer. And this is what it can look like, when we get it working properly. The second thing is why on device. As I said, you have invested, and Google also have invested hugely on the data center that we have around the world. So why do we want to do this on the device? The first reason is privacy. The data stays on your user's device. Second is it works offline. So when we are allowed to leave our Wi-Fi bubble at home, then you can use it anywhere that you want. And last but not least, low latency. And this is the one that I'm most excited about, because you can run your machine learning model without the back and forth delay of sending data to your data center and coming back. So it can really provide a live experience, real-time experience to your user. And that can completely change how the user use your app. So in the rest of this talk, instead of going through the different brands and MLKit or TensorFlow, I would actually maybe just walk you through the 4 steps of implementing a machine learning kind of experience in your app. So the first thing is design, and then the second one is after you have found that you want to use machine learning, finding a model. That's the easiest way to build it in, and then if you find that it is not suitable, that there is no model that is tailored to your use case, you can build a model, and then finally implement it. So if you build a custom model, how do you basically put it into your Android app? So with ML design, very quickly going through I just really want to highlight the People Plus AI guidebook that we've launched at I/O 2019. It highlights the best practice that Google have learned. The most important thing in this guidebook is that it tries to focus you on not so much the cool things that you can do with machine learning, but more around focusing on the need of the user, and then see whether machine learning is suitable. So that's something that we should really highlight here, is that machine learning shouldn't be used as a magic dust. on top of your application, but you should really focus on the user. And the other thing about this guide is it's not just for engineers or designers or PMs. It is actually for everyone in your development team. So this is something that may be useful if you're planning a design sprint and you wanted to basically think about machine learning in a holistic way rather than kind of on a piecemeal kind of basis. So this is something that I would really recommend for your next design sprint. So moving very quickly, because we have very limited time today. Normally this talk is about 40 minutes. I'm cutting it down to 20 odd minutes, and hopefully we have some time for Q&A. So the next stage is, once you've found the machine learning is the correct thing, the easiest thing is to do here is to try to find a ready-made machine learning model that you can use. And here I want to introduce 3 places that you may be able to find them: MLKit, Android Platform, and TensorFlow Hub. With MLKit, as many of you know, it is Google's machine learning SDK for mobile. You can use it just like any other SDK, and there is no ML expertise required at all. There are Java/Kotlin APIs that you can just plug directly into. You don't need to understand basically what's going on kind of behind the scene. And it is built on top of TensorFlow. And I know that I'm from the Android developer advocacy team, but this API actually supports both Android and iOS. And the first thing that's new in 2020 is this. So previously, when you want to use MLKit, you needed a Firebase account, but this is no longer the case as of this year. We have actually separated the on-device functionality for MLKit from the Firebase product. So you no longer need an account, and you no longer need to basically make sure that your sign-in .json file is correct before you can use it, because all the APIs that we have within MLKit runs on the device and is actually not really using Google resource beyond the initial download. So, why do you need the sign-in at all? And the second thing that's new is we have added 2 new offerings this year, in addition to other kind of improvements, which I will talk about later in the implementation phase. So the first one is digital ink recognition. So this is to do with handwriting, and then the other one is post detection. So let me walk you through very quickly about those 2 APIs and what's so special about them. So firstly, with digital ink recognition, it supports over 300 different languages, including and also on top of it, emojis and basic shapes. So if you want to draw a pizza, it will recognize it. And it's powered by the same technology as Gboard, the Google keyboard that Google Translate and Quick Draw, and it runs fully on device. And one thing that's really special about digital ink recognition instead of a static image recognition is that because the user draw those shapes in turn. So in this animation, when I was writing in my native Chinese or Cantonese, the algorithm actually detects which character goes first, and then which characters go second, and so on. And this is something that the context that is lacking if you purely kind of give it a static image. So it really helps, and many of you know this. If you have done optical character recognition before, the hardest thing is to basically going, hey, which part of the recognized tags or sentences come first and which one comes second. This completely solves that with the digital ink recognition. Next is post detection. So we have launched, in fact, 2 models. One is a fast model, the other one is accurate, depending on basically your performance need versus kind of accuracy. And it provides 33 points, in fact, of your body, including facial landmarks. So that would include the eye, where the nose is, and where the ears are. And at first, some developers was asking, hey, maybe we need this in 3D, etc., in order to do a lot of things that we want. But what we find actually is that you can do a lot by just measuring the distance between the joints. And what we suggest developer to do is to just measure the distance between joints, and starting with just 2 points, and just say, hey, where did my knee go? And then you can then add more and more joints to it. And we find that between 2 points and 4 points, a lot of these exercises, like the squat that you see here, can be easily counted if you just measure the 2D distance between joints in between pictures. And like everything else that is in MLKit, it runs fully on device and is offered at no cost. If you want to find out more, go to g.co/MLKit. Next, about ML platform, about the Android platform, and this is something that I've talked about before last year at DevFest London, so I won't bore you too much about it. And I just want to really highlight the capability of both text-to-speech that's available back from 2009, API level 4. And the second thing is around the speech recognizer, which has been available since API level 8. And all the models have been continuously updated. So please check it out if you have a speech requirement there. And to find out more about how to implement it, you can go to my talk last year at Google I/O. And the final thing that I want to highlight about this particular functionality is the wide coverage of languages. So as I said before, I speak Cantonese. I'm from Hong Kong, and and you might argue that, hey, that's a much smaller market than, say, what people speak in mainland China, which is Mandarin. But it is a language that we do cover in both the voice recognizer as well as the text-to-speech. So if you have a language need, please do try it out and see what the support is like, and give us some feedback. If there are languages that we don't support or don't support that well, let us know. Last but not least, in finding the model is TensorFlow Hub. So TensorFlow Hub is a large repository of TensorFlow model, as many of you know, and it contains models from both Google as well as the wider research community. And for mobile developer, the section that we're really interested in is the TensorFlow Lite section. So TensorFlow Lite is a model format that is optimized for both mobile as well as Internet of Things devices. And all you need to do is to click on this option, and you will basically see a filter view of all the models that's compatible. But actually, my favorite way of using this is actually using the search box at the top. You just type in kind of what kind of use cases you want, and then it will basically list out all the models again. And just want to give you an update on some of the things that are available. So as of middle of this year, there are some very large-scale classifiers that are available. So previously, this kind of functionality can only be done in the cloud. So you can imagine a model with 100,000 different classes of supermarket goods, or wine labels, with 400,000 different wine labels. Those are really difficult to pack into a compact enough model, let alone kind of have the performance to run through that. In addition, we have also published kind of landmark models as well for the 6 continents, so you can choose one continent at a time. A little bit of a health warning is that the model is relatively large by Android standard. So for the US supermarket goods, is about I think it's about 37 megabytes. And then for the wine label, it's about 140. So you will really need to, if you're deploying it live, you will need something like the dynamic asset delivery on Android to really deliver it to your audience. And if you want to find out more, search for an update at the Google AI blog. So that's the 3 places where you can find a ready-made model. MLKit, the most easy to use. You could just call the APIs. On the Android platform, we have a lot of speech-related functionality that you can get out of the box. And then finally, if those doesn't suit your need, you can actually find a lot of ready-made models from Google and third-party at the TensorFlow Hub. So next step, what if those model doesn't suit your need? Here we want to highlight 2 offerings from Google. The first one is Firebase ML, and then the second one is some new functionality from TensorFlow. So with Firebase ML, we have a new functionality as of last year where you can go through a graphical user interface and upload a bunch of photos to us, and we will help you train the model, which you can then download and package either in your app, or you can serve it via an API. And this is what the interface look like. You just upload a model, and then you just press train model, and it is that simple. So that really serves the kind of image classifier need, which is what we first go to in a lot of the machine learning needs. So what if you need something else? So towards the back end of last year, we introduced TensorFlow Lite Model Maker, and at the beginning, we have really just two functionality. One of them is, of course, image classifier. The next thing that we introduced was around text classification. And that was just a start. And what we've done this year is we have really expanded the range of offering that we have to include other functionalities such as question and answer. So you can now train a model to answer your domain-specific questions and answer using BERT, which is a natural language processing model that Google Research have produced in a mobile context. And to train it, you have you basically put together JSON files like this, where you have a paragraph of text, and then you basically tell the training algorithm about what questions can be asked from that passage, and highlights basically where the answers are. And if you run a bunch of these through the model and the training process, then the model will be customized for your particular domain. Another thing that's worth highlighting is that even without training, in using your domain-specific knowledge, the model is actually ready to use as is. And how it was trained was using a large quantity of Wikipedia articles. So let's, the way that I would recommend using it is, let's use it just generic. Let's just use a generic model and see if you get the result that you want. But if you're in a particular field, let's say medicine or other specialist domain like engineering, a particular type of engineering where the question and answer, the generic question and answer model doesn't serve you as well, then you might want to kind of go into more depth to train your own specific model. So those are the two routes. If you have a image classifying need, then you can just go directly to Firebase ML with the GUI interface, the graphical user interface. And if that doesn't help, then there are more models and more training that you can do with the TensorFlow Lite Model Maker. So after you have got your custom model, how do you put it into your app? Again, there are three ways to do this. So the first one is MLKit. Second is something that's new from TensorFlow called TensorFlow Task, which we've launched, I think, a month ago. And then finally, as of this Monday, actually, the Monday just passed, the ML model binding in Android Studio 4.1. So let me walk you through the three different options. And at the end, I will also try to compare and contrast which one you should use. So with MLKit, as I said, this year, we have actually made some improvement to some existing APIs. And two of the APIs that developer have access to previously, image labeling and object detection and tracking, previously was only customized to use a default model that Google produced. But a lot of developers actually come back to us and say, hey, I want to plug in my own custom model into your pipeline. Can you do that? And we say yes. So as of June this year, we enable that functionality. And why would you use something like this? So if we go to, for example, something like object detection and tracking, these are 5 of the categories that we automatically can differentiate between, and that's something that you can use out of the box. But if you, if let's say your product or your target are not one of these 5 categories, then you might want to train your own custom classifier and plug it into the object detection and tracking so that we can do the filtering for you. And so that's one use case. The other one is, let's say you have very distinctive designs for your home goods or your fashion goods. So those are categories that are covered, but the default model doesn't work that well for your brand or product. Then you can actually also train your own custom classifier and plug it into the object detection and tracking API and use it in a very easy way. And this is what the code will look like. So starting from the top, you plug in your custom TF-Lite model. In the middle, you put it into the detector option. And then thirdly, you basically initialize a object detector using that option that you have created. That's the way to do this. Next, TF-Lite task library. So there is a large repository of TensorFlow model from both Google and the wider research community, as I said before, on TensorFlow Hub. And it covers a lot more than the two use cases that we just talked about in terms of image classification and object detection. So we have built actually a library wrapper that you can use, and it's optimized for specific tasks. So ranging from the default image classification all the way to question and answer. So you can now easily drop in the model that you have trained before. It supports both Java and C++, but at the moment it only supports CPU and single-threaded right now. But we are working on supporting both acceleration via hardware as well as multi-threading. The last word of warning is that it is coming from a nightly build, so we are continually we are improving that code day by day. So as a result, if you're using it in a production environment, one, test it properly. The second thing is you really should cache your own version just in case that the next nightly build is broken. Then you can kind of revert back to the version that you know works. So let's start with image classifier. It looks no different. You just basically create an option, create image classifier, and it will work. And the new things like the bird question and answer model that you could create kind of before. Here again, you could just create a answerer object and then use it and plug in strings instead of needing to translate the string into a byte array that I often get wrong. I don't know about you in that conversion process, and you could just go ahead and use the model. Last but not least, Android Studio 4.1 ML model binding. So this is something that we've launched on Monday in production. So it's now ready for your production need. It all started when I was trying to build this a Hoi or not model back in DroidCon Berlin. And what I find is I needed a lot of boilerplate code because I need to convert, like I said before, from a type object into byte array before I can use the model. Excuse me. And a lot of the times I get it wrong. And these are real life runtime error that I got when I first tried to implement it. And we thought, hey, maybe we can do something better. So we did. We added metadata into the model. And so we can now use tooling to automatically wrap the model that you have created and allow you to use it very easily in the tooling. And this is what it looks like. So in Android Studio, you can now right-click on the module where you want to import a model, click New, click Other, and then the TensorFlow Lite model. And then next, you'll be presented with a dialog box like this one, where you can select the TF-Lite model. And if you want to use GPU acceleration, you can take the bottom box as well, and then it will import the GPU delegate into your code. And you just need to wait for a couple of seconds, and it imported all the code. In addition, what it does is it generates a wrapper around it, a little bit like the classes that you get, for example, in data binding in Android. Those are hidden classes that basically generate around an asset. And you can then have a look at both what the model color is and what the input and output are required from the model. But my favorite section is down here at the bottom, where you can just copy and paste the sample code and basically get ahead and just go ahead and use the model itself. It's really that simple. And that is Android Studio 4.1. So you can download it at developer.android.com/studio. So those are the three options, and some of you might go, hey, I'm a little bit confused because some of the options are available across all three products. Which one should I use? So let's do a quick compare and contrast. So I've listed all the different use cases down on the left-hand side, and then the coverage of the model on the right-hand side. And I would like to highlight three considerations that you might want to go through. So the first one is around production readiness. So as I've said, things like TF-Lite task library is on a lightly built train. So on the right-hand side is maybe perhaps the least production ready, you could argue, apart from maybe TF-Lite interpreter, which I've shifted to the left because that has been running for a couple of years. And then secondly, it'll be MLKit because it's been running for 2/3 years. And then ML model binding, actually, we've just put it into production. So that's the next one up. And then the one that's the most experimental is around the TF-Lite task library. Secondly, some of you might not want to use Java/Kotlin in your programming, and you want to program on a native coding layer, and you want C++ support. In that case, is the only column that supports that is both the TF-Lite task library as well as the TF-Lite interpreter. Lastly, hardware acceleration. So if you want to run it more than CPU single thread, or let's say if you want to use the GPU or an API, then ML model binding and TF-Lite interpreter are the only one that supports it. Both the MLKit team and the TF-Lite task library team are both looking at including hardware acceleration in future releases. So stay tuned. The next two things is a little bit more subtle that I want to talk about because some of the functionality sounds really familiar, and I certainly have that question when I first started. So the first one is around image classification / labeling versus object detection and tracking. Which one should you use? Because both of them are about pointing your camera in an image and then getting basically different predictions back with a percentage. So why are they different, and what circumstances should you use each one? So let's start with image classification. If the whole image is a scene that you want to classify, so let's say, it could be a landmark, or it could be like, hey, you want to detect whether the scene is a forest or a urban area or indoor versus outdoor, then image classification is fine because the whole image is what you want to put through the image classifier. On the other hand, if you are, let's say, in a very busy supermarket product aisle and you have products stacked right next to each other, and you wanted to detect particular objects that is on the same shelf, then you might want to crop it and limit the area of detection first before you put it through your image classifier. So that's something that object detection works kind of really well. So it depends on the use case here. So if the whole image is a scene that you want to detect, image classification. If it is about a particular product on a row of different products, then object detection and tracking is your friend. Lastly, I just want to highlight there are two ways to do object detection and the trade-off here. So the MLKit way of doing object detection is actually quite different compared to a lot of the ML classifier that you see. So the way that MLKit does it is that it have an object detector up front. And then once it detected that there is an object, it's just generic object, then it runs two things. One is a image classifier. So it is basically the very generic thing that you can train using Firebase ML or the TensorFlow model maker. And then secondly, it also runs a tracker. So that tracker doesn't, again, know what that object is. It just kind of try to track the object through the different frames. And a second way to do that is the ML model binding or TensorFlow like task library way of doing things, which is to detect the object on every single frame. So what is the difference here? The object detector is much more processing efficient, and what it can do on lower devices is because it only runs the object classifier whenever it loses tracking, so you can actually get quite a smooth experience throughout on lower-end devices. First is the single-shot detector, where it is actually quite demanding in terms of processing power. So that's something that to think of. But at the same time, if you have an async, if you're not having a live experience, maybe both of those wouldn't actually make that much difference. And with that, that's the end of my talk, the 4 stage of ML machine learning. And for more, you can find out at this link.
Thanks, Hoi. That was amazing, really insightful. I think we all enjoyed that, especially seeing as machine learning is very important in mobile applications. So thank you so much for that talk. Really appreciate it.
Thank you. And yeah, if there are any questions, just DM me on HoiTab, and I will be able to answer your question. Just type in a little context and just say, "Hey, I saw you at DevFest London." I get a lot of spam, so that would really help me filter out.
Cool. Thanks, Hoi. I appreciate it.
Right.
Thank you.
Thank you so much.
So next we have Jay talking about unidirectional data flows. Now in Flutter uses a lot of state management. So Jay's going to discuss that when you're increasing the scope of a project and increasing the functionality, how can you use different state management techniques to make sure you don't get any bugs or anything like that. So hey Jay, welcome to DevFest.
Hi there. Thanks for having me.
Cool. So I see you host a generic typing show on Twitch. How does that go?
Oh boy. Yeah, I started doing generic typing about 2 years ago when I started Flutter, I guess, a little bit after that. And I just haven't gotten around to getting back into it. But whenever I did stream, it was a lot of fun. But it just takes a lot of time to get started, right? So I do want to get back into it, but I've been saying that for half a year now. So yeah, it's a lot of fun when I do. So yeah, I'll keep people up to date whenever I do something like that again. But yeah.
Cool. I'm excited for your talk.
Cool. Thanks.
Thanks
for having me again. Cool. So let's get started.
Yeah.
Can you all see this? This is good?
Yeah.
Perfect. Hi, everyone. I'm Jay. Today I'm going to be talking about unidirectional data flow in Flutter, and I'm going to be introducing 3 state management solutions in Flutter, sort of as an overview, and then one more specifically. This is an abridged version of this talk because I had to keep it a little bit shorter than I usually do. So a full version of this talk is available at the end of these slides. You'll have a link, and there you can view both this abridged version as well as all the code, both the start and the finished version, slides as a keynote or a PDF or whatever you want. So it's all there. I tend to go a little bit fast through my talks, but this time especially since I had to keep it short. So if you need to rewatch it, or if you want to ask questions afterwards through Twitter or something, that's totally fine too. So first, a little bit about me. Hi again, I'm Jay. I am a software developer and mainly use Flutter and TypeScript. I do full stack development at a company called Very Good Ventures. That's a Flutter development agency in New York. I do freelance work there as well as some other projects here in the Netherlands. I'm an open source contributor. I do a lot of stuff with the community, with the Flutter community, where we have a GitHub where we collect packages and keep them up to date, maintained, and open source. And we have multiple sources for articles and all that good stuff. And I do talks, obviously. So let's talk about state management. State management is sort of a heated topic in the Flutter community. It's always has been from the start. And so there are a lot of different solutions, and I just wanted to go into sort of one direction of the state management landscape as far as Flutter goes. So first off, I think there's this sort of taboo about, oh, you need to use this or whatever. Well, not a taboo, but like everybody recommends something, but sometimes you don't need anything else than what's in the framework. Using built-in solutions is often fine. If that works for you, if that works for the scope with what you're working with, that's totally cool. Don't worry about it. Keep state local and pass it around. If that works for whatever you're building, if it's small or like an MVP or like a proof of concept type thing, just use that. That's totally cool. Now, what I think people can agree on is as soon as your app grows, the complexity becomes larger. And at that point, you really need to think about how you're going to handle data throughout your application, right? You need to think, okay, where am I going to put this piece of data? How are other parts of my app going to access that? And how am I going to make sure that my UI knows about updates whenever that data changes? But you don't want to refresh all the time, right? That's going to be expensive as far as performance and battery life goes. So there are some decisions that need to be made there. Now, in this case, you want some sort of state management pattern, right? A way of nailing down some sort of flow within your application on how to pass data around and make sure that changes are propagated properly. So one of the ways of doing state management, one of sort of as a design pattern or a rule of thumb, one of them is called unidirectional data flow. And the definition of this concept depends on in what context you're talking about it in. So I'm going to be talking about it in the context of Flutter state management specifically. And even then it's still a bit divisive or it depends on the interpretation. But I'll just give you my explanation for what I feel unidirectional data flow has to offer for Flutter state management. So to me, it's a design pattern for state management, as we've discussed before, right? Now, what I like about it is that it does four main things. One, it makes state management, the flow of your data structured, right? So there's a nice rigid structure that will work well regardless of scaling, right? Then it's consistent, so it's easy to wrap your head around usually. Again, this depends on the framework. All of this does, but this is the rule of thumb. It tries to be consistent across the framework, so there's less thinking and less confusion. Then it's predictable, so that means that it might be easier for somebody who onboards to look at examples of how your app works and then extract that into new features. And then it's testable, which is, more people need to do testing, and it depends on the framework again. But usually using a state management approach that has unidirectional data flow in mind might make it easier to test. Now, what this all comes down to is that it will help separate the views or how you present data from how you process it and collect it. So that means that you can separate those. That makes both easier to test and also easier to replace. If you need to replace your view or whatever data you have, then that becomes easier since they're separated, right? Removing one part won't wreck the whole thing. That's the idea. And especially with the frameworks that I'm going to be talking about, it works really well with declarative programming, right? Where you have some sort of state that you pull a function over that maps it to some view, right? Or even just data, right? If you have a piece of data, you have a function that maps it to new data, right? Immutability also comes up a lot in this sort of context. So let me get a little bit more into it. So unidirectional data flow specifically in Flutter. To me, unidirectional data flow has a couple of key aspects that you'll see in a lot of frameworks, especially the one that I'm going to be talking about. So these concepts come back in all these frameworks and they're executed in some way or another. How they execute it is different for every framework or pattern, I should say. But these are the main concepts that keep coming back for me. One is an immutable state, right? So that represents a part of your app or your entire app, right? It's just an object. It can be anything you want, a class or Boolean or an integer, whatever fits your needs, that will represent a part of the UI, right? Or a part of your application, rather. Now, that is immutable, and we'll get into why in a little bit, but that is just an object, some data. That's it. Very simple. Then you have a collection of events. So these are, how these are executed depends on what you do and what the framework offers, right? But events are a way of conveying that an action has taken place, right? So this can be a class that says my counter has increased and maybe has a value that says with how many it should be increased, right? That could be an event or an action. So, but it could also be an enum or whatever you want, as long as it has some payload or data that it tries to represent that an action has happened. Then, third and last, there's a reducer or a pure function. And that is a simple function that takes the state or receives a state rather, and an event and produces a new state. So you never change the state directly, rather you have the state and an event, and this function will take those two and produce a new state. A good example would be the counter again, which is what I'm going to be building in a little bit. So say that you have the state, which is like an integer, for example, and the state is 0 at this point. Then an event comes in and says the counter needs to be incremented. Okay, the event doesn't know what to do, but the reducer does, right? The pure function knows what to do as soon as an event and an action, a state and an event come through. So you have your pure function is run with two arguments, the state, the current state, which is 0, and the event, which is increment counter. You put those two together and the pure function will produce a new state where the counter is incremented. In this case, it will produce 1. And then the same event comes in, and with a new state, 1. Later, when you press the button again, for example, to increment the counter, those 2 come in, and you produce a new state, in this case 2. And you can keep doing that, right? So that's sort of the flow. Let's visualize this so you have more of an idea of how this would work within an application. So you have your state right here. This is your object. It can be whatever you want, right? It's immutable, though. You cannot change this directly. Your state is somehow passed to the view, right? And so the view at this point is only concerned with, I have some data, display it. It's a pure function, very declarative, like we like how Flutter likes to do things. So the state is passed to the view in some way, doesn't matter how, it just gets it, right? So the view has a state and it shows it. In this case, it could be a piece of text that displays the counter, right? Then a button is pressed or something happens within the view that triggers an event. And that event is sent to the reducer, right? So again, the view only cares about, I get a state and show it. Once something happens, I just push an event. That's all the state needs to care about. No managing from like, okay, I need to set state and then, replace this with that. And I need to make sure that other components know about this update. That's not the responsibility of the view. The only thing your view needs to do is have a state, show it, and send events. That's all. Now, the event and the state are both passed to the reducer in this case. How that happens depends on the framework, but in this case, your reducer will have the current state and the event that came through, right? And now, as I said before, your reducer will produce a new state, right? So it will get the event and the state, both current, and then produce a new state. And then that state is passed to your view again. So this is where you get that flow. This is your data flow, and it's cyclical, which makes it really easy to understand. You have a state, is passed to the view, event comes in through the reducer produces new state, and there you go. That's your cycle. So a state object doesn't have a responsibility. It just holds data. Your view only needs to show it and call a function whenever something happens, but it doesn't care what is happening, only that something happened. Your reducer doesn't care what events are there or what the state is, just that an event came through and the state came in and produces a new one. That's all. So that's sort of the flow. Now, there are 3 frameworks or 3 state management approaches, rather, that I want to talk about today that use this approach. 3 main ones for me are, one is Redux. This one is very popular within the JavaScript community, and it's used a lot also in Flutter. I've seen a bunch of projects. I used to use it myself as well. I've sort of grown out of it, but it's a very valid approach still. Then there's Bloc, which I guess is sort of one of the standards these days for Flutter state management, and that also works really well. To me, it's sort of similar to Redux, but it works nicer to me in Flutter because it uses the Streams API a lot. So everything is async, and you don't need to. You can handle async data a lot more better natively that way. That's what I like about it. Now, Qubit is closely related to Bloc in that all blocks are actually qubits. Bloc is just a sort of different execution of the state management pattern, and Qubit does its own things a little bit differently, but both are very valid. I'm going to talk about Bloc and Qubit specifically today, and I'm going to start out with Bloc. So Bloc stands for Business Logic Component, and that's just a very nice and fancy name, and it was based by Felix Engelov. He's a colleague of mine, actually. And so Bloc is really simple. You can use it as a package and also use the Flutter block components to more easily consume blocks and edit them. But in general, you don't have to. Its core concept is very simple. A block is a class containing a state and reducers. That's it. So internally, it has more stuff going on under the hood, but internally, it's just a class with a state and some reducers. It uses the Streams API internally, which means that everything can be async and everything can happen, sort of doesn't need to happen synchronously, which makes it play really well with how Flutter does things declaratively. Then it manages and produces new states internally. So that means that the only thing you have to write is the state and the reducers. That's it. So how these states are passed onto your view, that's kept to Bloc. Bloc does that for you if you use the widgets that are appropriate to it. Then, usually, Bloc will consume events in the form of classes, right? You could use an enum or whatever type you want, actually, but usually you'll have a class that represents an action. And for every action, you'll have a new class. Let's look at an example, like a small example of how you could make a new block. or how you could declare one. First off, I'm going to import the block package. Now, again, you don't need this, but it's very useful to have it. Then I'm going to declare a new class called counterBlock. That's a block that has two type parameters. One is the type of event that it's going to get. In this case, counter event is just another class. And the counter state, which is also another class that in this case contains like an integer, for example, that represents the counter state. And that's your block. Now, obviously, there's more to implement, but this is your initial declaration, and that's really all you need at this point. Now, I use blocks in a certain way or in a certain pattern, and everybody has their different approaches, but I think this is sort of a standardized pattern for how you could use block. To me, it's a best practice. So you can have multiple blocks, usually a lot of them throughout your app, and each has their own scope, right? So what I usually use per screen or per feature, I make a new block. So for example, I could have a block that just represents the state for one screen, for one whole view of your app. Right? And then there could be another block that only concerns itself, not with views specifically, but just with data. So like an authentication block that will keep the current user inside its state. And then whenever you need to have the current user, you just listen to that block or get that block from within the widget tree and then just retrieve whatever information you need. Then blocks can be passed around using block providers that are provided with the Flutter block package. Now, you can have blocks everywhere, right? And you can have multiple ways of passing them around because you need some way to access the blocks themselves. But what I really like is to use block providers, right? This internally uses the provider package by Remy, which is used a lot. So actually, block and provider go hand in hand really well. Same goes for Cubits. Now, let's look at an overview example of block. Sort of like a sketch out version of how you could use block in this case. So let's say in your widget tree, in your example app, you have a material app all the way at the top, right? So this is the base widget of the widget that starts off your application. This is usually what lives at the top. Then further below, but not too far below, you can have a block provider, right? That contains a counter block. So the block provider will construct the counter block, just make a new instance of it, and then provides it to any widget that needs it further below the tree. So you can look it up, just like provider or inherited widget. So it makes the counter block, and then you can imagine, so you have your material app, then the block provider, and then maybe a scaffold with an app bar and the body and the column and all these other widgets in between. And then at some point, you want to retrieve whatever values you need from your counter block. So you can use a block builder for that. Now you have two options here. You can either ask for the counter block by using block provider of and just look up the block from whatever point in the widget tree you want, as long as it's below the block provider. So you can look it up that way, or you can use a block builder. And what's really useful about this widget, which is provided also by the Flutter block package, is that it will look up the closest counter block that it can find, right? So in this case, it's the one provided by the block provider. And then if that counter block state ever changes, your UI will also be rebuilt. So you don't need to worry yourself about calling set state or doing anything regarding rebuilding or checking for updates or subscribing or whatever. You just have a block builder that looks up that block and then rebuilds whenever the state changes. And so that's your reactive part, right? And then from that block builder on, you can have any sort of widgets that you want, right? You could build anything within that block builder. Now, not having too many widgets in the block builder might be nice because you don't want to rebuild like your entire app every time the simple counter changes, but this is the basic structure. Now, Qubit is sort of Block's little brother. Somebody told me actually it would be the other way around because Qubit is actually, all blocks are actually qubits, but to me, it's sort of the smaller brother of Block. So Qubit is the base class of Block, and it's sort of a smaller or simpler form of Block to me. So as I said, all blocks are actually internally qubits, so they share up 90% of their code. It's just that the API is a little bit different. So it's the same concepts, but it's a different execution of those concepts, right? Now, qubits use public methods that are accessible from the qubit instead of classes to convey actions or events, right? The net positive of this is that you don't need to make a new class for every action that you want. Instead, you just make a qubit and then just add methods to it that emit new states, right? So I'm going to try to show you in the little time that I have left Qubit in action, and then questions afterwards or on Twitter and all that. So let's have a quick look, and I'm going to race through this. Feel free to view the code afterwards, but let's have an example of Qubit. So what I have here, this is viewable. What I have here is a very simple counter app, right? That's it. And currently it's not doing anything because we haven't implemented the state management part of it yet. So over here we have the application itself, a Qubit counter example. We have a material app with some theming and a homepage. The homepage itself is a stateless widget. And again, it can be stateless because the widget is not actually maintaining any state itself. Then we have a scaffold with an app bar, a center column, 2 pieces of text. You have pushed the button this many times, which is here at the top. And then a piece of text with, in this case, an ellipsis, but we're going to change that. We want to show the counter here. So let's make our counter block. So I can write the counter block myself if I want to, but I'm just going to use the block Visual Studio Code extension here and select create new qubit. Now I can give it a name. So I'm going to call it counter. Now it says it has successfully generated the qubit. And here we go. Let's have a look. So this is our qubit. That's it. It's extremely tiny. That's what I like about it. It's very simple and concise. So we have a class counter qubit that extends qubit with its state, right? Normally we would have an action or an events class definition here as well, the type definition, but we don't need it, right? Because our events are gonna just go into this class as public methods. That's not an anti-pattern when using qubit. So then we have our constructor, and in our constructor, the only thing we do in this case is initialize it with an initial state. So where does this come from? Well, the counter state. In this case, it has an abstract class as sort of an interface, and then it implements that interface. I'm not going to bother with that for a little bit. So I'm just going to say class counter state is a new counter state. The properties here is just an easy method using equatable, which is another package that is used often with this state management approach. It's just an easy way to make sure that you can easily check if 2 objects are the same, 2 counter states. So we don't need to override the hash code and the equals operator and all that. So what does our state need? Well, in this case, we're going to need an integer, which is our counter. So I'm going to say final integer counter. So that's the counter that we have. I'm going to make sure that counter is part of those properties so that when we compare 2 counter states, we know that they're the same because the counter is the same, or maybe they're not, in which case they're different. Then we need to make sure that this counter is initialized. So we need to put it into our constructor, this.counter. There we go. So now it's happy. Now again, this is final and it's immutable, and that's because our state is immutable, but we create new states all the time, and that's what's being passed to our view. So that's our state. Now our qubit is going to complain because we don't have this anymore, but I'm just going to say our initial state is going to be a counter state. Let's start with a counter of 0 in this case, right? Now, 2 more things, 3 actually, but then we're done. So we can go over here and we need to make a counter qubit and then provide it to some part to the rest of our app. And we can do that. So we have our homepage widget here. So let's make sure that anything below this part in our widget tree can access that counter qubit. How can we do that? Well, with a block provider. And again, all blocks are actually qubits. And so when we use a block provider, which I'm going to do with the shortcut here, it will actually work with qubits. That's what it's asking, right? But it's the same package and it's all called block, but it will work with qubits just fine. So what are we going to provide? Well, a counter qubit. Import that, and I need to import block provider as well. And this cannot be const because of that, but this homepage can. That's nice. So in just, I guess, 3 lines, we have now made sure that we provide a new instance, one single instance of our counter qubit to the rest of our application. Perfect. So now anywhere below this point in the widget tree, we can access that counter qubit, right? So in our homepage, wherever we want, right? So let's save this and then reload. And nothing happens. Well, something happened. A new counter qubit is now constructed, but we still need to show it. So let's do that. So over here, I have the text with the ellipses, and this is where I want to show that counter qubit. So now we're providing that counter qubit to the rest of our UI, but we still need to fetch it. So let's do that. I'm going to go over here and wrap the text with a block builder. So this block builder asks for 2 things, the block or qubit that we want to fetch and its state, the type of its state. We need that to make sure that it's type safe. This is just an artifact of how Dart does the how Dart needs its generic arguments to be provided. So the thing that we want to fetch is the counter qubit, which is provided by the provider that we made before, right there on line 23. And then the state is called counter state. That's it. Now we have the state. This state object here is the counter state. And so now we have that state. So we can fetch it and say state.counter to string. Put the comma there, save it, reload, and 0. Perfect. So that's our initial state. Now I'm going to make it a little bit prettier by using string interpolation here. So I can just do state.counter. And there we go. And so this will rebuild any time that the widget changes or the state changes. 2 more things we need to do. We need to make sure that the button increments the counter, and we need to write that function itself. So let's go over here to our floating action button. And so now we need some way of accessing that qubit and calling a method on it. Now, Flutter Block provides extensions for Dart, which are really useful. So I'm just going to use the extension, in which case I can do context.block. Let's fetch the block or qubit that's closest to this point in the widget tree and say we need the counter qubit. Let's fetch it. So now we have access to our counter qubit from within this function, right? And now we need to call a method on it. So I'm going to say increment. Now we haven't made that method yet, but that's what we're going to do. So this function will call the increment method on the closest counter qubit it can find, which is the same as the one that we are building the state of. So that's the floating action button implemented. That's all this needs to do. So the UI doesn't care what is happening with the state or the block or whatever, just that it's sending an action, the increment action, right? Now, on our qubit, we need to actually add this increment function. So I'm going to do that, which is really simple. It doesn't return anything itself, but it will just, it will emit new states, right? We're not returning a new state. That would be breaking the cycle of unidirectional data flow. This will emit new states, and the flow will be complete. So I can actually reload now, but nothing will happen. But this function is being run. So the only thing we need to do now is, if you check this out, we need to have a new counter and emit that new state. So I'm going to say our old counter is the current state that we have access to. This counter. Then the new counter is just going to be the old counter plus 1. Right, so now we have our new counter, in which case this would be 2 or 1, actually, if I press the button now. And then our new state is a new counter state with that new counter. The last thing we need to do is emit that new state. So we send out that new state so that the block builder knows it needs to rebuild. So emit the new state. There we go. That's the entire thing. So reload, and there we are. So it rebuilds. Perfect. I'm going to make this a one-liner real quick because I like to be efficient. So we can actually just do the current counter plus 1, right? So this does the exact same thing, but it's a little bit shorter. Now notice that emit is does not need to return only once. We can emit as many times as we want, which means that you can emit a loading state, then do all sorts of async stuff like fetching data or updating something, and then emit a new state where you say the data has been loaded, here's the data. And you don't need to manage any of that within your UI. So that's it. And now it works perfectly fine. So that was that. I know I might have gone a little bit over time, but I really appreciate the time I've been given. Thank you. All the code, slides, and presentations, everything is up on cut.ly/JFK Talks if you want to view it there. I'm up on Twitter at JFKDev. If you want to ask any questions, please either post them on Twitter or DM me. Please do say that you come from DevFest, just like Hoi before. That really reduces spam. Thank you very much, and I hope to see you again soon. Thank you. Bye.
Thank you. It was a really good talk, Jay. Really well done. Yeah, now I want to put qubits everywhere.
Thank you. I appreciate it.
No, yeah, it was great. And yeah, like you said, like if you have any question, just ping him on Twitter. There is on the written right now on the stream. So yeah, thank you, Jay. Thank you so much.
Thank you for having me.
Thank you. So now our next speaker, so it's Wajahat. is a GDE in Android, and is the first GDE from Pakistan. I think it's really great. And he's going to do a talk about Compose and dinosaurs, and I love Compose and I love dinosaurs, so I'm sure it's going to be a really great talk. So hello Wajahat, how are you today?
Hello, hello Antonio. Hello Harish. How are you? I'm good. So my name is Wajahat Karim, and I'm currently live from Pakistan, Karachi, and it feels super awesome that during these tough times you can go around anywhere. For example, I'm doing a talk at UK, so I still can't believe it, but it's a great opportunity and great platform. So today I'll be talking about Jetpack Compose and mostly about exploring the Canvas API and how we can actually make games in it. So you might be wondering that why Jetpack Compose and why Jetpack Compose games. So yeah, um, you probably have seen this picture around the internet a lot because it's been circulating on Twitter and stuff. Uh, it was a little hard to make a good demo, but yeah. So I will be talking about this. So starting from Jetpack Compose. Jetpack Compose is a modern UI toolkit which simplifies and accelerates UI development. So you might be wondering that this is UI development and UI toolkit. Then why we are bothering with games anymore in this? Because the whole idea behind Jetpack Compose was about simplifying the stuff on UI development and bridging the gap between XML and Kotlin and providing a more declarative and more easier and more user developer friendly way to create UIs. So everyone was building UIs like YouTube app clone, Android app clone, and that sort of stuff. And there were different kind of menus and buttons and all that. So I was like, I needed something that should be a challenge. Like Jetpack Compose is still in alpha state, so there are hardly any resources and very less resources, and especially about animations and games. So I was looking for a challenge, and I thought, okay, let's see how it goes. So this is where I got an idea that let's build a game. So before that, this guy from Twitter, Alex Lockwood, he done some creating animations and stuff in Jetpack Compose. So I thought, okay, this is good. So games are a little different from our normal traditional applications because they work in a little different criteria, and uh, the biggest advantage in the games you are going to get is that uh, you will learn about how different custom views can be created. I know, Android is very tough in creating custom views, and their API for custom views like on Meijer, on draw, and all that sort of functions make very complex. So Jetpack Compose is actually totally opposite of that. It is very user friendly. It is very easy, especially for creating custom views and custom components. So if you know about Canvas API in Jetpack Compose, you will probably be getting it a more plus point. Like it will be very easier for you to understand that how custom views are built and created. And beside that, who does not love animations? Like animations are awesome, and every app or game should have good micro animation. So Jetpack Compose is good. So this talk is about game, but it will give you some basics and foundation around how you can make it work with custom views and animation. So before that, I would like to start with game development or 101. Like I'm going with the assumption that some people might not be aware with game development, or they have not done it in their past experiences. So this is how a usual game flow is, because software applications or normal app, they are mostly event driven. So that means that if user does not click on button, then app will remain there and it will not do anything. So on the other side, games are a little different, because it does not matter whether you are taking action or not. Games are running, and someone will come up and fire you, shoot you, or something like that. So, yep. So this concept is called a game. So ideally, a game have these all stuff like startup, intro, movie, then main menu and setting, loading, and then game starts. Then there is a intro or backward story of that specific level. Then there is actual gameplay, like you are actually pressing buttons and keyboards and all the things. Then you can either pause, or there is a game over and there are optional outro, and then end game levels or end game. So move on. So the one specific thing from this is game loop. So this is how an ideal game loop looks like. You have initialize and shutdown. Before the game loop, you make sure that which level is in, and you show main menu and all that screens before that. And after that, you exit the application, like show game over screens and stuff like that. This is the game loop. Like I have put it while true, but this will be depending on whether player has died, game is over or not, something like that. So there are four things. Number one, there is process input. So the game runs in a way that it will wait for like 200 or 300 milliseconds, and then if user has pressed any key, okay. If user does not press any key, okay. So after that wait, it will move to next, and it will update the game data, like what kind of change has been made because of the user input, and then it will draw and render it on the screen, and then it will check that whether loop should continue or not, like shutdown conditions and that stuff. So that is simple game loop looks like. So we will try to mimic this in Jetpack Compose and see that how it works. And now one other thing, Compose Canvas. I would like to create some foundation that you now know about game development. So let's focus on Canvas. So Canvas, if you look into the definition of Canvas composable, you will realize that it's a simple spacer, and it comes with like draw behind. So whatever you want to draw, there is on draw parameter, and that is a draw scope method. So normally compose runs on composable. So usually most of the methods are composable, and that's why they are like components. But if you are playing with Canvas API, then your more focus will be on draw scope. So because you cannot put a composable in a draw scope like in a canvas, so you have to create extension methods of the draw scope, like draw my shape. So we'll see. So these are the built-in functions on Canvas API for now. They will probably add more as Jetpack Compose gets more stabilized. So you can draw rectangles, ovals, lines, images, and or circles and arcs and paths, like vector paths actually. And beside that, even you want to create your own custom views or shape, then you can create an extension method of draw scope, like I did that fun draw scope dot draw my shape. So and then you play around with it and create your shape. So this is how Compose Canvas works. So for example, we have this shape view, we have this circle custom view. So let's see, we have this canvas, and we have filled the whole width and height, and then we are creating three different like circles. Circle, this is red one, this is green one, and this is blue one. So yeah, you can create it. Like I have created three circles, 300, 200, and 100 radiuses, and you got your whole custom. And now you can create more stuff with it based on the state and data. So this is how easy Canvas is. It's all about what you can imagine and what you can calculate. So now we got covered with game development and we got covered with Canvas. So let's see that how we can put together a Dino game. So, so basic. So starting from we have X and Y. We have reverse coordinates usually as compared to our traditional mathematics. So this is how screens work. So we have X and Y, and then I have figured out the device width in pixels. So it's just normal way, nothing fancy. Like as we bring the device width from the display metric. So and then I started from the Earth Y. So this is Earth Y. I have set it to 500 pixels from top, but you can do it like on percentage basis, 30%, 20%, and something like that. So yeah, it's not a problem. So this is our Earth Y, and this is device width. And now next. So first one, I started from creating the actual scene, regardless of how animation will work or how Jetpack, how Dino will jump and all that. I just wanted to make a scene of the game. So this is our Earth, like this one. So you can see that I have started from drawscope.attribute. So I have created the different drawscope methods for Earth, for character, for canvas, and I'm going to call them in a loop, game loop, and continue moving it. So this is attribute. So I created one simple line. This is the first line and bold line. So you can see that I simply called the drawLine method, and this is our Earth Y position. And then we have offset of the end is it starts from 0 to this and ends here, device width. So it's very simple. And then I have created. Now this would do my job, but this will not feel like game is scrolling, like Earth is scrolling. So I wanted to create some inconsistency to make sure that users feel that game is scrolling. So it was with the two dashed lines. The only difference is the path effect. You can see that I have added a path effect. It creates a different path. So first line is 20 with 20 pixels line, and then 40 pixels of space, then 20 pixels line and 40 pixels of space. And other one is 15 pixels of line and 50 pixels of space. So this created two sort of random lines, and when they scroll, user feels that Earth is scrolling. The top line remains there, and this does not scroll. So that was Earth. Now I wanted to put these icons, so I downloaded these icons from Flat Icon and Cactus, Cloud, and Replay, and Dino. So so this is where I got stuck in my first problem. That it was that every icon was using its own size. So Cloud was 512 by 512, and Dino was 200 by 200 and something like that. So when I put them all together in the game, everything was totally different. I applied the manual scale on them in the code, but it created problems later. At first it was all okay, but when I was into the Boolean detection, every component was using its own dimension system and one using its own scaling metric. So this created confusion that when dinosaurs colliding with cactus or not. So what I did that I actually resized them all 200 by 200 through this iloveimage.com website. So it gave me all vector resources with 200 by 200. So it gave me, it allowed me to have a single dimension system throughout the whole game, because you need to layer a lot. You need to do some mathematics, and you need to have uniform dimensional system. So now I put this in, and I created vector Android vector drawables. But later I figured that oh, Canvas does not support Android vector drawable format. So probably they will add it later. There are several ways like vector painters and something like that to do that stuff. But I didn't know at that time, and I was like, okay, so there is no vector drawables in Canvas. Then I used a simple old way. Like you can see that we have the path here for every XML and the drawable. So I actually copied this whole path in this one. And it was a little annoying and boilerplate work, but it needed to be done. And then there is a path parser from the Jetpack compose, and it parses the path and gives you a path. So I created a method, cloud path. So whenever I call this, it gives me the characters to cloud path, and I applied a simple basic scale throughout all. So it was done here, like scale matrix, basic scale, and then this gives me. Remember that Android path and compose path are different. So a scale matrix will give you Android path, and then you need to convert that into compose path. Now this is was all done. So all I needed to do was call it in the code. So this is my cloud view method. This creates a cloud, and I call the draw method, and I set it to cloud that path. So yeah, it's that simple. Then I set color is gray and the stroke is 2F. So I have applied the stroke, so this will not fill it and will make it transparent. So okay, so this is how cloud works. And similarly, I applied the same approach for characters and created the characters view and applied the path there. And then I also did that for dinosaur, and there was dino view, and I also gave the path there. And then when I put it in the simple game loop, this is Dino game loop, canvas, and Earth view, cloud view, Dino view, canvas. So this is how it was done. Like Earth is set Earth Y, so that's why it's here. Rest of the stuff is all at 0, 0. So we need to position these items dynamically, and we need to continuously update the position. So this is where canvas transforms comes in. Okay, I'll move to the canvas transforms later. So first thing is that we are here, and now we have to do game loop in compose. So I have worked on game development before, and I came up with some assumption that okay, compose works very good with state changes, and I don't think that we even need a game loop. All we need to do is draw and update our state, and compose will automatically pick it up that state has changed, and it will update the canvas. So as we discussed in our previous slides, that we have update game data, and then we have render word. So we have two methods. So we only do update, render will be done automatically. But I was wrong. Turned out that game loop does not work in compose in that way. You have to figure it out. So I experimented with 4 different approaches, and explained the pros and cons, but I have limited duration, so I have omitted one, and I am only sharing the only method which is very optimal and recommended way in compose. So first we will create animated float value. This will start from 0. This does not matter, it's just for making sure that canvas is updated on every frame. So we'll see that how that render. Then when the Dino game scene compose is active, then I'm saying that animated progress should be animated to 1F, and you can see that I have created infinite here, and this is a simple linear easing, and this will be updated every 1000 milliseconds, that means 1 second. So this is about 1 second, 1 second, 1 second, 1 second. So finally I'll use this animated progress value millis. Now I'm not using this milli variable in throughout whole code anywhere else. This is just a simple variable. And the only purpose of this is that this milli variable is in Dino game scene. So that means the Dino game scene composable will be updated on every frame over and over again. And if I comment this line, then this will only be drawn one time and then it will not redraw again. And we have to make sure that game is running and continuously looping forward. So that's why we need to put this variable. And there will be nothing else. This is just for, and after that I have put more things like this is our game loop. I have said that cloud state move forward. So this is like updating data. Every character is getting moved forward, cloud is moved forward. So every game data changes is here. And then we have canvas, which is actually drawing things. So this is our update game data. This is our render game data. So and these both are in this same Dino game scene composable, and millis is in this game Dino composable. So this will be running continuously. I have set iteration to infinite, so this will be running continuously until this composable does not get destroyed. So now let's get back to our transformation. So transformation allows transformation fixes our problem of that, like everything was at 0, 0. So you can put it. We have 3 transformations: translate, rotate, and scale. So for example, I have applied the transformation in cloud. So we have with transform method, it accepts multiple transformations or single transformation. So you can apply translation, rotation, scale at the same time, and then I have for now applied only translate. So this will be the like left and down. So you can see I'm picking up the position from this state, and these positions are getting continuously updated. We will look into that next. So now this made our game scene. Now we are going to focus on animations and crawling. So idea behind is that I created 2 earth position. Sorry, this line was not intended. Okay, so we have one red line and we have one green, and both are the device width. So at any time, user will be seeing any one line completely. So as green line is out of the screen, then it moves back to here, and it will follow the red line, and as red line is here, then it will move back to here, and the 2 lines will be overlapping each other, like continuously following each other. Red before green, green before red, red before green, green before red, and user will only be seeing this part, so you will never know that what is happening after line is crossing from the screen. So this was a simple technique to create a crawling earth. So let's see, 2 blocks chasing each other. So I have created this is the earth state move forward method, and I have set end position. End position is current position and with size. So this is where actual Earth's X position is continuously decreasing. So I have implemented this variable speed. Speed is like 3 pixels or 4 pixels or 10 pixels or 20 pixels. And then when the first block is out of the screen, like Earth offset is 0, then it will again move to the end position. So it's all about mathematics. Now we are going to move cactus and cloud generation. So now you understand the basic. We have move forward method for each state, clouds and earth and cactus and dinosaur. So it will update the data based on the. So we have this similarly clouds X speed, and if cloud is out of the screen, reposition it at the start, like behind the screen again, and then it will again move. So and cactus is also working in a way, but I had to adjust some setting to make sure that there is enough distance between cactuses to dinosaur jump. Otherwise, game will be too difficult and impossible to win. So yeah, you have to make sure that this does not happen. So Now I needed to make a jump. But before that, I needed to tap. So my whole canvas was this one before, but then I put it in the column and I added a clickable, and indication was null because it was creating a ripple of the whole screen. So I didn't wanted that. So and in that click, I created that if game is not over, then okay, we'll jump. So now what this method jump does, this does first this makes sure that dinosaur is on Earth. So dinosaur's Earth is same as Earth Y position, and then it makes sure jumping is true, and it adds a velocity. Velocity Y is like a push. So okay, you are going with push. So it adds a minus 40 unit, whatever you want to call it, Newton or whatever you want to call it, minus 40 of distance to the Y, and then I have also set the gravity to 3. So now what will happen that it will start moving up until minus 40, but at the same time gravity will be added. So at first it will be minus 40 plus 3 minus 37 minus 34, so similar. Once it reaches 0, then it will start come back again 3 6 and something like that. So I could have created this other way, but this gave a very good awesome effect, like it made it look like dinosaur is actually jumping. So and once dinosaur is on Earth, then gravity is 0, push is 0, and jumping is 1. So this was an interesting experiment that I wanted to create running for the dinosaur. So what I did that instead of one part, I used 2 parts, 3 parts. So for every dinosaur keyframe, we have different parts, and I created a list, parse list, and then a keyframe. Then we have this old part variable, and it will look like that which keyframe is currently active, and it will give us the related path. So I'm then calling this change keyframe, and every step there is new keyframe, and it looks like dinosaur is running actually. So we can add more inside this. Now this was a challenging one, bounding box. So the bounding box, I needed to create a Boolean detection, and before that I wanted to make sure that I know that what kind of rectangle bounds I'm dealing with. So I created this dry scope custom method bounding box. It creates 2 rectangles. One is outer and one is inner. So Boolean detection is actually happening on the inner to make sure that there is a benefit of doubt and there is a little playability inside the game. This is a common practice in game development, but it will look like that we are following with outer. So dinosaur, if cloud and if cactus and dinosaur are on the outer, then the game will not be over. Game will be over when inner circles are colliding. So there is a method deflate which gives us that. So in the game, I actually created this there is a outer line and there is an inner line to see that what is happening. And I call this draw bounding box in every dinosaur, cloud, and all to see that how they are being drawn and what kind of rectangles they are using. And it was very helpful. It was very helpful in debugging, and it played very nice. So on that end, now all I have to do is, this is our game loop, will be continuously be running until game is not over. We don't need any while, because this is already in a Dino game scene composable, and it will be running continuously. So only one if else will work. So this is where every game data is being updated in course and forward, earth, cloud, cactus, and this is where collides are checked. So I am grabbing the whole cactus list and see that whether deflated inner bounds are actually overlapping with each other or not. This is overlap method, and this makes sure that overlapping is happening. And once that's done, your game is over. So It was that simple. Scores are very easy. I have added high score text with composable, and in that I just made sure that make a text high and keep increasing it on every frame. So it was simple one. And similarly, game over text view, I created a game over text view composable, and I put it inside here like. I made a condition that if game is actually over, then draw the, you know, uh, game overview and the replay button, and once that button pressed, then game is for initialized over again. So, yeah, it was this one. So we actually played with canvas, game loops, and vector paths, and how we have managed the whole state behind this, and why bounding box actually works. And thank you, DevFest, for having me here. Thank you, you awesome folks, for listening me here. I really appreciate it. So you can see the whole code at this repository, Redux 3/Dino Compose. I have also recently added dark mode, so you can see the code and play around with it. And please follow me on Twitter and check my website. Thank you.
It was a great talk, Wajahat, because you combine Dino and you combine the Jetpack Compose. It's really interesting. So it's kind of like you are developing the game for Android. Amazing. Thank you for the talk today, and hope to see you in our next event later. Thank you.
Okay, thank you. Bye bye.
Goodbye. So now it does feel like we need a coffee, doesn't it? Cool. So we will be going on a coffee break around 2015. We'll come back again and we'll have a few sessions after that. So keep in tune. We'll see you later. Bye bye.
Hello, everyone, and welcome back. This is George from JDG Leads, and welcome back to this year's DevFest. So we got a couple of more talks coming along, but before we do that, I'd like to remind everyone to share everything they want on their social media, just using our official hashtags, DevFest and DevFest UKI. Having said that, there will always be prizes, so remember that and feel free to share anything you want. Moving along with the agenda, we're going to be starting with Carlos talking about how we can do Kotlin throughout Android, iOS, and web, which is a true multi-platform triathlon.
And the second session will be about, Ashita will be talking about how you can navigate in the journey from the package discovery to the publishing and beyond.
And then we're going to be talking about how we can get users' feedback using InAppReview API by Nav Singh. So without further ado, let me introduce you to Carlos. Carlos comes from Portugal. He is he's an Android lead on WIT software. He is the founder of JDG Coimbra, and he's also an author for Medium, Ryan Wendrick, and which one was the other one?
Opinions Online.
Yes,
Opinions
exactly.
Online. It's a Portuguese tech blog.
All right. So hello, Carlos. How are you?
Hello, I'm fine. How's everyone on the other side of the screen?
We're great. We're great. So yes, we can see your screen. So feel free to move along and talk us through your yeah.
Okay, thank you. Thank you for this great presentation. Let me start by thanks to everyone that's on the side of the screen. I know this is a Saturday and we're living such difficult times, so thank you for taking the time to assist to my talk. I also want to thank the organization. It's amazing to see how many parallel tracks we have. We have a lot of amazing talks. I've been watching a couple of them this morning, and it was difficult to select which ones I wanted to watch because there were so many. I need more monitors. So before I start, let me just give a big round of applause to everyone. Thank you. It's nothing weird to clap on an empty room. You can find me on Twitter at @CFonsMota. I tweet a lot of things about Kotlin, about Android, about photography. Everything that's here, it was already said by George, so thank you. I can only add that I have this big dream of one day do a podcast, so if is anyone out there that also shares the same dream, ping me at the end and let's create one. I also love to travel, photography, and running. I've created a set of materials for this talk. You can find the slides on my speaker deck. I will tweet them at the end of this talk, don't worry. I also created a sample project that you can find on my GitHub, and I've created a code lab with step-by-step on how you can create a multi-platform project. I've also added a section on how you could migrate your existing project on Android and iOS to multi-platform. So feel free to check this code lab. I think this image sums really, really well how we can develop for mobile. On the left, we have this amazing castle, but before we reach that castle, there is a long path away. It's a complex one. We have to maintain two applications. We have to build two applications on different platforms. Although when you achieve that, you can have those beautiful animations, you can have a smooth experience, you can have the best experience possible. Or you can do it on the right and you can really fast create an application by using hybrid or cross-platform frameworks. But in the end, you have this house that we don't know how long it's going to last, but it's there and you can use it. Let's talk a bit about cross-platform and hybrid platform solutions. We've been seeing them since 2006 with PhoneGap, and throughout the years, we've been seeing new frameworks being launched. We saw Xamarin, RubyMotion, Ionic, NativeScript, React Native, Kotlin Multiplatform, and I'm saying inside quotes because it's not a really cross-platform solution, as you're going to see, and more recently, Flutter. Of course, that all of these frameworks have clear advantages. Nowadays, if you want to develop for native, you need to have an Android team and an iOS team. If you're going to use one of these solutions, you basically only need one team because you're going to reuse the code. With this, if you could have someone from Android and someone from the iOS, I'd really advise you, because sometimes you need to develop some native code, but it's not mandatory. Also, since most of these frameworks are web-based, if you're coming from web, it's fairly easy to adapt to mobile by using, let's say, React Native, for instance. With this, it means that typically it's half of the cost of doing things native. It takes you less time to build, of course, to test, it's a single code base, and hopefully to fix issues. Although there are a lot of disadvantages, and for me, this first one, it's the worst. This happened to me in the past. When you're using one of these frameworks, you're chained to the framework implementation of the UI. This means that you're going to use the framework widgets, and they will run on your device. A couple of years ago, there was a huge redesign on iOS. Sorry. And when people updated to the new OS version, basically all the native components changed. My application, when people were running on their devices, were still looking old. It was still using the widgets that Xamarin built at that time. I needed to wait for 3 or 4 months before I could rebuild my application, submit it to the store, and people download it. Well, I lost a lot of users during that period, as you could imagine. It also means that the users that didn't update the OS, they were using the new application with the old operating system. So it's still not a good experience to not have things as they should be. And I was thinking about this presentation, and a couple of days ago, I noticed this. This is the Instagram app that's going to share on Facebook. Did you saw the spinner? Let me move this again. Let's look into attention. Do you see that spinner on the side of that dialog? This is like Android 2.1 or 2.3. We're talking that Facebook is using some old widgets. They didn't update it, or perhaps no one created the new ones. And this really gives your application an old look, and it doesn't show you consistency. Of course, this is always arguable, but performance, it's not the same. You have a layer in between. Sometimes you need to write native code. If one of the platforms doesn't support a specific feature, typically these frameworks won't implement that feature. Flutter is not, or in this case, Dart, it's not a widely language for now, a used language for now. It's gaining a lot of attraction, but it's not, let's say, as trending as Kotlin, for instance. And you're committing your project to a framework or to a language. For instance, let's imagine that you are going to work on a 5 or 10 year project. What will happen to that framework after these 5 or 10 years? Are you still going to have that framework? What happens if the framework stops launching new updates? You're going to rewrite the entire code? I'm not saying with this that you shouldn't use these frameworks. I think this depends a lot on the project at hand. If you want to build a proof of concept, an MVP, these tools are great. But if you're thinking long term, in my opinion, you've got better tools. So what about Kotlin Multiplatform? I said between codes, this is not a really cross-platform solution because the Kotlin goal is a bit different. Kotlin doesn't want to share the entire code. They want to share the application logic. So they leave up the UI to be developed natively. You're going to have your network, the parser, unit tests. All this logic can be shared across different platforms, but UI should be developed natively. Being said, I already saw a couple of projects with Flutter on top, with Multiplatform as business logic and Flutter on the UI. I've tried it. It's a bit difficult to have everything together, but it's possible. So we're talking about the disadvantages of cross-platform solutions. So this no longer applies. You're going to develop the UI natively. Once again, a new update appears. If you're using native components, they will be updated. Always arguable, but you're leaving everything to the UI, so performance will be the same. We'll have a bit more compile time, especially in iOS, but the people on JetBrains are going to fix that every time soon. You're going to develop the UI. You have access direct to everything. Doing this on the shared model will take you a bit more time, especially on the beginning. But it will these extra efforts is going to compensate. Also, we're going to talk about one of the most trending languages nowadays. Kotlin is amazing. Kotlin is here to stay, and Kotlin is supported by JetBrains and even Google on Android development. So there is a push on two big companies on the language. So you decide what you want to share. Since you can select what your business logic, you can start small. My advice is to start small. I started on multi-platform the same way that I started when I moved from Java to Kotlin. I started with creating a unit test for a new feature. I then started creating the network for another feature that I needed to develop. And then I go step by step until I had an entire feature built on multi-platform. It took some time. At the time, Kotlin multi-platform was still experimental, but I managed to have everything together with lowest risk possible. I didn't revert anything or change to the native implementations. It's interoperable. You've got on server, web, Android, native desktop. You've got in every platform. You've got consistency with this, since we're going to develop things and share it across different platforms. No longer the discussions where someone decided to make a server request and implement a cache mechanism or discard successive requests. Now you're going to have the same logic on all platforms. This also means that if you add a bug to your code, you're going to have the same code bug on all the platforms. But let's see the cup as half full, and if you fix that bug, you're going to fix the bug on all platforms. So that's great. There is a strong investment from the JetBrains and the community. If you have any question, just go to the Kotlin Lang Slack. Everyone there is really friendly. They're really a good community. I've lost the number of questions that I've asked there, and in a couple of minutes or hours, someone from JetBrains or the community asked them and helped me moving on. This is always a question that I hear quite often. There are applications in production with multi-platform. This slide is from last year, Kotlin Conf. We're no longer experimental. A couple of weeks, 1 month ago, moved to alpha, so we're almost there. JetBrains Space, it's full Kotlin multi-platform. Cash App, there are the people behind SQL Delight, share their business logic. ENXMap share the business logic and wrappers for C++ libraries. PlanGrid shares business logic, sync logic, management, offline data. Each one of these applications share what makes sense for them. So this is the big advantage of multi-platform. You can share across platforms what makes sense for your app, and you can start small without big rewrites and then move on. So this is a triathlon. So we want to target Android, iOS, and the web. But let me first tell you what multi-platform is when you use Kotlin in projects that target more than one platform. Let's imagine this example. We want to build an Android application. So we start by adding a presentation layer, the model, the parser, a network, and then we're going to implement the views. And if you want to target the same application for iOS and the web, we're going to do exactly the same things. But this part, this business logic, could be common, could be shared. And this is what we want to do on multi-platform, right? So how can you start develop for multi-platform? You can use IntelliJ, or you can use Android Studio with this Kotlin multi-platform mobile plugin. You can install it. You just need to go to Preference, Plugin, Marketplace, and search for Kotlin multi-platform mobile and install this plugin. You'll need to reboot the Android Studio, but there's no problem in there. Of course, if you're doing this, I also advise you to use Xcode. Although you can do everything from the Android Studio, you can compile iOS now with Android Studio with this plugin. But honestly, and this is my personal opinion, I still like to use Xcode if I want to build something for iOS. I have the syntax I like, the autocomplete works way better on that IDE. But we're talking about compiling for different platforms. How does this work? There is a lot of platform-specific code. For instance, on Android, you've got the shared preference, but on iOS, they're called NS user defaults. So do I need to do something like if Android use shared preference, I'll see if iOS use NS user defaults? How can I expect platforms to communicate? So it's exactly this. You use the keyword expect. you use the keyword expect on a common model that contains all your shared code, and then you're going to use the keyword actual on your platform-specific code. Let's see an example. Imagine that I want to show a message saying, hello, Android, and by Android, I'm going to use the device name, so hello, Pixel. On iOS, I'm going to say, hello, iOS Simulator. On the web, hello, Chrome, for instance. So we first start by saying that on our common main, and if you see here, I've got it underlined, it's inside a shared folder, a shared directory. I'm going to say that I expect someone to define this. And if I'm targeting Android, iOS, and the web, as soon as I create this class, I'm going to see an error saying, okay, you're saying that you expect someone to define this, but there is no actual. And you can press Alt-Enter and it will automatically create all the classes. So now we've moved from the common main to Android main, and we're going to say what actual really means. And in this case, you can see that we're using the Android SDK, so we're accessing the build and getting the manufacturer. And we're going to do the same thing for iOS. In this case, we moved for iOS main. Everything is inside the shared directory. In this case, we're going to use UI kit UI device. And since we're also targeting the web, we're going to use the navigator and get its user agent. And then we're going to compile the app, and we're going to run it everywhere, and we're going to have hello, and then we're going to get the name on each platform that's going to be different. If you look at the project's If you look at the project structure, you're going to see something similar to this. You're going to see this shared, where you've got your common main, Android main, and you're going to see an Android app, iOS app, and web. If you look at Android app, it's what you're already familiar with. We've got source, main, Java, or Kotlin, the package name, the activities, and then your code, your Android code. If you go to the iOS app, you're going to see your Xcode Swift code, and if you go to web, your web code. So on shared, you've got the common main that we already saw, Android main, since we're targeting Android, and of course, since we're targeting iOS and GS, we're also going to see the iOS main and GS main. So let's get everything together. And how can we put everything under the same block? So if you're already familiar with the Gradle system, first you need to define the common main on source sets. In this case, I'm going to define all the libraries that I'm going to use. So I'm going to use Ktor, Kotlin X serialization, Kotlin X routine, SQLite for database, and multi-platform settings for shared preference and NSUSD defaults. Now I want to target Android, so I'm just going to add the Android here and saying which dependencies the Android has. Now I'm also going to target iOS, so I need to define also the iOS, and in this case, I've split them on two. If I'm targeting to the simulator, I want to use iOS x64. If I'm compiling for the smartphone, I want only the ARM64 framework. I also have integration with Cocoa Pods. If I want to use some kind of library, I can just add pod name of the library and it will automatically be installed. Here are the dependencies for iOS main. And if we go to the GS, for the web, we just add GS and say the dependencies for the web. So briefly, we're going to have the common with everything that we expect, and then actual on each one of the platforms that will generate the code that we need to use on the application side. So are you ready to see some code? So let's stretch a bit. So this is the application that I've built. It's just going to fetch all the conferences that we have nowadays about Android, and it allows you to select which ones are online and which ones aren't. So I've built this business logic, and then I've implemented the UI for Android, for iOS, and for the web. And I think from this screen, you can see that I'm no web developer. So this is really rough. So if you want to improve this screen, please make me a PR with some cool UI that I can demo here. I promise to give thanks to you. So basically, what we've done here is that we're going to use the UI that you're already familiar with. We're going to make network requests, parse these responses, study them locally, and use system preference to save the user intention of showing online or not. Typically, on Android, for database, we're going to use Home. For iOS, you'd use Core Data. retrofit for requests, Alarm on Fire, Gaze and JSON serialization, MVP, MVVM, RS, Java, RS Swift. And if you go to the web, well, I tried to talk with some people that are web developers, and this discussion was really big. They have too many frameworks. So let's say something like Redux, Fetch, JSON API Serializer, etc. But what's really different here, it's the UI that we want to develop. So in Android, you have activities. On iOS, you have the UI view controller. On the web, we have a lot of things. We have components. We have really a lot of things depending on the framework that you're using. So if you look at our application, what we want to use, it's Ktor for network, Kotlin serialization for parsers, SQLite for database. We've got our model, our get conferences, our presenter, our platform-specific code. And if you already saw some of my talks, you saw that before we had HTTP client engine here. Nowadays, you don't need it with a new release of Ktor. So this is done for you. And then you only need to implement the presenter and the view on Android, iOS, and the web. Let's see a quick example on this. So first, we want to make a network request. For this, we're going to use the HTTP client that we've got from Ktor. I'm going to make this request on a URL, and this is going to make a request to a GitHub gist that I've created. And typically, I would say instead of client.get string, I would say that it would be the conference object. Unfortunately, when you're making the request to github.gist, the content type is text plain. So I will receive a string and not a JSON, and I needed to make this JSON serialization afterwards. So I'm going to make the get for this URL. I've got my data object here, this conference that is going to have the name, the city, the country, the date, the log, website stats, everything about the conference. And now I'm going to make this call. So I've got my get conferences that's going to receive the conference API. And as you can see here, I have an on success and on failure that's going to be called when I'm able to get the conferences or not. So I'm going to call the previous method, fetch confs. That's going to make the network request via HTTP client. And then when I receive that response, that once again, it's going to be text plain. I'm going to decode it from string with JSON, and I'm going to have a list of conferences. Typically, this should be done on the side of conference API, but once again, since this is text plain, I needed to do it here. Since we only want a list of conferences, we're going to call on success with this list of conferences. If for some reason this didn't work, you would have some kind of try catch, and you can just on catch call on failure with the error that you received. Now let's get over to the presenter. So here it's the presenter defined. And if you see, I have an iConference data here defined. This is the interface, and this is what the UI needs to implement. So basically, I have just two methods: on conference data fetch that receives this list of conferences, and on conference data file that receives an exception. The UI will implement this. Basically, when they receive the list of conferences, they will call submit list and update the UI with the new list of conferences. If we get back to this conference list presenter, basically this fetch conference list will call the get conferences that we saw before, and we'll define that on success means that we're going to call on conference data fetch from the interface that we've received. Having the same logic, on failure will call on conference data file. Now we need to go to the service locator and define a variable that the UI can call. So we're going to first initialize the conference API, which contains the HTTP client. We're going to create a get conferences that's going to make the request, and then we're going to create the conference list presenter that the UI will access to call attach view. Now let's move on to the UI, and I'm going to show you the Android one. So we are on our main activity. This is general activity code, and you can see here that I have my presenter defined by just calling service locator.getConfsPresenter. I'm going to call attach view, and when this information is available, on conference data fetch is going to be called. And in this case, I'm going to update my recycler view, my adapter, with these new items of conferences. The same thing is done on iOS side and on the website, and this is how you can achieve multi-platform. So multi-platform are still an alpha. You're going to see this message a lot of times. So take special attention when you're going to make some updates. I recently, the project that I'm using have all the libraries updated, so you can start from there. But if you notice there is one or two libraries that are using the latest version. This happens because, for instance, if you use the native MT2 of Ktor, you won't be able to compile your web project. So you need to be special careful when updating a library when you're targeting a lot of platforms. Start small. Don't try to reach 100% of shared logic. Start by creating unit tests. By when a new feature appears, you try to do it on multi-platform. Try to share some common code like an image processor, network requests. And you can spend some time resolving compilation issues. This is the worst part here, but it happens. Sometimes you spend a bit countless hours trying to solve these issues, but once again, you always have the Kotlin link Slack, and you can ask them if anyone already saw the same issue that you had. How to evangelize the iOS team. I think it was Kevin from TouchLab that said this once, and I used it and it worked. That iOS people don't like core data. They are really painful about core data. So you can just go approach them and tell, oh, you know, core data, we have a really good solution here called SQLite. Do you want to try it? This will solve all your problems, or at least a big part of your problems. I made this exercise by creating a sample project that I wanted to create, and then I asked a friend from iOS to implement it. And he was really happy with it because he could just focus on the UI. You know that he would call that method and he will get that information, but he didn't care that he was receiving what was happening before. If we are processing that data, if we're using cache, if we're discarding events. No, he knew that when you call that method, he will receive that information. So he could just focus on what you like, that was building the UI. Once again, Kotlin multi-platform is not intended to share the UI. You should use it natively. You can now debug it from Android Studio with the KMM plugin. There was also a really good plugin from TouchLab. The community is really strong here. There are a lot of people using Kotlin nowadays. Google and JetBrains are pushing it. And you can always go to the Kotlin link Slack, of course. If you compare with native, where you need to do two different applications, here you're sharing the business logic. So you've got probably half of the time needed to implement an application. If you add web here, I'm not going to say that it's 3 times less, but it's like 2.5 times less. It's also faster to write unit tests because you're going to write them only once, and it's one tech stack. You've got consistency across platforms, and this is really important nowadays for users to have the same feel, to have the same behavior, and they don't report you issues on why iOS or why an Android it's better than iOS. It isn't. I'm an Android developer, so I needed to say that Android is better. A couple more information, libraries that I'm using. You've got all of the links here. These are also some cool projects that you need to follow if you want to know more about multi-platform. There is John O'Reilly as the people in space. This project is really, really good because it's targeting all platforms, even as WatchOS. So look at his GitHub. And some more useful links. We had the Kotlin Days this week, and there was a lot of good conference about Kotlin multi-platform. So you can see that JetBrains is really trying to push and making all the efforts on the multi-platform. I advise you to watch at least these 3. And I've built a code lab where you can go step by step to create your multi-platform project by creating a logger where you're going to use the log, util log from Android, and you're going to use print from iOS, and you're going to use the console from the web. So feel free to check it. Also, after creating the logger, you have the network request, starting locally, multi-platform settings, using the time library, and migrate your project to multi-platform. And here I've got a couple more links on how you can access all the source code that I've explained here, my slides, and this code lab that I've created. I hope you've all enjoyed this talk.
Cool. Thank you, Carlos. Carlos, that was a great talk, I can say, because when a product you want to do a lot of things, and in between of the development you realize, okay, this tool is not working for you. Maybe Kotlin multi-platform can help us to remove those impediments. So it was a great talk. We enjoyed it, and I hope you enjoyed it too.
Yes, it's always a pleasure to talk about multi-platform, especially now on UK and Ireland. So thank you for having me.
Yeah, thank you. See you later. Bye-bye.
See you later. Bye.
Bye-bye. Cool. So our next talk, let me share my screen, is about Flutter. So what we're doing is, let me getting in the Flutter. Let me add Ashita here. Hi Ashita, how are you?
Hi Mamta, hi.
How are you doing? Good?
Yeah, I'm doing great.
Ready for the talk?
Yeah.
Cool. So before we move on to the talk, let me introduce Ashita and what she does. So Ashita is a die-hard Flutterista. She is a creator of the Flutter Gems. It's basically a curated Flutter package, which is trusted by more than 7,000 Flutter developers. I think she can introduce that a bit much more better than me. But seems like she's a lot deep into the Flutter, so that's a good thing. Cool. So great to have you here, and best of luck for the talk.
Thank you. So, hi everyone, I am Ashita, and today I'll be talking about how one can navigate the Flutter ecosystem, starting from package discovery to publishing and beyond. So, before we delve into today's talk, I would like to give a brief introduction about myself. I'm a consultant by profession and a product person at heart, and I'm also the creator of Flutter Gems. So, let's start with a brief overview of Flutter for people who are new to this technology. So, Flutter is Google's cross platform UI toolkit. With a single source code base, you can ship your apps across desktop, mobile, and web. For mobile, you can build your apps for both iOS and Android. In case of web, you can seamlessly access your apps across all major web browsers like Edge, Safari, Chrome, Firefox, and Opera. And for desktop, you can build your apps across Windows, Chrome OS, Mac OS, and Linux. So, what happens is when you have a single source code base, it results in faster development. And Flutter also has this awesome feature called hot reload, which is very important while debugging, and it greatly improves the developer's efficiency. Now, Flutter has a vast library of widgets, and it enables us to make expressive and beautiful UIs. And as we all know, UI is one of the core strengths of Flutter. Now, unlike other cross-platform UI toolkits, code in Flutter is directly compiled to native code, which results in a faster performance. And Flutter is based on an easy-to-learn Dart programming language, which was also developed by Google. So Flutter is relatively young. It's just been 3 years since the first alpha release of Flutter. And in such a short span of time, it has completely taken over Google Play Store and the entire app market as such. Just in April 2020, we had 50,000 apps on Google Play Store. And in the next 3 months, that number rose to an overwhelming 90,000. Flutter is becoming a preferred choice for startups, small medium enterprises, and large scale businesses alike. Now, to show you the power and scalability of Flutter, let's explore some real world examples. So, Dream 11. So, Dream 11 is completely built on Flutter, and it is India's biggest fantasy sports platform, which is currently sponsoring India's biggest sporting event called the IPL, and it boasts of 100 million users. So you can just realize how scalable Flutter is. Google Pay. Now, as you must have heard recently, Google Pay entirely migrated to Flutter. Now, what made them choose Flutter was because once you write a single source code in Flutter, you can easily deploy it across both iOS and Android, which basically helps in giving the customer a unified experience across both the platforms. JIT compiler with hot reload enables rapid iteration on UI, which makes a developer really efficient. And ahead of time compilation ensures a high performance deployment. Now let's move to the smart apps category. Philips. So Philips Hue is one of the most leading apps in the smart apps category, and Philips chose Flutter. So what made Philips, like a large scale business like Philips, choose Flutter for their development? The reason is Flutter has a vast number of packages which enable functionality such as Wi-Fi, BLE, Bluetooth, NFC, and beacon. Now, because of this, Flutter is one of the leading choices when it comes to making IoT and smart home apps. So Flutter is much more than just an engine, a set of widgets, and some tools. It includes a large ecosystem of packages which add functionality to your apps beyond what comes out of the box. Just Dart and Flutter itself have more than 12,000 plus packages on PubDev. And maneuvering this vast landscape to find the right package for your requirement is often a daunting task. So to understand this dilemma better, let's undertake a developer's journey through a demo app named Street Artist. So how does the developer begin his journey? He begins his journey by gathering requirement. And we all know that a picture is worth more than 1,000 words. So he first tries to make a crude mock-up of the requirement. Now that can be done either on a pen and paper as shown here, or using wireframing tools, you can do it on a computer like shown on the screen. So as you can see, you have a pack of cards with an image and a location. And when you click on the image, it expands to a full screen. So thanks to material design specifications, we now have a formal language for expressing the UI elements. So the first step for the developer is to try to figure out what those UI elements he'll need. Say an app bar or a navigation bar or a button. And these material component widgets have already been implemented in Flutter. So these widgets are readily available in Flutter like app bar, grid view, card, image, etc., which you can directly plug in and use in your apps. So using this, he comes up with a first iteration of the app. So as you can see, you have cards, pack of cards with image and location on it. And once you click on the card, if you click on the image on the card, it takes you to a full screen. But if you observe carefully, the aspect ratio of the image on the card and the aspect ratio of the image, full image that is displayed, is not the same. So let's check it out again. The moment you click, you realize that the aspect ratio is completely mismatched. So what will be a quick solution? A quick solution will be to fit these cards, to fit the images inside the card. So if you see, the entire image has been fitted in the card image. Now what this is resulting in is an improper utilization of the space. And it is definitely hampering our visual experience. So let's check it out. The entire image is fitted, as you can see, and a lot of space is being wasted. So what will be a good solution? A good solution for this will be to maintain the aspect ratio of the actual image and the card image. So as you can see, the aspect ratio has now been maintained. But what this results in is we do not get a uniform grid anymore. It's a clustered pack of cards on the screen, as you can see. Now, the moment you get such a UI, you don't know how to express it in words. And then begins what we call the hunt, how to express the required widget in words. So the first basic step for any developer is to go and try to search on PubDev. Now, PubDev is completely text-driven, which makes it really difficult for us to come to our required package. So before we understand why we cannot get our required package on PubDev search, let's take a step back and analyze how search at PubDev works. So packages can be sorted based on search relevance, that is text, the text that you enter in the search bar, and they are sorted based on individual package scores. Now there are three parameters which determine the individual package scores. First is likes. Now this is a measure of how many developers like your package. Second is popularity, which is a measure of how many developers are actually using your package. And third is pub points. Now pub points is more of a quality measure, which is based on various dimensions like documentation, code style, platform support, and maintainability. Now, when you don't get your required package on PubDev, you go on various forums which are on the internet and you try asking help from the community. You post pictures and you wait for people to respond. You might get your package in this way, but the cycle is usually quite long. And often developers do not have so much time. So what if I tell you that there is a visual discovery platform to aid you in your hunt? Because as we all know that a picture is worth more than 1,000 words. So this is where Flutter Gems comes to our rescue. Flutter Gems is a Flutter package landscape guide comprising 1,500 plus neatly categorized, useful and popular packages which are based on functionality. You can head to fluttergems.dev to explore the platform. So there are various categories, as you can see: user onboarding, functionality, UI, and various components like various scrollables, etc. So now let's take a step back and try to analyze our grid problem. So as you remember, we had a clustered pack of cards and we wanted to arrange them in grid. So let's see how Flutter Gems will come to our rescue. So if you can see, there's a grid category on Flutter Gems. The moment you click on it, you will find 4 packages. And if you look closely, Flutter Staggered Grid View is the exact package that we were looking for. And the entire process of finding your package is so seamless when you use Flutter Gems. Just a glance of 10 to 15 seconds and you exactly know what package you were looking for. So let's go ahead now. As the app starts evolving, so do the requirements, like geolocation picker, like an icon switch, as you can see, a clustered map view, an animated floating action button menu, as you can see on the screen, and a social media reaction button. So let's see how we can use Flutter Gems to achieve all of these features. So if you can see, you can go to location, place and address picker, and Google Map location picker was the one that we were looking for. This is the location, place, address picker, and Google Map location picker, we were looking for it. If you go to geolocation and maps, you can see that Flutter was the package that you are looking for. For the clustered map view that we were discussing earlier in the icon switch, you can use Flutter package to achieve that. Now, third, floating action button. You can see that animated float action buttons is the exact package that will give us what we were looking for. And for social media reaction, Flutter reaction button package comes to our rescue. So now let's take a step back and try to understand the product development journey as such. Now, product development journey is not a straightforward linear process. It is not something where a product manager will come and give the product developer a requirement and the developer is just going to develop it. It is a collaborative effort. Say you as a product developer are glancing through Flutter gems and you realize that a new category of UI has come up called neumorphic UI. Now you realize that your app is better suited to use this kind of a UI, or maybe some components are better suited for a neumorphic UI widget. So what you can do in such a case is you can go and pitch into your product manager and let him know. And in this way, you can also contribute to the product development process as such. Now, say a simple widget like a floating action button, which is one of the most commonly used widgets across all apps today. Now, as a product manager, one might not be truly aware of all the technical capabilities the platform that they're using is capable of. But you as a product developer, when you go through Flutter gems, you realize that there are a lot of variants available for even a simple widget like floating action button. And you realize that maybe some of the other variants are better suited to your requirement than the one you're currently using. Again, you can go and pitch into your product manager and let him know and truly contribute to the product development process as such. So now let's come to a scenario where you couldn't find your package on Flutter gems or PubDev. How do you go about in that case? So in that case, you try to find a package that most closely resembles your requirement. And you suggest enhancements by raising an issue. It is important to understand that you must fork your package only as a last resort. Because the moment you fork your package, the entire responsibility of maintaining the fork package comes on you, which is a very great responsibility. Now say you couldn't even find a package that most closely resembled your need. In that case, you might have to go back and start developing a package from scratch. And you will also have to release your package. So let's try to understand the package release process. So documentation is very important for any package release. You have to treat your README very seriously, literally treat it like a Tinder profile. Your README can either get you a left swipe or a right swipe. Your API has to be well documented. And it is very important to understand that you must include micro examples in your code instead of monolith examples. Now, what happens is when you include monolith examples, is your package might have a lot of features, which I as a user might not be looking, and basically I as a user might not be looking to use all the features that your package provides, but say only a few of them which are unique to your package. So in case of micro examples, as a user, for me, it is very easy to grasp the exact requirement that I'm looking for. Whereas in case of large monolith examples, it becomes very difficult for the user to look what he's looking for, to find out what he's looking for. So it is very important that you must include micro examples highlighting different features of your package. Second is spreading the word. To increase adoption, you need to spread the word. So there is a very active Reddit community called Flutter Dev. You must definitely go and announce your package there. You need to publish need plus use case stories on Flutter community at Medium. And you must reach out to your local Flutter chapter so that they can spread the word on Twitter and meetups. And you must also go ahead and submit your package on Flutter Gems. So there's a contribute button on Flutter Gems that you can use, and go ahead and submit your package there so that people, when they're visually browsing, they can actually find the package that they're looking for. Just releasing the package is not work done. You also have to maintain it. Maintaining a package is also a great responsibility. So for maintenance, testing is very important. You have to do unit test where you test a single function, method, or a class. You have to do widget testing or component testing where you test an entire widget. You have to do integration testing where you test a complete app in case your app is small or not that bulky. Or in case of a very bulky app, you have to test large parts of the app. It is important to set up automated testing using CI/CD tools, which are free for open source projects. One of the most famous CI/CD tools that are being used currently is Travis CI. So you can explore these CI/CD tools that are listed on the screen for setting up automated testing. You also have to set up a release frequency. In case of bulky projects, it is usually done quarterly. You need to update your changelog.md with each new release to list notable changes like adding new features, change in existing functionality, deprecation of soon to be removed feature. Now, there might be some features that you think your package does not need anymore and you might want to remove them, and you have to do your bug fixes and obviously security updates to combat vulnerabilities. So it is important that you update your changelog.md with each new release so that people know what has been changed. Now it is also important to make your package open to the community to contribute. So you have to set up guidelines for repository contributors by adding a contributing.md file in your repository. Respond to issues and pull requests so that people also know that you are engaged. And it is also important to become a benevolent dictator for life and let the community shape the future of the package. So if you have built a great package, or if you have been using one, go ahead and click on that contribute button on Flutter Gems and let the world know about it. So before I close today's session, I would just like to show the website of Flutter Gems.
All right, thank you, Asira. That was a really helpful talk on how to navigate on the Flutter ecosystem. Really, thank you very much.
Yeah.
So next up, I'd like to introduce Nav Singh. Nav comes from Montreal, Canada, and he's a software engineer at Manulife, and he's also a GDG organizer at GDG Montreal. Today, he will talk about how to give users feedback using the API review API, something really interesting. So Nav, the stage is yours.
Okay, thank you.
Nav, did you stop sharing screen?
I'm going to share. Yeah, just a second. You able to see my screen? Okay. Hello everyone. Welcome to our this first virtual DevFest, and I welcome all of you on behalf of GDG UK and Ireland, and on behalf of all the Google developer group across the world. So before starting today's talk, I will little bit talk about myself. So my name is Nav, which is already he already introduced about me a little bit. So I'm working as a mobile software engineer. My day-to-day job is more related to the Android. So in today's talk, we will discuss about how we can easily get the users feedback in our Android applications using a new InAppReview API, which is introduced by Google Play team in this year. So let's get started. So basically, before going forward, I would like to consider like what are the main challenges for us in this Android world before actually getting this API. So what I figured out, there are three main problems that I found. So far, there is no any standard way exists for prompting our users to get their feedback from our apps. So what we did is like, as a developers, we put some kind of menu items in our drawers or at any in some activities or kind of more options in your apps where user just hit on that, rate this feature, rate this item, and we push them to the Play Store, or we redirect from them to from our app to the Play Store, and they go there and they can rate our apps, right? But we don't get any information like if they really actually go to rate our app, or we put some kind of analytics to just to know, or just to tracking how many people actually go and give us a feedback using that menu option. So, and the second thing is laziness. So as a users, when we're using Android applications, if we are able to do or finish our task successfully, we normally don't go to give our ratings for that experience. And the third one is like, we only like to shout for bad things. So if we are doing, if user is interacting with our apps and somehow if there are services issues or anything went wrong, in those cases we might get users feedback, because at that point they feel frustrated, or then in that case they go to Play Store just to give us a ratings. And yeah, these are the major challenges that so far I found in Android world for related to getting the user feedback for our Android apps. So in this year, this is the most weighted solution for getting the feedback, and the Play team, they worked really great, I would say. And they provide us a simple API, which is called the InAppReview API. And what are the main major advantages of this API? It's a native solution. Like, it's not any third-party dependency from any external dependencies. So you just need to use the Play core services in your Android applications, and from there we can easily integrate it into our apps. And the second major advantage of this API is the feedback. When you try to prompt your user, they will not leave your application at any point. So when you are integrating this API in your applications, the full process of from launching to finishing the feedback process will handled by your application. Like, you just trigger the launch and everything handled by the API, but it is within your process, or it's within your application. So user will not actually going to the Play Store and then leaving feedback, and then from there they might lose the context, right? But in this case, you can trigger it in your app and everything will be handled by the API within your app. So that's the major advantage over the existing third-party solutions. And third is easy integration. There are like 5 or 7 steps that we need to follow in just to integrate this API in our applications. So let's see a little bit details about this API before actually see the implementation. So the major components, there are 3 major components exists for this API. The first one is the review manager. It's the interface that lets your app start in a review flow. This is the first step. We get the instance of review manager. And the second one is request task. that is the task which we get, which results as a task which has a review info object, and which is in the third step, review info, which is used to launch the InAppReview API, is final triggering the final launch review flow, which helps to get the feedback from the user. So these are the main three components: the review manager, request task, and the review info. And this is basically like the hierarchy first, like the same way we implement these things, like getting the review manager and then the request task, and then on the completion of the request task, we get the review info, and then using that review info, we can easily get the feedback from our users. So before starting integrating this library into our applications, there are a few requirements, or I can say prerequisites. To integrate it into your app, we need to add a pre-code dependency for version 1.8.0 or higher. And from the device side, there is a restriction, or the lower API which is supported by this API is 21, which is Android 5.0 or higher than that. And in terms of the Chrome OS devices, they must have the Google Play installed to having this functionality working. So these are the two main requirements: the Play Core library and the device requirements. Now we can, I will go through the implementation of this library, like how we can easily integrate it into our apps. Just a second. Yep. So as I already described, it's the first step is getting the instance of review manager using the review manager factory and its create method, which takes the context of your application as a parameter. So the first step is to just initialize your review manager. And this code samples, it's written in Kotlin. So if you are from Java world, you can easily convert your, or you can just, it's a easy to understand, it's a well explained code. But still, if you want to see the Java implementation, you can go through the Android documentation, and they provided both versions. And after getting the review manager, the next step is getting the request task, which on successful completion provides us the review info. So if you see the first line of the second piece of code, which is a manager.request review flow, it provides us its return type is a request with the task, which has a review info as a result if that task is successfully completed. So in the second line, we added the completion listener on that request. So if request is successfully done, we will get a review info from like calling the result, getting the result from that request. So this is the second step. So we can say like the request is successful. Now we have the review info, and this is the final step in your API implementation. The first line in this code is like using the manager that we initialized in the first step. We call the launch review flow method on top of that, using the context, which can be your activity or fragment from where you are actually triggering your feedback flow, and passing the review info object that we received from the second step. And then again, this flow, the return type of the launch review flow is also a task, but in this case we don't get any information, or if it's successfully finished or not, we don't get any information like what actually happened during the launch, the feedback process, like if actually user gives us the feedback or not. So we don't get information about that. So in the add-on completion listener, you can just continue with whatever you are doing in your app, or if you want to do something, or you just, the best practice is like don't don't put some kind of conditions to verify like if actually the flow is finished or not, because there are some quotas that is already added or implemented by the API team. So they put some conditions like how many times in the year they will actually launch the prompt. They will prompt the user to feedback, or but for the user privacy, they don't provide any documentation about that quota, like how that quota is working, like what are the conditions they are added. They have added in that quotas, but even there is some quota by the API team, but we can add our own conditions on top of that just to be on the safe side. So maybe if you want to say, like, let's say your app is having some kind of process of transactions, maybe bank apps or any other insurance app where user can submit their claims or e-transfers. So you can put some kind of counter, like if 5 times successfully completed, you can trigger the launch review flow on your for your API, and or checking the version of your app, some kind of those conditions you can still put on top of the quota that is already there by the API team. So these are the main 3 steps to implement your integrate this API in your app. So the first one is getting the review manager. Second is getting the request flow. So request flow, basically it fetches the information from the Play Store for the current user which is logged in at the Play Store. So the image and their user detail that they will show in the final dialog for the rating that I will demo at the end of the slides. And then third is like launching the review flow. The best practices to get the request review flow is in the early stage of your early stage of your process or your application, because it's asynchronous and it might take some time when you actually triggering your launch review flow to get the information. So it's best to get the information beforehand when you actually calling the launch review flow. So at least it will not freezing the UI. Your user will not wait for so long to actually see that launch review dialog. So that's the part that is totally related to the implementation. The next part, which is mostly everyone wants to make sure that everything works fine after integrating new APIs in your production apps, which is testing. So let's see that. So for testing this API integration, we have 3 ways to test this API. The first one is fake review manager. This is provided by the API team for testing during the development. So what we will do is, like, rather than getting the review manager's real object using the review manager factory, we just use the fake review manager passing the context. So this is the code. If you see here, I'm just replacing the review manager factory dot create with the fake review manager, and we get the fake review manager. And in this case, I didn't find any value in this case, because what this actually does is, like, it goes through from the first step to until the end of your flow. So it basically triggers this add-on completion listener. So during that process, if something went wrong or whatever happens, like you are not able to get the details of the user, it will not test those things. So whenever you using the fake review manager, it implements the add-on completion listener of the launch review flow. So it assumes that everything happens, like it follows the happy path, like you get the information, everything works fine, and you are successfully done with the review process. So it only implements that, and even in this case, you will not able to see the dialog, the fragment which shows to the user for getting their feedback. So it's basically just you can just testing using this, like putting some kind of logs in your add-on completion listener here. So you can actually see, like, yeah, add-on completion listener is called. That's the only thing they have provided using the fake review manager. And the next way is internal app sharing. It's on the Play Store. If you are familiar with how we are publishing our apps, there are 3 different tracks. So internal app sharing is like we can share our apps with the testers that we added at the Play Store for the testing purposes. So in this case, we publish our app APK or app bundle to the internal app sharing, and then whatever the testers emails you have added into your Play Store account, you can share the link with them. and they can install this APK, and during this method or using this method, we can actually able to see the UI, like how that launch review flow or the dialog gonna look like in our application. And it has some limitations, but it's a better than the first one, the fake review manager. So in this case, user can interact with the dialog fragment of the feedback thing, but they will not able to submit. So the submit button is disabled in this case, but they can write the review, they can rate, they can give us the stars, and they can cancel the dialog. Only the submit functionality is not enabled in this case, and the quota limits, they will not applied on the testing tracks. And the final one is the internal testing track. So if you already have published your app on Play Store, and you can use this track for the testing purposes, and you just share your app with your testers. And in this case, it's better over the previous two cases, like the internal app sharing and fake review manager. It simulates the full flow, like you get the feedback, and the user also able to submit that feedback, and in your play console you can see those feedbacks under the testing tracks, and you can easily delete or whatever you want to do with that feedback from there. But in this case, yeah, this is the best solution for testing this integration in your apps. So yeah, these are the three main testing ways to test this API. So this is basically all about the API details and how we can integrate it into our app. And this is basically the flow chart. I can say how it actually works when you integrate it and when it's the flow is successfully started. So the first step is like when we call the launch review flow, and it's successfully already, you got the information from the Play Store related to the user. The first screen, it shows the username and its profile from the Play Store, and this is how it's going to look like with the stars and 2 buttons. And the next step, when user interact with the stars, so they hit 1, 2, 3, whatever, the feedback, the optional text widget gonna be it will be visible to the user, so they can add a text if they want something to say. And then the submit button is going to be enabled at that time, and they can submit in the third step. And the final step, we just informing the user like your review is done. And the cool thing about it is that there is at the last step, there is an option to undo the stuff that you have done. You just give the feedback. You can still redo the stuff, or you can just revert that change that you just have done. So this is the flow for the final flow, how it's gonna work. So I did one sample app, like how it's gonna be look like in your app. So I can show you. Just a second. So I added one API into my sample app, and you can see how it's look like. So it fetches my user detail. I called the request review before, so it doesn't wait for that information. But as I told you, I posted this in internal app sharing. The submit button is disabled in this case. So this is how you can test your apps. I tested it using internal app sharing, but you can test it with your internal testing track to see how the actually submit functionality works. And one last thing that I want to share is about the quota thing. So if you see here, they don't provide us the information like how it actually quota works, like what are the limitations that they added, or what are the conditions they added there. But to managing the behavior like these, like method more than once a short period of time, like if we are calling even after 5 transactions, there might happen that the user finished up those 5 successful transactions within 1 week, right? So to managing those kind of scenarios, they put some kind of limit conditions in top of our conditions. So to make sure that it happens at a specific time, or if user already give us a feedback, it will not prompt them again to give us a feedback for a specific version. But again, they said for the user privacy, they didn't want to share these details with the developers for now. Maybe in future we can see details about that. And last thing that I can show you is a code. So this is the sample code that I just show you the app. So the first thing, I'm getting the review manager here. So for the testing purpose, I am checking the variant. So if it's the debug variant, I get the fake review manager. Otherwise, like production thing or any other variant, just get the real object for the review manager. And the second is getting the request review flow here. So all this should happen before, like to getting the review info object, like until the step of fourth, from first to fourth steps, like getting the review info, it should happen like in the early stages of your app, actually before triggering the call for launch review flow, so that you have beforehand information whatever you want before, so that user will not see any kind of delay, or it should not freezes the UI kind of stuff. So the final step is launch review. And again, I told you, like in this case, if you see the definition of the launch review flow, it provides us that task which has a void type, so we don't get any information like what actually happened, if user gave us feedback or not, or even if the dialog is shown to the user. So we just launch and that's it. That's the only part in our hands, and that's the final call that we can do in our site. And from there you can you can put some kind of checks if the request is successfully done. Go now, like proceed further with launching the review. Otherwise, just continue with whatever your user is doing. So you will not actually halting your process, or for better user experience, just continue with whatever actually you want to do here. It should be here too. So you just continue with the normal users interaction with your app. And for the best practices implementation, the API team, it's a recommendation that don't try to abuse the API by putting some kind of conditions just to check like what user actually hit in that dialog fragment, just to tracking like if they submit us or not. So just follow the best practices. And this is just a 6 or 5 yeah, it's a 6-step implementation, and it's the easy implementation, and you will able to get your good ratings or your user feedback easiest way in Android so far. So yeah, so that's all in this talk. Thank you everyone, and if you have questions, I'm happy to answer here. So thank you very much.
There was a quite good session. So actually we also came around some problems like that. You know, when user taps on the CTA, they can go to the Play Store, but then you don't know if user has reviewed the app or not. So that's how you cannot track the specific action, and you cannot track the data. But now with this new API, it's not that flexible, but it's at least something that you can get. So that, yeah. So that's quite good. That's quite good. And also the session was amazing. Thank you so much for the session today. Hope you enjoyed it. Did you enjoy it?
Yeah, I like it.
You like it? That's good.
Yeah.
Cool. So thank you so much for the today. Hope to see you in the next session, and have a good day.
Yeah, thank you.
Bye-bye.
Bye-bye.
So before we move on, and now it's time. I'm hungry. I think you guys are hungry too. So it's time for the lunch. We're gonna go on a lunch break, and we're gonna come back at the 2:45. So you have a 1 hour, and then we'll start with amazing stuff like unit testing and the WebView. I know the infamous component. And the next is how to work with Firebase UI emulator. So it's quite a good stuff coming up. So hope to see you after an hour. Thank you so much.
Hello, everyone, and welcome back to DevFest UK and Ireland. We are back from our lunch break. I hope you had some time to have a nice lunch. And we are back with the second half of today's track. We have still 6 more talks in total, with 3 coming into this chapter. So first one is from 2:35 until 3:15 is unit testing, Kotlin channels and flows. Mamta, I think you're muted.
Yeah, I'm back again. Thank you for that. So the second talk is about the better web view. Now, when I say better web view, I'm not sure how you can do it better if you're coming from the Android ecosystem, but let's see how we can make it better.
Yeah, definitely. Let's see about that. And the last one before our next coffee break, which probably will be needed, is the talk about developing locally with the Firebase UI emulator. Ooh, that sounds exciting. So before, let's start with our talks. First one, we have Mohit, who is an Android engineer and a Kotlin advocate. Hey, Mohit.
Hi.
Glad to have you here.
Great. I'm very excited. It's my first GDG event. Yeah, so my talk is about unit testing, channels, and flows. So in this talk, I'm going to present on how to utilize utilities such as run blocking tests. I'll present to you on use cases for testing flows and at the repository and the view model layer. So let's look at some use cases for testing flows. The use case we'll look at is simple to a little bit more complicated. We'll look at use cases for testing collection. How do you read items from one to another in the flow? So suppose you had a very simple use case where you were basically building an app that displays a list of users, and you may communicate with an API service. And the API service might be written using GraphQL, gRPC, or REST. And all these different services, they have coroutine-based implementation that you could use. So when I get a response back, the response might be a stream. Suppose that in this use case, it's a stream of user data, where each item has a user ID, username, and the location they're from. And I may want to consume this and process this stream in some way. So I may set up an architecture where I have a repository that communicates with a service, and let's look at how I would go implementing that. Suppose I had a user repository in which I injected in an API service, and this repository has a method to give you a stream of usernames, which are strings. So I may start off by asking my API service, hey, give me your flow of user data. And I'm going to do some filtering on it. I want all the users that are located in UK, and I want to get all their usernames. So I have a very simple flow over here in which I'm processing something. And how do I test this very simple flow? So in order to test this, the Kotlin coroutine library provides you with a module that you could include. And this is how you would include it as a test dependency. And let's look at what utilities it has. So to write my tests, I first need to create a coroutine that it will run in. And to do this, I'm going to use a method called run blocking test. And this internally creates a coroutine on a particular scope. You always need a scope to create a coroutine. And then it also creates a dispatcher that's going to run this coroutine on that you need. So the logic that gets executed in this coroutine that it creates is your test that you provide, which is going to get executed by this coroutine. So let's look at internally how run blocking test is implemented. So it takes in a particular test body, your logic, the test that you have written. It creates a scope, and then it basically runs your test asynchronously inside of what's called a deferred. and it begins to run your test. If there's any exceptions, it will surface them to you. After your test has run, it will begin to do cleanup. It will begin to cancel the jobs that are active. Jobs are a part of, every time you create a coroutine, gives you a reference to its job, and it will begin to cancel them. If there are any jobs that cannot be canceled as part of your test code, it will give you an error. This is the most common error that you may get, in which you have some coroutine that you created in your test that was still active, could not be cleaned up. So we could look at the logic in 3 steps, where you have setup, it runs your test, and performs some cleanup. So now let's look at how to write your actual test. To write your test, how do I go about testing this flow inside of my run blocking test? There are 2 ways that I can do it. I could create a mock, or I could create a fake. So let's look at how to use Mockito, to do this. So there's a Mockito Kotlin library that provides you with utilities for mocking, suspending methods, etc. So I'm going to mock out my API service. I'm going to say, when the getUser method is called, I want you to return a flow which has some data. The users, this is the data. This is the data that I want to create a stream from. It's a list of users with various locations, and I'm going to convert it to a flow using the askFlow method, just like I did here. So I'm going to inject this API service into my repo, and then I need to be able to read from this flow called getUsers that I made, that I showed you. And the way that I'm going to do that is call a terminal method called toList. There's a terminal method called collect. There's a different terminal method called .single, and in the toList method, what it does is that it reads from the flow one by one, and it stores all the emissions into a list. So what I have here is a user list, which has all the things that have been emitted, and then I could do an assertion on it. And when I do an assertion, I can verify that I got the list of users that I wanted. So this is a very simple test, but could we improve upon it? So when you think about the way that I'm collecting from the flow is by using the toList method, but there's a library that provides you with a better, maybe more scalable way to do this, called Turbine. Great library by Square. And what it is that it provides you with an extension on the flow called test. And what the test extension does is that it allows you to read from the flow one by one. Expect item is a method call which gives me the first item that was emitted by the flow, and I'm doing a verification on it. And then it allows me to get the second item that was emitted, and I could do a verification on it. And then I could verify that my flow has completely, the collection has been successful. I have read all the items. There are no leftover things that I need to collect from. So collecting the flow. So this is how my test looks using Turbine. So how does Turbine work underneath the hood, and how does test extension actually work? So another thing to note is that suppose that I have something left over in the flow that I didn't do an assertion on, it will give me an error, and I could fix that by adding another expect item in there, call in there. So it allows me to verify that I have read everything that was emitted by the flow that I'm testing. And then also, if I didn't have a complete verification, it will give me an error, because it requires you to verify that your flow, basically that your flow has completely emitted everything that it needs to. So how does test method work? It takes in the flow that you're trying to test, which emits, in this case, 3 items, and it internally creates a blocking queue, which is it's called a channel. And it's an unlimited channel that, as you store more things to it, it expands. So what gets stored are events which are from your flow. So your first item gets emitted from the flow. It gets stored into this channel as an event, which is an item. Second thing is an event. It gets stored as an event of item. Third thing, and then finally it stores the event that your flow has completely. You have read every item from the flow. It's complete. But there is an exception. There's a case when there's an exception. It will also store that as an event. So how now you have a record of everything that was emitted by the flow. How do I query all the items in this channel? To query them, it provides you with an API to do this. I could determine, the duration of an emission. I could verify that there were nothing that was emitted from the flow that I'm testing. I could verify an particular item was emitted, could read items from this channel. I could verify if there was an event which was an error. I could verify that there was an event where everything was read and you completed collecting from the flow. So now you have this API that you could utilize in your test to test flows. And the way internally it hooks up this test extensions by creating a coroutine inside of there. This coroutine will inherit the context of the run blocking coroutine. So it creates a child coroutine of it, creates a channel inside of it to store events. Then it creates a coroutine inside to collect from your flow, reads one item after the other, and then it stores basically all the events that get emitted get stored in this channel. And if there are any exceptions, it wraps in a try catch and it stores what exception was thrown. So you could access when you write a test, you could access, read from this channel, read from this record of events by using the flow turbine API using this function type over here. So this provides you with the API to access it. And that's why I'm able to access expect item in this Lambda block inside of .test. This is a very simple test of using Turbine, how Turbine works underneath the hood. But there are other types of patterns that, let's look at them that, there are more complex patterns. So one is being able to run on a separate dispatcher. Suppose I have my flow, simple flow over here, but now it will run on the dispatcher that in the coroutine that I consume this from. But I want to specify my own dispatcher to do this. And to do that, you could inject into your repo some dispatcher that you want to use. And I could use the flow on operator, and everything above the flow on operator will be executed in this dispatcher. So this is really good. And this is useful for testing, as we'll see. So how do I make run blocking tests? Use a dispatcher that I created, but not have it created its own. So there's an extension that they provide you for that on a dispatcher that I could use. So the way you set it up is that I am going to create my own dispatcher in my test. I'm going to inject it into my repo, and I'm going to tie it to the run blocking test just like this, calling the extension to utilize my own dispatcher, not have it created its own. There are some benefits to this. So let's look at that. Let's look at now errors. How do you test them? Suppose you call this get users method and it throws an exception. How do you handle it in your flow? So one way to test this is that you mock out your get users flow to return a flow that throws some particular exception. And when I begin to collect from it inside of my test block, I'm going to call expect error because I expect an exception to catch an exception, and my test will succeed. And the way flow test, as you saw, works is that it wraps basically your test code in a try and catch, and it stores that as an event that you could query inside of this test block. But is there a better way to handle errors rather than relying on try and catch? So a better way to do this is to use a result union type called result, which is in the Kotlin library. It allows you to represent the result of a computation of success or failure. And the way you do this is that you have your flow, its type is going to be result now, not string, result of string. And then when there's a successful response in your flow, you're going to say result.success, give me the successful response. But if there is a exception, in one of these operators, any operators above this catch block, it will go inside of this catch block and going to emit a failure. So this is a better way to handle, exceptions and errors. We're using the catch block. How do you test that? In order to test that, we're going to take the same approach. I have a flow that throws an exception. And when I go to read the flow now, I'm going to assert that it's a failure. Expect item gives me a result. And failure is an extension on it that I could use to verify. So the way this works is that the exception gets thrown, it will go into the catch block and it will emit a result of failure. And I can verify that. So that's how a good way to test errors. What about when you want to test retries? An exception occurs in your flow and you want to retry your flow again, the operator's applied again. So suppose an exception occurs and you go into the catch block, but you want to retry even before going there. There's an extension that they provide, Kotlin provides, called retry. This is one of the extensions. There's retry when. There is this extension here takes the number of retries you want to do. And before I do a retry, I'm going to delay for 2 seconds. This retry lambda block returns a Boolean. So you could specify whether you want to do a retry for a particular exception. It may not be for every exception that occurs. And it gives you the throwable, a reference to the throwable. So when an error happens, it goes into a retry, then it delays for 2 seconds. It will retry the flow again, retry the operators before this retry call again. And if it fails again, and then it will ultimately go into the catch block. So this is our flow now with retries. The order in which the retry and catch is applied is important. So let's look at how to test this. The way we test this is that we're going to create a coroutine for our test. We're going to mock out our get users flow. We're going to start to read from our flow one by one, and then we're going to assert that it was a failure. So this is our simple test, and the way this test works is that so something else to note here is that when I go to run this test, I'll get this error because there's a modification that I need to make. When an exception happens, my test runs, it goes into get users, it will go into retry, but then it will stop, not go forward this delay. I need to be able to move virtual time forward on my dispatcher. And to do this, they provide you with an API to do this. And there's a method called advanced time by that I could call in my dispatcher to move forward by 2 seconds. When I do that, it will go and retry the flow again. And when it does that, it goes back. The error will happen again. It will go back and do the second retry. It will delay first. But now I want to advance time forward again by 2 seconds and have it do a retry again. And when it does the second retry, it will ultimately fail and go into the catch block. That's how that test works. And one thing to note here is that there's this concept of virtual time that I'm utilizing here. And there's an API they provide to handle it using a method called advanced time by. So the last retry case that I may want to test is, suppose that one of the retry happens, could be the second retry, and it succeeds, and I want to test that case. So when a second retry happens, I want I want these flow, filter, and map operators to succeed. How do I test that? So in order to do this, I'm going to create a flag that allows me to control what my test flow does, whether it throws an error or gives me some data. I'm going to mock out my get users flow. When throw error is true, give me throw an exception. Otherwise, emit some data that I want to verify. So then I'm going to advance time forward this time, go retry my flow. Before I do that, I'm going to say throw error, don't throw error, set it to false. And then I'm going to advance time by 2 seconds. And then I'm going to assert that it will ultimately was successful, the result that I got. And the way this works is that when the get users flow is called, it won't go into the catch block immediately. It's going to go into filter and it's going to apply the filter and map operators, because in my test, I control whether my test flow throws an exception or not. So this is a way to test whether one of the retries succeeds. You can modify this test to test whether the first retry actually succeeds. So those are some different use cases that on how to test flows. There are many more use cases that you could learn from. Now let's look at lastly how to do view model testing. Test your coroutines inside of a view model. So what I was doing so far was I was collecting and consuming a flow from a service in my repo, but I may have a coroutine in my view model that also consumes a flow. And how do I do that or test that? So I may create a view model using Jetpack view model class that it provides. And there are benefits to it. It creates a scope for me that I could use. So I'm going to inject my repo into this view model. Inside of this view model, I have a construct, which is a mutable state flow, and that I could, send data to, and I could have my view listening to it. So one way to architect this. You could also use live data, but I have my get user repository, which gives me a flow that I'm going to consume. Every time it emits a username, I'm going to give it to this mutable state flow. And then I'm going to launch a coroutine to do this. So one good practice that I found is useful is to always use launch-in. Don't do vModelScope.launch, and always use launch-in. Internally creates a coroutine, and then when on each will get called for every emission. So let's look at how to test this simple implementation. So I'm going to inject a mock repo into my view model. You could also use fakes if you want. I'm going to create a coroutine as I did before for my test. When I stub out my my get users call, I'm going to make it return a flow using flow of method return a single item. And then I'm going to start my test. This will internally create a coroutine using launch-in, begin to collect from my flow. And then I'm going to do an assertion on viewModel.statesFlow. I'm going to assert each emission. So expect item gets me the first thing that was emitted. And then I'm going to verify that it is the user item that I expect it to be. So when I run this test, I'll run into an issue, and it will give me this error that I need to set the main dispatcher. So when you create a coroutine in view model using view model scopes, it sets the dispatcher of main. And I need to be able to set that in my test. So the coroutines utilities library, they provide a utility called dispatcher.setMain, in which I could set a custom dispatcher like this. So, and then I could reset it when my test tears down, when my test completes, all my tests complete. So I could make this functionality reusable by creating a test rule that I could utilize for all my view models. I'm inheriting from a class called TestWatcher in here. And I'm going to override two methods called starting, in which I set my main dispatcher for my view model coroutine. And then I'm going to reset it when finished this call. So this is a custom test coroutine test rule that I could reuse. And this is how I would implement it, for my view model test. I'm using the annotation get:rule, which has the test rule that I want to use. And I could reuse it for all my view model tests like this. Now when I run my test, you'll see it passes. So that's a really useful test rule that you could use. So testing is also a good way to learn about these constructs and how they work and what their behavior is and whether it's good, whether it's useful for your use case, etc. For example, suppose I have a repo in my test, I modify it to not return one thing but two items, user1, user2 strings. And then I'm going to start to run my test and start to read from my mutable state flow. When I run this test, I'm doing a verification on two strings, user1, user2. And I'm going to get an error. The first assertion here, expect item.data should be user1, will fail because it was actually a string called user2. And the reason why this is because mutable state flow is conflated. And because I'm sending events back to back, it will basically only have like the most recent thing that I send it to. So that's why this test fails. So if I have a use case where I want all the events to be processed by the consumer, I may use like something else. So because it's conflated, that test failed. But I may use any of these constructs, in my use case. So one thing let's look at is something that will be released soon is mutable shared flow. So mutable shared flow, the way I send things to it, it will basically suspend until all the consumers have processed the event. So I'm going to send things in here, read from my flow, from our user repo, and one by one, and we'll call on each. And I'm going to emit what was given to me by the get users method to this mutable shared flow. When the emit gets calls, it will suspend until a consumer has processed the event. So this might be useful for the use case that you're trying to implement. So knowing which type of a construct you want to use, mutable state, mutable shared flow, or a particular type of channel is useful for your use case. So the last thing I wrote a blog post which has more information on what I covered. And you could check it out on my website called codingwithmohit.com. I'll link it on my slides. And also gave given many presentations on unit testing and channels and flows and how they work. And you could check it out. I'll link it in my slides. So that's my presentation. I hope that was useful. There are many more use cases that you could learn from, that you could implement. If you have any questions, please feel free to reach out to me on Twitter. I'm more than happy to help you to implement unit test and answer any question. Do my best to answer any questions and help you out. Well, thank you.
Okay. That was a great talk, Mohit. And in one of the bio, you mentioned like you were a backend developer before and now in the Android development.
Yes.
From where you have started the Kotlin flows and channel, like after coming into the Android or before you were doing the backend?
No. So when I was a backend engineer, but I utilized a different technology long ago on PHP. But I do now also work on Android and backend. Contribute to both sides, and I worked on implementing coroutines and testing also on the backend side with gRPC, and also on Android side with various technologies like GraphQL and gRPC. So that's my experience.
Yeah, that's great, because I really loved about the part where you are going through each layer of the architecture. Like you went through the data layer and you say how you can test your repository. You go to the presentation layer, you said like how you can test your view model. So that was a great part. I really loved your talk. Hopefully you also enjoyed the presenting here. And thank you so much.
Thank you. Thank you.
So yeah.
Thanks very much, Mohit.
So let's go to our next session. Give me a second. I'm going to present the speaker. So the next is Hazem. Hi, Hazem. How are you?
Hello, everyone.
Hi.
Just wanted to check the sound quality. Is the sound quality okay? Can you hear me?
Yeah, we can hear you.
Yeah,
Okay.
I can hear a loud, clear. Yeah.
Cool. So you ready for the talk?
Okay. Should we start?
Cool. Yeah, definitely we can start. So before that, can I give you a little bit of introduction, like what you do and everything?
Yeah, sure.
Yeah, just to look, make you look a little bit better here.
Okay, yeah. I'm not sure. Okay, so my name is Hazem Ashmawy. I'm a software engineer at Google UK. I joined Google actually like this month. Marks 2 years for me at Google here in London. I work primarily on the Android WebView team in London. And yeah, I'm here to present some tips and how to better use WebView in Android applications.
Yep. So yeah, you're going to talk about the WebView, and you mentioned the better WebView, so I'm quite interested in it. Cool. So best of luck. I will see you later.
Okay, thank you. I hope you will find this this presentation useful. So yeah, I guess you know me. I'm Hazem. So a little bit of background about WebView. I guess like all the guests here are familiar with Android development. However, a background won't harm. So Android WebView is an essential part of the Android platform since actually API 1. So WebView is essentially yet like another Android WebView. Like you have text view to show text, image view to show images, and you have Android WebView, which is to render web content in your application. So yeah. So as I said, like it has been in part of the Android platform since API 1. A lot of things have happened since then. WebView actually is built on the Chromium project. So actually, it's like a mini browser in your Android app. And actually, you can find the source code of WebView under the Chromium project source code directory. So since Android 5, or previously known as Lollipop version, WebView became a separate APK that can be updated through via the Play Store. So previously, you have to get like updates, like OS updates, like security OS updates, like maybe every year or every like 3 or 6 months. But now you can get updates regularly via the Play Store for WebView, including all the security fixes, bug fixes, new features, all of this like in a very quick cycle. Currently, it's around 6 weeks cycle. And who knows, maybe this will be even faster, quicker in the future. Okay, so actually, WebView, when WebView became an independent APK, this opened a lot of doors for the WebView team. So now you can have different WebView APKs on your device, not just the only one that is shipped with the Android version you initially got. So you can install multiple APKs, and then you can choose which we call it WebView provider. So which WebView provider you want to use on your device. I ask you to remember this because we will use this information later in the presentation. So yeah. A fun fact for you that a recent analysis for the applications on the Play Store, we found that around at least 80% of Android apps on the Play Store uses WebView APIs. So that's a really high number. Like WebView is a really important part of the Android ecosystem, and it needs a lot of attention, and hopefully developers will better use WebView in their applications. Okay, yeah, here we go. So here you can see a chart of Android like Android version distributions as of this month, actually. You can see that Android 10, Android 9, almost like half of the devices now run the recent versions of Android, like 10 and 9, but still around 19% of devices still run very old Android versions, like Android 5 and 6, like Marshmallow and Lollipop. So as I said, like even WebView is an independent APK. It is still part of the Android platform. So the APIs you can use in your applications depend on the API level or the Android version that the application runs on. So since, for example, like since Android 5 Lollipop, WebView gained like around 40 plus more new APIs. And yet, if your application is running on an old Android L device, it can't use this new APIs. Like some of the APIs improves, like adds new features. Some of the APIs fixes some security issues, and you can't use this on old devices. So before we switch the slides for the next one, just a disclaimer here. If you shouldn't use this chart to base your marketing or any like application strategy decision for your application. You should refer to the link below, the developer dashboards, and you can use the Play Store developer own like dashboards and statistics to like make your decisions about your application. So, as I said, like you have a solution. We have a problem that if you only use the WebView in the provided in the platform API, you don't have access like to new features on old Android devices. So what should you do, and how you can solve this? As you see in the slide, you should use Jetpack's Android X WebKit. So Jetpack is like a set of tools provided by the Android developer team to help Android developers better develop for Android. And Android X in particular is it's not part of the platform, Android platform, so it's dependent. You add it as a dependency in your application, and it got updated like much quicker than the platform. Like platform updates, maybe it's as I said, like maybe every year or every few months when an application, when a device get like a security update or something, and some devices, like some companies and some providers stop updating their devices after a couple of years. But this is compiled part of the application APK, an application binary. So this can provide like the updates to your application much quicker than just if you depend on the platform API. So what is Android X WebKit if you are not familiar with it? It's, as I said, it's part of the Jetpack library. We try our best to make it as easy to use as possible for developers. It follows a fast release cycles, like every few weeks, and it supports. It has like it offers backward compatibility for devices till Android versions, for L+ Android versions. So if you use Android X WebKit, your feature will work on a very wide range of devices, and you don't care anymore about the platform restriction. Again, if you're not familiar with that, you can just add it like to your Gradle build file. You just add it as a dependency, implementation Android X WebKit, and 1.3.0 is our most recent stable release. You can get other like pre-releases if you're feeling adventurous. There are a couple of other alpha and beta releases available now, but this is the stable one, the current stable one. So I want to go through some of the exciting APIs we provide in the Android X WebKit. And most of exciting feature of all time, the dark mode for Android. Dark mode has been recently like a feature that everyone is seeking in their application. And when Android 10 came last year, it provided support for dark mode in Android application. So now WebView as well support dark mode using Android X WebKit APIs. So the first set of APIs are Android Force Dark APIs. This is actually available since the 1.20 release. It provides the developers control over the Android Force Dark mode in WebView. So in Android, like the Android supported APIs for Force Dark mode, you define some configuration in your Android manifest, or you can toggle it using like platform APIs, and this allows you to control the settings in WebView. So there are 3 modes available for dark mode. It's off, on, and auto. Off means that your content will never be dark. In WebView, like it will always in the light mode. On means that the content will always be dark, and auto it will follow the system settings. Yeah, so this is a sample code. It's super easy, just using the web settings combat, and instead of like the standard platform web settings, you use web settings combat available under Android X WebKit, and you use get force dark to query current settings, or use set force dark and the appropriate setting you want, and here you go. Just one thing I want to highlight here. As you see, like you need to check if the feature is available in WebView. So you should go whenever you use Android X WebKit APIs. Most of the time, you need to check if this feature is supported by the WebView installed on the device. So, okay, Hazem, like I said that we support backward compatibility to Android L. So why you need to check like if a feature is supported or not. So as I said, like WebView is built on Chrome, and it's updated independently from the Android platform. So it may happen that the device doesn't have the most recent version of WebView. So you need to check if the current version of WebView available on the device, it has the support for the feature you want to use. So here you use like WebView is feature supported, WebView feature for dark, and you're good to go. So this is another exciting dark mode API. It's available in our recent version 1.3.0, released in last August, and this kind of complements the previous API. It helps to control the WebView darkening using the CSS and web content darkening inside the WebView. So the previous one was using like Android settings, Android device setting whether to darken WebView or not, and it doesn't tell WebView how to actually darken the content inside the WebView. So this controls the CSS settings and the web content loaded in WebView, and it follows the W3C standards. So here you have like 3 options. You can use user agent only. Content will be darkened by user agent, and the beige dark theme will be ignored if it exists. Like if it doesn't exist, it will be still ignored. The second one is web theme only. This will be like, this means that the content will be darkened by the dark theme provided by the web page. If the page doesn't have one, content will be rendered with the default theme. And the third one is prefer web theme over user agent, which means content will be darkened by the dark theme provided by the page. Or if the page doesn't have like a specific dark theme setting, it will be darkened using the default user agent. Yeah. So yet another snippet. You can see it's very similar to the force dark API. Same thing. You need to check again for the feature if the feature is supported or not, and you are good to go. And here's a sample of when to for darkening web content inside WebView. This is a Gmail email and HTML in a Gmail app. And yeah, this is the light mode, and this is the dark version. So yeah, if you want to learn more about the Android X WebKit, all the APIs and for the dark mode and or other available APIs, you can check our Android developer documentation over this link. And I advise you to check it regularly for the recent releases, and check the release notes as well to be up to date with our new features. So yet another one, like another thing related to Android X WebKit API is how to load in-app web content. So yeah, let's yeah. What does an in-app content mean? By in-app content, we mean either like local web pages statically compiled into the app, like not loaded over the internet, or like you maybe saved some web pages in your app data directory, and for like maybe caching purposes, and you want to load it from your data directory. So it's local content on the device. And it's again, like it's a web content, you want to load it in your WebView, so it's built using HTML, GSS, and CSS technologies. WebView provides multiple or various APIs to do this. Like you can load local data through WebView load data API, or WebView load data with base URL. And you can also use file URLs and the special case file URLs like Android asset and Android resources to load content from the application assets and application resources. I will not go through the load data use case. It has many quirks and gotchas. You should get it right to get it to work correctly. And it's a slightly complicated API. I'm sorry about this, but this is like we can do anything about it. It's the API is there. But if you are interested about it, I recommend you see the Modern WebView Best Practices talk by my colleague Nate Fisher from the Android Developer Summit in 2018. It's a very good talk. He goes through all the tips and best practices on how to use load data in your app. However, I want to focus on file URLs, because first, like we have a new API from Android X that replaces this, and it's now the recommended way to load local data in your WebView, and maybe like you shouldn't use actually load data API. And yeah, as I said, it's like a spoiler alert. File URLs are bad. Please don't use them because it's tricky to get all the security aspects correct while using them. So the why they are bad. Firstly, they are considered opaque origin. So what does an opaque origin mean? For those who are not familiar with opaque origin, like from the web land, an opaque origin means, in a nutshell, that JavaScript that runs inside the page loaded over file URLs can't directly access other origins, since this will violate the cross-origin policy via WebView, like the cross-origin policy. So what does this mean? Again, even like if you have a JavaScript loaded inside this page and it tries to access yet another like file URL, this will consider an opaque origin. So this is considered a cross origin request, and it will be blocked by default by WebView, which means like many of the use cases of JavaScript will be broken inside this page. So usually to get around this, you may need to enable some settings in the web settings API, things like set allow file access from file URLs. This grant the special powers to the file URLs like Android assets, Android resources, and the other file URLs to access arbitrary files on external storage. So say you have a file, like an HTML file that's stored outside the app data directory, and you want to load it. By default, the app doesn't have access to the external storage, but this will allow the file URLs, like the JavaScript running inside the page loaded over the file URL, to access external files, which is quite risky, because like you don't have control of what files are on the device. Like they may be a malicious third-party file, and it can compromise WebView and even like your application, because remember, WebView runs inside your Android app sandbox. Another one, like set allow universal file access from file URLs. This is an extremely dangerous one. And please don't enable it under any measure. Because like if you load third-party content in your WebView, this and if you don't handle like external intents properly, this can for unsafely configured WebView, this can launch cross-site scripting attacks, and either accessing arbitrary local files or even like credentials stored inside your app data directory. Another one, like cookie manager, set accept file scheme cookies. So say you loaded some content over in your file page, the file URL page, and you want to use cookies. Actually, all file URLs share the same cookie, which is isn't secure, because like if you load multiple, like if you load external content in your WebView, this can access the cookies, user cookies in the app. And actually, this doesn't comply with the web specifications and standards, because like cookies by standards should be an HTTPS APIs only. It shouldn't apply to file URLs. And actually, like in Chrome, file URLs doesn't have access to cookie jar. Anyway, so I'm sorry about like if this confused you, but what I want to say that these APIs are dangerous, and you can't actually use file URLs in most cases without enabling these settings. So you shouldn't use file URL. Instead, you should use Android X WebView Asset Loader. So what is Android X WebView Asset Loader? It's part of the Android X WebKit since the early release of 1.1.0. It helps loading local content over web HTTPS URLs. So it's you avoid file URLs entirely, and you load local data as if you are loading a web content from over the internet. This allows you to use all the security model built around web URLs, like cross-origin policies, using cookies and everything securely for your local data. This allows you, like even like in some cases like caching, that you can integrate local content in your app with like the web content you are loading from over the internet. So how to use it? This is a quick snippet. You first build the asset loader object. You register some asset, some path handler. We have like three path ready path handlers for you, like for asset path handler to access files from the assets directory, resources path handler to access files from the resources and resources directory. And yeah, I think I'm running late, so I will try to go quickly over this. And another one to load from the internal storage directory. Then you hook it up in the WebView client using the should intercept request API, and then you just load an HTTPS content. By default, the origin is appassets.androidplatform.net. It's the default origin. It's reserved for you by Google, so you should use it almost all the time if you don't care about other content loaded from over the internet. This actually can be customized in different ways. You can implement your own path handler. You can use your own custom domain. But one important thing that you should always use domain that you have full control over. So it should always be your own domain. Don't use like a generic one like example.com or something that you don't control. Or if you don't use the default reserved one, it's reserved by Google, so you are sure that there are no external web content will ever be loaded over this origin. And you should always use its HTTPS scheme if you don't have another not good reason to not to use it. And yeah, you should, another thing you should always set or allow file access to false. It's now set by false by default for apps that target API 30 and over. And now these dangerous APIs are deprecated since API 30. So you shouldn't use them. But yeah, the set allow file access, even like for all the APIs, I recommend like setting them to defaults. So an exciting thing that I should have given more time is WebView DevTools. We talked about like APIs, and you are using the best tips, and like but you still run into some problems in the WebView in your device. An exciting thing that we launched in early this year is WebView DevTools. It's a set of on-device web tools for developers to debug the WebViews on your device. It's like an application built inside the WebView APK. It's available since the Chrome M83 release. I think it was in March, I guess. Or I don't exactly remember, but yeah, it's has been there for a while now. So you install that, you have a launcher icon on the device, and you launch it, and you can use it. It has like some exciting tools like WebView crashes, to allow you to see the crashes in your device from all WebViews on the device. You can report crashes, like if crashes are automatically reported to WebView team, but if you have want to provide more information about the steps to produce the crash, you can use this tool to provide more, to find a bug against the WebView team to provide more infos. You get like WebView flags. It's similar to Chrome flags. If you're familiar with Chrome flags, you can enable and disable experimental feature flags. This allows you to, like if some new feature breaks your application, you can disable this feature and like see if this fixes your app, and then like report it back to the WebView team so we can act on it. This is like my favorite like flag. It highlights WebView in all application. Flags are enabled for all WebViews on the device for all applications. Yeah, so how to get it? You need to install WebView pre-stable channels for Android N and P. You need to install like monochrome or Chrome, and you can use Chrome Beta as a WebView provider. Or on Android 10 and plus, you should install WebView Beta from the Play Store. You should, final thing, you should always use, for developers, Android developers, please use WebView Beta. WebView Beta will help you detect crashes and like breakage ahead of time. So you don't, like a new WebView release won't break your app. Please test your app against WebView Beta and report any problems to the WebView team. And yeah, here's some the documentation for the developer UI, and this is a more documentation. This is not like the most user-friendly URL. This is our public documentation for pre-release WebView versions. Please feel free to go to these URLs. And yeah, thanks for your time. I'm sorry about running a little.
That was actually right on point, Hazem. Thanks for that.
Yeah, thanks. And you can follow me on GitHub or on Twitter. And if you have any questions, either for me or generally for the WebView team, please feel free to reach out to us, like to this email, and we always monitor this email and respond to external developers. And yeah, that's it. Thank you.
Thanks very much for your time today. I guess the words of wisdom today is do not use the file URLs in WebView.
Yeah, exactly. And use WebView Beta and WebView dev tools. Please use WebView tools and let us know what you think. And if you have any features in mind, we will be happy to implement it for you.
That's great. Thanks very much for your time. And now we'll get you go now. Enjoy your afternoon.
You too.
Thanks very much. So we have the next session coming, and that was with PJ. PJ is a GDE for Firebase, and he will discuss more into details. Actually, I think he will discuss everything that we need to know about Firebase UI Emulator. Is that right, PJ?
Yeah. Hopefully, I can cover a lot of things. Today it's going to be mostly focused on Android, but I'll try and cover as much as I can.
Yeah, that sounds great. Without further delay, the stage is yours.
Awesome. Thanks so much. Okay, cool. Yeah, so thanks so much, everybody, for joining my talk today. I know DevFest is pretty crazy everywhere around the world. There's a bunch of talks you could have went to, but you chose to be here with me, so thanks. Today I'm going to be chatting about developing locally with the Firebase emulator, the new UI emulator. Who I am, so I'm a freelance mobile developer. I'm also a Google developer expert for Firebase. These are the stacks that I develop on, so Android, iOS, Firebase. My choice of cloud is Google Cloud. I try and do a little bit of machine learning where I can. And I have a podcast which is called Talking with Apples. where I discuss mobile development with a bunch of community members from around the world. So if you want to check that out, it's cool. Something random about me is that I do some photography. So this is the picture on the side here of something that I took recently. But yeah, you guys are not really here to hear about me. You're here to hear about Firebase. So let's jump straight into it. So Firebase, a quick history lesson about Firebase. So Firebase, around, I think it was like 2012, came out, and its main focus was to provide us with a database that was able to sync data in real time. And this was amazing. We didn't have to write any kind of third-party web services or anything. We could just use the SDK and connect straight to the database, and it would sync between devices. And this was amazing. Eventually, we then got, once it was acquired by Google and a bunch of development was done, we then got Cloud Functions, which kind of then helped us with that, almost that 3-tier architecture, where we still needed to do some kind of stuff on the server side that we needed to do. So we got Cloud Functions that really helped us with that and glued everything together. So we had this real-time database that was syncing data and was then interacting with these web service or serverless functions, I would say, to then do external work that we needed to be done. But when it came to the development environment with Firebase, it felt a little bit weird. So there were a few cons with the development environment at the time. You always had to be online. So in order to connect to the database and to actually interact with the database and get data that you actually wanted to swap in and out, you always had to be online. You had to kind of like post data and pull data in to see data changes. There were like offline modes, but like you weren't actually syncing any data when you were kind of in offline mode. So that wasn't really great. So it almost felt like you were kind of developing in production all the time, which really wasn't the best thing. I don't think anybody really wants to be developing in production, so that's not great. Sometimes your teammates might have been sad with you just because you might have been working on a specific feature and you're changing some data, and then it breaks their feature, and now you have this teammate that's like really not happy. And then obviously it comes down to there's a free quota or a free tier within Firebase, and you get a certain amount of requests, and your development time that you were developing with Firebase was kind of like eating into your free quota. So at some point, you would then have to either start paying for it while developing, or you'd actually be paying a lot more per month in terms of production time when your app was actually out there where users were using your application. So there were some hacky solutions to this. You could have created multiple projects. So you could have created like a development project, and you could create a production project, and you could have then worked in your dev project while you're developing, and then obviously then just kind of mimic the rules and change your URL so that you actually then go to your production project once you actually then push your new changes or new features to production. So that kind of worked. For the real-time database, you could actually create multiple databases if you were on the Blaze plan, where you could actually create a production database and in the same project, a production database and a development database. And this kind of worked also. Again, it was just like changing your URL, or you could create some kind of like flavors or something that when you're using a debug version versus when you actually have a release version, you could have that. And then you could also then do something like having different bundle IDs and package names in the same project. So creating two specifically apps inside of one project with different bundle IDs or project or package names. And then that would actually then give you some kind of like separation. But I mean, these were all kind of like hacky solutions to using the Firebase suite of tools. So then the Firebase emulator came along. But the Firebase emulator has actually been around since 2017. I think a lot of people maybe didn't know about it because it was, I think, like in alpha for a while. I kind of found out about it in 2017 by actually watching this talk about cloud functions, where they were speaking about writing different cloud functions, unit testing cloud functions, and they kind of went through towards the end. They kind of showed this emulator where you could actually use this emulator locally to actually interact with your cloud functions and to your database, which was really, really cool. The only thing there is that it was firstly in alpha, I think, at that point, but also it was all command line based. So there was no visualization. It made it really, really hard to use if you weren't always using it. It just wasn't a great development tool at the specific time, but it was kind of like the beginning of what we're going to be speaking about today, which is the UI emulator. So the Firebase UI emulator. So recently, well, I would say a few months back, the Firebase team released the Firebase UI emulator suite. And this is kind of the tool that allows us to develop locally with Firebase. So as you can see on the side, we have our traditional on my left, maybe your right. We have the Android emulator, the iOS simulator, and your web app. And then we have a whole bunch of emulators from the Firebase suite. Emulator suite, which is Firestore, real-time database, cloud functions, hosting, and PubSub. And once we actually spawn these up, and we can spawn these up locally, we will see what is on my right at the moment, a screen that comes up in our browser where we have this Firebase emulator suite, and it shows us all the emulators that are running on our local machine. We will go through how to actually get this set up. So what are the benefits of the UI emulator? So I think the biggest benefit is you'll be able to access your databases, your cloud Firestore database, your real-time database. You can access it offline. So this is a big deal because it's actually running on your machine now, and it's actually not running in the cloud anymore. And you have full control over what's on your machine. You can wipe your environment. You can create a new database. You can do whatever you want to. So this is really great. You can now also run end-to-end tests on your CI/CD. So this is really, really great because you can actually run like some kind of UI test that actually uses a Firebase database to actually check if data is actually coming back correctly and all of those type of things. So you can actually add this Firebase emulator to your CI workflow, and it can help you obviously improve your accuracy in terms of how your application behaves. There's easy ways to import and export data. It definitely helps increase with development productivity as it helps you, because you're working offline and on your own machine, you will be able to work a lot faster and you don't have to have any kind of like issues with teammates maybe changing data or anything like that. You can now also use it to actually unit test your security rules. So security rules are really important within Firebase. It kind of glues everything together in terms of making your databases secure. And sometimes you actually want to make sure that the logic within that is also working correctly. And you can actually use the UI emulator to actually do that also. And then I think the biggest thing for many people is that it doesn't contribute to your quota. So at the end of the day, you're going to be working on your Firebase project, and you won't actually be contributing to your quota. So only your production users will be using your Firebase quota, which is really, really great, especially if you're on the free plan. So that's really, really nice. There are limitations, though, to the emulator. It doesn't support all of the Firebase products. So Firebase has over 20 products inside of it. And the ones that are probably the ones that you're going to notice upfront when you start looking through the emulator is that authentication and storage, two of Firebase's biggest products, are not supported with the emulator at the moment. I have seen a lot of people sending in feature requests for an authentication emulator, especially. I think at some point they might be the team might be working on something like this, because I think the amount of requests that I've seen on the Firebase project for the auth emulator is a lot. So Hopefully there will be support for authentication and storage, but at the moment there's no way for us to utilize authentication and storage. So when you're interacting with the other emulators, it will automatically go to the Firebase production or your project code, and it will actually utilize that, and then it will only use the emulators for the products that it supports. It also doesn't support all Firebase triggers. So it doesn't support triggers where you may be trying to upload an image and you maybe have a cloud function that then triggers based on an image being uploaded. That won't work. That will automatically go up to your real cloud function, and that's kind of not great. But it does support other cloud functions, such as like if you're interacting with Firestore and something then triggers over there. Then if you want to add something back into your Firestore database with some logic on the JavaScript side or TypeScript side, you can then do that. So we'll go through a few examples of that also. So just a quick disclosure is that the Firebase emulator, you'll see a lot of people see it for the first time and they're like, oh my goodness, this is really great. And they're like, maybe we could just use this in production. The emulators are not production ready. They're not part of the production. They're not supposed to be used in production. This is to actually help us with development. So please don't try and host the UI emulator by yourself. I think it might just go through your mind and you might be like, oh my goodness, this is actually, I could probably do that myself and not use the Firebase suite. But obviously the Firebase emulator, the Firebase suite of products is backed by Google Cloud. So they have proper load balancing and all the fancy stuff with having people being able to access your database efficiently. So just try not to use it in production if you were thinking it. So there's just a quick meme for that. Okay, so let's get started with the actual UI emulator. So in order for us to use the UI emulator, we need to install Node version 8 or greater. It might even be version 10 now, but I know that at the time that I installed it, it was version 8 or greater, which is good. I think if you just install Node these days, I think Node's at 14 or 15 at this specific time. I don't know. So as long as you have a version that's greater, then you should be all good. You also need to install the JDK, so the Java Development Kit. It has to be 1.8 or greater again. There's some Java jar files that get spawned up and stuff like that. So you need the JDK, especially for people that are probably using web, the emulators for web, and they're like, I don't understand, like I don't have Java installed on my machine. You kind of, in order to use the emulators, you need to have that. So I've noticed that like people from on the website, they'll be like, they won't kind of understand why this is needed, but the emulators kind of use the JDK or the Java virtual machine to kind of spawn up. And then you need the Firebase CLI. So we'll go through about installing that. So in order to install the CLI, the Firebase CLI, we just go npm install Firebase tools, which is great. It will then install all of that for you. You'll then log into your Firebase account. So you'll go Firebase login in the CLI. That will take you to a website. It will open up. You choose your Google account, and it will then bring down all your projects. And then if you're trying to start a new project, you can do Firebase init, and you can actually just create a project from the CLI itself, which is great. So in order for us to actually get the emulators, though, we need to do Firebase init emulators, and then this will actually ask us what emulators would you like to install. And this is really, really great because we can choose to only install the ones that we actually need instead of just installing all of them. So you will see that for my demo, I've only installed Firestore and Cloud Functions emulator, and I've left the rest out. So it will only install that because that's only the things that I will be using. So that's really, really nice. You can initialize any of them over there. It will look at your JavaScript, your Node.js version. Make sure that you have Java installed and all of that, and we'll let you know, and then it will actually create them. And then for us to actually start the emulators up, we go Firebase emulator start, and this will actually then start running our emulators and you will then see them start up in your command line, and it will show you what ports they're actually running on your local host. Just a quick thing, inside of your Firebase JSON file, if you have things running on a similar port, so I think port 8080 is the default for the Firestore emulator to run on, but that's also a very common port that people use for other things, like maybe some Docker containers or something like that are running, and it might say that, hey, there's something else running on there. If you go to the Firebase JSON file, you can actually go and change the ports that you actually want to run your emulators on. So inside of this file, you can just specify emulators, Firestore, and you go port, and you can say, I want to run it on 8090, and it will pretty much run on 8090. So that's really, really cool. This is just an FYI, because I had something else running on 8080, and I kind of ran into this, so then I thought I'll just put this in here. And then once you've actually said a Firebase emulator start, you will see something like this, where it will then tell you your emulators are ready, and you can then go to the local host URL, and it will then show you your specific emulator, or your emulators. And you'll see something like this. So if you go to localhost 4001, you'll see this thing pop up on your screen, and you will then have your emulators up and running. And you can see it says status there. The status is on, others are off, because those are the ones that are not installed for the specific project. And it also always reminds you that this is a local environment. So this is great. So how do we actually interact with these emulators? So we've got them up and running, and this is amazing. But now we need to figure out, how do we actually interact with them? So how we interact with them is through our devices, but it's also through the Firebase SDK. So there's a few changes that we'll need to make to our Android, iOS, or web applications. Just a few lines of code that actually just points to the emulator and not to the production code that you might be interacting with in the cloud. So the examples that I'm going to be showing today are all Android examples, but I have written a demo which I'll share in some links at the end that show an iOS example also, if you're looking to do it on iOS. And there's some great talks by the Firebase team on how to also do this in web. So from an Android point of view, you kind of need to install Firebase Firestore SDK and Firebase Cloud Functions SDK. So a lot of people kind of don't know that there's a Firebase SDK for functions. So you can actually talk to your Cloud Functions straight from your Kotlin code. Something to mention also is that the Firebase team, in terms of their dependencies, have moved to a bill of materials way of using their dependencies. So you'll see that I haven't specified any version codes for any of Firestore or for Firebase functions, because it will pretty much pull all the latest versions of the Firebase libraries that you have mentioned below it, based on the specific the bill of materials platform that are actually specified on top. That kind of maps all the latest versions to the other Firebase libraries. So that's just a side note. So once we kind of jump into our Firebase code, we've now created a connection to our Firestore in the cloud, and now we actually want to use our emulator. So what we will do is that we'll create a function that says setup in our activity or wherever you want to do it, and we'll say setup Firebase emulator, and to turn this, so we want to go to localhost. So if you're using an Android emulator, you know that localhost is 10.0.2.2. And then what we're going to do is we're kind of just going to set our Firebase Firestore like instance to use the emulator, and then we're going to tell it where the URL is, and we're going to tell it what port it's running on. So we need to specify the port, because we are allowed to change the port, as I mentioned previously in the Firebase in our Firebase JSON file. Then we have the Firebase. What we need to do is we need to set persistence to false, because we might have some kind of persistence that might have been kept over from our Firebase instance when interacting with our project that lives on the Firebase console. So we kind of set that to false also. And then once we do that, we can rerun our application, and we pretty much should have a working version. So if you can see over here, this is just a small video of myself pretty much using the Firebase emulator. So this is actually using authentication, Firebase authentication, showing that it's then going to go to the cloud and authenticate still, which is great. And then once I actually create a poll, well, once I'm going to change some of the values inside of the poll, we can then see I am on localhost on 4,000 over there. And as I change the values in my local emulator, hopefully they will then change inside of my application, which is great. So this is me interacting with the same database. It would have been going to the cloud, but now it's actually just using the emulator suite that's on my local machine, which is really, really great. So this is obviously making it much easier for me to develop locally. I can see everything. It looks exactly like the Firestore emulator, well, the Firebase database, databases that are on the console. So everything should be familiar to you. And you can add documents and collections exactly the same way and edit everything, which is really cool. So then the next part of it is I want to show you how to interact with cloud functions. So as I mentioned previously, that there is an SDK for that, but we still need to write a cloud function locally. So this is just a quick cloud function that pretty much just takes some JSON data, deserializes and puts it into our cloud, into our Firebase cloud Firestore. And what that's going to do is it's then going to reflect inside of our application. So what's happening here is that I just have a quick JavaScript importing some of the libraries. It's a say hello function. It does some random JSON here that I got from the internet. And then I'm literally just adding that specific JSON into a collection inside of the Firestore database. So from an Android point of view, in order for us to actually interact with this specific cloud function, what we need to do is that we need to create an instance of the Firebase cloud functions. And then we need to say, use the emulator for this. So specifically exactly the same local host. Then we get the port that we were running it on. So all the Firebase emulators run on different ports. So just check inside of your console which port it's running on. This one is running on 5001. And all I'm doing over here is I'm saying, function, can you please call the say hello function inside of my project? And what it will do is we'll actually call say hello, and it will send some data to it. And I'm just calling the function, invoking the function at the bottom because this is the add message function. I'm just invoking the specific function over here. And there's a quick small video up next, but something that's really, really important, and this is only for Android. In iOS and web, it kind of just works, but in Android, from Android 9 and above, you have to create a security configuration file, so that you need to whitelist your local your local host for Firebase, because the Android platform kind of still uses the HTTP stack within Android, and this kind of blocks non-secure URLs, and obviously your local host is not going to be secure. So you kind of need to whitelist your local host value. So make sure that you create this specific security XML file if you're on Android 9 and above, and then inside of your manifest, at the bottom over there, we go Android network security config, and then we set this the specific XML file so that the Android system knows to whitelist that specific URL. And then just a quick demo of this working. So what I've done here is I've clicked the register button, And when I click the register button, it's going to call the cloud function and add data to my Firestore database. So you can see over there, I clicked it a few times and it added some data and it said hello, and it gives you all the logs. So you can actually go to the logs and see your function actually doing specific things. And if you have any kind of JavaScript logs also, it will then also show you. So that's really, really great. So the UI emulator can do a lot more than just what I've shown today. Firebase, there's Firebase web hosting that you can also be testing locally. So if you have a website that you're pretty much using and using Firebase web hosting, you can utilize the emulators for that to test locally before you deploy to production. You can run these emulators also in your CI, like I mentioned previously. There's actually containerized emulator images that Firebase provides for you. So inside of the documentation, you can go and check those out. There's also a PubSub emulator where you can emulate your PubSub interactions with cloud functions, which is really, really nice. Real-time database interactions, like I mentioned. And you can also still, like I actually showed in my demo, you can still interact with external services also through the emulator. If you need to go fetch some JSON from another service in order to then put it inside of your Firestore database, you can do that also. And then just some references, like I mentioned, the documentation is really, really great for the Firebase emulator suite. The team has done really, really well. There's 2 examples on my GitHub, so an Android and iOS example. And then the Firebase team has done some amazing talks on the UI emulator, also specifically from the web side of things, and even like I mentioned, unit testing your security rules. And yeah, that's all I have today. If you ever want to get in contact with me, I'm at PJ Apples on Twitter. And thank you for having me. You could have been anywhere else in the world. You could have been watching amazing English football, but you were here with me. So thank you very much.
Thanks, Julien. So that was a great talk. I've used different services from the Firebase, but never dared to use the emulator because of the experience of the Android Studio emulator. But this seems like a promising one, so I'm definitely gonna give it a try. So that was a great talk, and I hope you enjoyed it too.
Yeah, it was awesome. Thank you so much for having me.
No worries. Thank you. See you in the backstage. Yeah.
Ciao.
Bye. Cool. So it's almost time to have a coffee. I'm feeling a little bit numb, so I'll need a quite great rested coffee today. So there will be a coffee break, and after the coffee break, we'll be coming back around 4:45 p.m. And meanwhile, you can check out the agenda for the next upcoming talks. See you around then.
Hello, hello. Hi.
Hello, everyone.
So before we get started, just wanted to introduce myself. My name's Karthik, and I'm from GDG Southampton, also a student at Southampton University, studying computer science and artificial intelligence.
Oh, that's great. To introduce myself, my name is Henna. I am co-organizer for Google Developer Groups Dublin and Women Tech Makers Community Dublin.
Awesome. So the first talk we have for this section is Material All the Things by Julien and Renaud. So if we can just add them to the stream. Awesome. Hi, guys.
Hi.
How are you guys doing?
I'm good. Yeah. Perfect.
Yeah. Where are you guys calling in from today?
From Paris, in France.
Paris. Nice, nice.
Wow.
What's the weather like there?
Sorry?
What's the weather like? Is it
sunny?
Well, rainy?
Not so great.
Okay. Well, it looks like you have a pretty packed slide, so we'll let you get started.
Yep.
Awesome.
All right. So welcome to our talk. My name is Julien Salvi.
And I'm Renaud.
And today we're going to talk about material design on Android. And first, we're going to talk about material design back in the days. So material design was firstly introduced in 2014 when Lollipop was announced at the Google I/O. Then we'll have to wait almost 2 or 3 years to add the first design tools from Google. Before that, we had the concept of material design, but we have to implement all by our own. So no design tools by Google as a developer, and it was all made. But then they added the support design library. They allowed us to implement some nice design material design components. And in 2018, after announcing Material Design 2, they gave us the Material Design 1.1, the real material library to use and build some nice Android UI and nice material design components. And we are now in 2020. The latest will be the 1.3. And of course, the future of material design will be with Compose. So back then, material design was just some concept, as I said, and there is no really some material for developers, so no libraries, no tools. It was about do it yourself for building your own material components. For example, if you had to build your own material buttons, you will have to produce a lot of code. So let's see how we can do it. So we basically add your button, add some height, some background. You can customize your button with some text size. So whatever you want here. For looking like a material button, you also need to add a selector for a nice background. So adding a press color and a default state, and maybe more state if you want to add the enable state or the activate state, for example. And also, if you want to add the nice ripple effect, you also need to add another drawable with the ripple state. And if you need to add some nice style to your button, you need to add also a style. Maybe you need to add a text appearance for your text inside your button. And you maybe add another color in your color resources. Or maybe you have to draw on the canvas for adding elevation for KitKat. So material component, it's very nice, but if you had to make it from scratch, it's a lot of work. You can take a lot of time to make this component, especially if you want to add a time selector, or if you want to implement your own slider. It may take some time, and you definitely have to use a canvas, some custom views, custom variable, and you'll spend a lot of time building your own components, and you'll spend a lot of time in the maintenance. So it's quite a mess. You're gonna build a lot of components, but in the end, Google provided the nice material design libraries, and now let's see how we can migrate from our old theme to the material theme.
Yes, so the point of this section will be migrating to material components. And Julien and we are working in a company called InAppReview. The main product of the company is basically a cash register. And the product was created like 4 or 5 years ago. So we had a lot of legacy, and especially we were on AppCompat, and we had the old design. So the point was to move from this kind of screen, which is quite old. Here it's a tablet where you have a cash register. And the point was to move from here to something more material, and also without touching to the whether Java or Kotlin part. So basically doing some changes only with the XML. So the next slides will be more about return of experience and about the process we had at InAppReview to migrate from the old material library to the new material component library. The first step, of course, is to migrate from the support library to Jetpack. And basically, it means migrating to Android X. This part is actually quite easy because we have the button Migrate to Android X in Android Studio. And also, Google provided the same library, but with a new namespace. So we started from support design, and we just had to change to Android material. So this is the way to migrate to Jetpack. And the second part was to create a brand new material theme. For this, of course, to migrate to material component, we have to create a new theme. What we did, we added a libdesign Android library, Gradle module. And basically what it does, we called it libdesign, of course. It embeds the dependency to material. And here we are now even in the next release, so 1.3.0 Alpha 3. After, to create the new material theme, what we had to do was to build what we call the pillars of our design. And it's what actually Google is providing through the material theme. It's 3 pillars: the colors, the typography scale, and the shape. The colors is the brand color. The typography, you will see it's more about how we render the typography scale, basically. And the shape is the default shape of components within your app. So we work with the designers for this. And what they provided us is some assets. And basically what we had to do is, for the colors, put all the brand colors inside the colors.xml. And we just named after some branding name, color name, like Mercury, Leaf, Watermelon, etc. We did the same for the shapes. And material components comes with 3 type of shapes: the small, the medium, and the large. The small components are used by chips, button, text field, and floating action buttons. The medium components are for cards, alert dialog, and the large components are for side and button navigation drivers, for example. So the shapes.xml is where we put all the shape appearance. Then we define the typographic scale, and we can see here that we have headline 1, headline 2, etc. So definitely it comes from the web. And what is good here is the typographic scale can be used among all the products here at InOverder, even in the brand website, for example, or for the back office, or basically for all our web products. So we design here in the text.xml. After, we create the theme. And we created a base.io. IO stands for InOverder in this case. It inherits from a material component denied. You can start by just inherit from the light no action bar theme, material component theme. And what we did inside, we just linked all the shape appearance components with our custom shape appearances. And we did the same for the typographic scale. So basically, the base theme is where all the common styling goes. And we created another theme, which inherits from base.io. And this is where we connect all the colors. And we support the colors primary, secondary from the material component library. What we did after, we have created the new material theme. We are just updating view after views. Basically, you take any layout and you go to the root. And what we are doing is we apply the new theme with the Android theme. It's not a style because the style will apply only to the view, but the theme will apply to the children. And thanks to the auto-inflation here, what we are doing is basically it starts from app component, app text view, for example, and the auto-inflation will change this to the text view or the material text view. So we don't have to change the reference to the children, like the button will be still button or not material button, etc. So just add the theme in the root of your layout, and then you have migrated to material component. And what we did is it's layout after layout. We add new components. For example, we had buttons, and we had success buttons or warning buttons. So we have to create a new button, success, which means green, and a warning, which means red. So we progressively add new components during our process of migration. And when we define the new components, we can add them to the base IO theme. And this is where we put the default styles. And thanks to the card view styles, material button styles, snack bar styles, we can have a default, we can specify default components. We even have overlays for the theme, like the alert dialog. Basically, this is what we have for the project. This is in Android Studio. We have the lib design here. We define a new file for each component, so styles button, styles card, etc. And here we can see that, for example, IO button inherits from the material component button, snack bar inherits from material component snack bar. So this is the way we customize everything. And when we have done this for all the layout, the objective is to make sure that all the fragment is okay, and then the activity is okay, and then we can also replace, so here the case in the Android manifest, what we are doing is we change the theme from each activity, and when this is okay, then we can change the default theme inside the application. Of course, you have to remove the old Android theme IO in the layout. So to sum up, this is the process to migrate to material component. The first one is migrate to Android X, then create a material theme, then update view, add new components and over, and then when you're okay, remove the whole theme. What we did on top of that is we built a catalog app or a showcase. We added a new app design Android app Gradle module with the dependency of our lead design, and we have several benefits from here. Our components are validated by our designer. It specifies guidelines for new developers. It allows us to iterate, break, improve our design. Basically, we can have a semantic versioning of our design with major changes. Also, it's a sandbox, so we can tweak and try new things within this app design application, because the compile time is very, very fast. And also, it prepares us maybe for the migration to Jetpack Compose, since it's a catalog of components, so it's an app with components inside. This is how it looks like. So you can see that there is a theme summary and also a list of all the components we built. So basically, it's a huge linear layout with all the components inside.
So now we know all the basics of material design, all the themes, all the components. Let's see how material looks like in action. So let's add some nice motion transition to your application. Let's see how we can do it with a material design library. So here I implemented a transition from a card in a list to a single page, and the cover and the title are shared between the two fragments. So the transition will be about the title and the cover, and we will have a nice transition between the two fragments. So when you are building transition with material design, think always about having a meaningful motion inside your application. Material provide nice transition for activities, fragments, and views. So in your fragment A, you can set some exit and re-enter transition to be more like material design style. And of course, you have to set some transition name inside your views, and it should be unique. You can't have the same transition name for example, for two views. And on your fragment B, you'll set your shared element transition. So this is the transformation for doing the nice motion things between the two fragments. For example, here we are setting a duration of 300 milliseconds. We have some nice fade transition between the two screens, and also an accelerate decelerate interpolator. If you are dealing with images, if you need to load images from the internet, you have to think about postponing the transition. So you have to wait your images is there, it's ready for your application, and it's ready to render before starting the transition, unless you will have some glitchy animation. And to navigate from the fragment A to the fragment B, thanks to the navigation component, you can pass the extras data for the view for the transformation. Then you can navigate from fragment A to fragment B. So let's see a bit of code now on how you can material all the things in your application. So here, for example, we have our shapes here in our fragment movie. In our fragment, we have the shapeable image view for doing the nice cut corner image view. And in our fragment, we have our transition here. We are setting a material container transformation. And of course, as we are loading an images, we have to postpone and start the transition when the background is there. And let's see a live demo of the application. So here is our Android device. We are launching the material sample, and you'll see a nice bounce when the list is popping. So it's thanks to the spring animation from the material design library. And when I click on, for example, on the Return of the Jedi, you can see the nice transition between the card and the single element. And if I go for the design library, you can see here all the components we are using for our application at inner border. So it's the material component, so it's really a playground here, so we can test and implement all our material design theme and all our material design components. And yeah, that's it. Thank you very much for listening. And if you have any question on material design or how you want to migrate from your old theme to the material theme, or on the material components, feel free to ask or ping us on Twitter if you want to.
That was amazing. Thank you so much, Julien and Renaud. So do you have a GitHub link of the demo that you gave so that the viewers can get access to it? Would you?
We have our sample, our code sample of material design available on GitHub. And yeah, I can provide the code sample.
Oh, amazing. Thank you so much.
Awesome. Thank you.
Thank you.
Oh. Okay, next we have with us Santiago from Amsterdam. He will be talking on machine learning on Android devices with Firebase and TensorFlow. Thank you so much, Santiago, for being with us today. Would you like to talk about some of your experiences and your fun facts?
Thanks, Hannah. I'm actually from Bogota, Colombia. I did live in Amsterdam for some time. But yeah, I'm a Google developer expert in Android, and now I'm the CEO of Ada School. It's a social initiative to promote tech education around the world.
That's awesome. How long have you been doing that for?
I actually started with founding a community in Bogota, which is Android Meetup Bogota. It's the largest community in the country, around 2,800 members. And from there, I got the inspiration to transform this into something more structured. So I launched before the pandemic an Android course with 6 students, and it was really challenging, but as well discovering how you can actually change people's life through education and technology. So a lot of the students that graduated from this course got better jobs with better salaries, and also learned some best practices and things specific to Android. And from there, I decided to transform this initiative into a tech school that is called Ada School. So you can actually see on the URL ada-school.org. And it's actually only in Spanish. We're running our first pilot in Latin America. But so far, we have students from 5 countries, from Honduras, from Venezuela, from Colombia, from Bolivia, from Dominican Republic. So it's becoming a global initiative. And it's amazing to see how people is getting more and more connected through this, like us today. It's really a pleasure to be part of DevFest UK and Ireland and get to connect from developers all over the world.
Thank you for coming. So you said something about the language being Spanish. What languages do you speak?
I speak Spanish and English, and some words in Hindi, some words in Dutch.
Oh, wow. Nice.
Wow, that's amazing.
Yeah.
Are you a tea or a coffee person?
Sorry?
Are you a tea or a coffee person?
I'll say both. Like, of course, Colombia, we have one of the best coffees in the world, and it's really nice to drink coffee from local farmers, very fresh. But sometimes also I drink tea, so I wouldn't say go for one or the other.
Okay, thank you so much. So do you have any advice for our viewers who are looking to become as speakers and getting more comfortable with the Android technology? Do you have any advice for us?
Yeah, definitely. I think that there is every day more and more documentation, open projects, places to learn, and people also willing to share the knowledge. And from my experience, the best way to learn is to teach someone else what you just learned. So these communities are always places, and I have seen people that came to the community for the first time with no knowledge, and now they have senior level roles in big companies. So it's actually just, you have to have the will to learn and a lot of discipline. I think programming has a very high, like steep curve, learning curve, and once you pass it over, you can start using, and we're reaching amazing time, as you're gonna see in the talk today, where there is more abstractions, and there is, for instance, now the codeless apps, and there will be coming more initiatives like this where you don't need to understand a lot of the fundamental concepts, and you can create things that add value with little less effort. So I will say to focus on those technologies and also specialize in something, because it's also easy to just start picking into different frameworks, but then it's really hard to master any of those if you don't focus on either Android, iOS. You can, of course, later on, once you get more experience, start switching if you're interested in other technology. But I will say at the beginning, it's better to focus on one technology and understand the architecture, the way it's designed. Because, for instance, Android is a service-oriented architecture with, as you will see, with little few lines of code, you can use services that others created for you. And you don't need to create everything from scratch, which is something us software engineers tend to do a lot. We like to reinvent the wheel.
Absolutely. And I totally believe when you say that if you want to learn something, you teach, because I've actually lived and experienced that fact myself. So it happened with Android architecture patterns when they were introduced at IO 18, I believe. So at the time, I had no idea about that. So I decided, okay, I'll go ahead and give a talk. So in order to give a talk, I had to watch so many articles, videos. So that was how I actually became I became quite acquainted with the topic. So yeah, I totally believe the fact.
Definitely. And I think when you're gonna put your ideas, when you learn by yourself, you don't confront what you think you know, but when you want to explain this to someone, you go through this process of rethinking the concepts that you think you already know. And in this process, you understand deeper and deeper. And yeah, it's amazing how this works. With transfer knowledge actually helps you get more confident and also become a public speaker eventually, if that's what you're aiming for.
Absolutely.
Definitely. I'm mainly a Flutter dev, so slightly different to Java and Kotlin, but I used to be a Java developer, so yeah, it's awesome to see you here. And I guess we'll let you get started with your talk.
Great, thank you. So I'm gonna put this present mode. So thank you so much for having me. It's really an honor to be part of DevFest UK and Ireland. And today I'm gonna talk about machine learning on Android with Firebase and MLKit. I'm Santiago Carrillo from Colombia, and I'm the CEO of Ada School. I'm a Google developer expert on Android. So the agenda for today, we're just gonna take a very, very basic understanding of what machine learning is and why I really think this is very important for any industry to at least start exploring. We're going to talk about TensorFlow and TensorFlow Lite, which are the framework that allow us to do machine learning. And then Firebase, which is the technology that let us use this on the context of Android and any other SDKs, as you will see when we talk about Firebase. And then we're going to do a very short example on how to use actually one of the specific areas of machine learning, which is computer vision. We're going to make a small demo that you can use to classify image. And just take a photo from the phone and just generate labels from this image. So let's start with what is machine learning. Machine learning is something we hear a lot these days, and it's definitely transforming the world as we know it. There is a lot of automation happening, but let's start to understand what machine learning is in a very basic level. And machine learning, I see it personally as a new way of programming, where actually you're using the machine to train on a specific task, and we definitely need as a starting point the data. Once you have the data, you can basically use any machine learning algorithm to infer some possible output. So what happens is we have a large set of data. We process this data using a machine learning algorithm, and this outputs a machine learning model. And this model will be the starting point. And what actually is happening today, there is a lot of models, because in order to build this model, you have to have an advanced level of statistics and mathematics. I personally never dived into this area, but what we know is there are already a lot of models created by data scientists or machine learning engineers that are available for us to use, and actually companies like Google are putting these models which we're actually going to use today. Once we have this model, what you can actually do is predict a possible output. So then you have this trained model that knows a specific domain, and I can provide some data and pass it through this model. And the output will be what we call a prediction. So this prediction will be a number from 0 to 1, where 1, it means is 100% accurate that the output is. And probably if we see it in a specific example, is easier to understand. So one of the examples that you probably see is how to classify images. So here we have a cat photo, and this cat photo goes through an inference process where at the end it will output if whether it's a cat or not. And if it's a cat, it will also give you the accuracy. So the more data you train your model with, the more accurate it becomes to predict if an image is either a cat or a dog or any other kind of animal. And then this can have multiple uses. For instance, in agriculture, they're using these models to help farmers find different plagues they can have. And it's very interesting how this is taking off. This is a specific area of machine learning known as computer vision. So in order to use machine learning, as many of the things in computer science, we need a framework. And the framework we use is known as TensorFlow. So TensorFlow is an open source machine learning platform from Google. This machine learning platform, it allows you to use basically the models. And as I said before, and I will show you afterwards, that you can see there is many models from Google available for you to download and use in different contexts. So TensorFlow is basically the technology that allows you to use machine learning. And now what's happening is like the TensorFlow models are being optimized in something known as TensorFlow Lite, used to like low-end devices or like Android phones or IoT devices. So you can actually take this process and complex computations and make them simpler and portable to mobile devices. And this is actually what we're going to use today. So basically, you pick any model, you convert it, you deploy it, optimize, and make it more efficient to work with low-end devices like Android phones or different IoT devices. And then you can run this model to create or run the different models. As you can see here, this is the official documentation of TensorFlow. It's highly recommended. And here you can see that they have different models available for us to use today. So we have image classification, which is actually the one we're going to use today. You have object detection, pose estimation, smart reply. This is probably if you use Gmail, you've seen this working, that it helps you write your email faster. You have segmentation, the style transfer, text classification, natural language, and on-device recommendation. So my message that I want to deliver today around this is There are already many models created for us to use, available and free. And machine learning is reaching a point where it's more like black boxes and you can just plug and play. And it really makes a difference if you use machine learning on your product. Then the next technology we're going to use is Firebase. So for those who never use Firebase, Firebase is basically a backend as a service. It was acquired by Google around 7 years ago. And basically, it kind of gives you the premises of you don't worry about your backend. We will make sure it scales and provides you the services you need. Like, for instance, authentication, if you need push notification, hosting, if you want to run some functions on the cloud, they do that all for you. And you only need to worry for your product and focus on the part that matters for your user. So they basically give you infrastructure. They also have a service of like real-time database. They have like another vertical that helps you like understand better your audience and also understand how your product is failing or how you can make it better. And then they also provide different tools like for A/B testing, prediction, Google Analytics that will drive you to get a product that is more accurate to what your user needs. And then what we actually gonna use today is Firebase ML. And Firebase ML Kit is basically machine learning on the mobile context that you can usually use. As you're gonna see today, with few lines of code, you can port these models on TensorFlow Lite and use them directly from your device. So now we're gonna go into the code and see how we can actually use machine learning. But before we do that, I'm just gonna walk you through. So this is actually the Firebase console. So in here, you can select the different services that you wanna use. For instance, if you need authentication on your application, you can just go here to sign in methods, and then you can use Google, Facebook, GitHub, Twitter, Microsoft, any other like authentication that you wanna use. You can enable it and with few lines integrate. So these actually Firebase is a great tool if you have an idea or a prototype that you want to build, and you can do it with very few lines of code. Then we have Cloud Firestore, which is a real-time database, also very good to create prototypes that you can connect with also few lines of code. The real-time database, which is kind of an older version of Firestore, the storage to save files, hosting if you want to deploy an application, and functions if you want to run code like on the cloud that basically you invoke from your remote device. But then what we actually going to focus on today is machine learning. And as you see, like one of the things I really like about Firebase is that it's very well documented. So if you click here on Get Started, it will basically ask you which model you're going to use. And the one we're going to use today is basically the image labeling. So if you click on Get Started, it will actually take you to the documentation. So in here, we have two options to run this model. So you can actually run MLKit on device. And the advantage for this is actually it will run offline. So you can optimize this model. And if you have a situation where you have low connectivity or no connectivity at all, you still be able to run. And the best thing, this model is free. Of course, there is always a trade-off. So the trade-off is this model won't be as accurate as you use the one in the cloud, which will be the latest version updated by Google, which will be more accurate and give you more prediction or more possible image label. As you see, the image labeling categories, it's quite larger compared to the normal one. Once you select this, you can basically click on Get Started, and this will take you to the documentation step by step, so you can either go for iOS or Android. Today we're gonna go for Android, but then if you want to explore later on another technology, you definitely can do it. And here it will guide you step by step of how to do that. The other thing about here, we have different models for different purposes. So if you're exploring at your organization, your product, or anything you're building, how to use machine learning, you can see the different models that are available, and basically you can see how you can use them and definitely get started on the documentation. There is also another option that is quite interesting that is known as auto machine learning. And here what you can do is actually in a very simple way create your own model. So you can actually upload images here, and then you will generate this model so you can use. So if you have a specific context or domain that you want to solve a problem using machine learning, basically how it works, as we saw in the previous slides, you have some data, and this data you want to predict an output. So you provide as much data as you can. The more data you provide, the more accurate your model becomes. And then this will provide you an output, and it's up to you how to interpret the results. And in this custom model, what you can actually do, you can go to TensorFlow like official documentation, find the existing models, and you can actually upload the one. And this will help you like do this processing of this model optimization, so it's actually shippable and able to use on your Android device. So this is kind of the introduction to Firebase. It's free to use, so I encourage you, if you haven't used it, to create an account, start playing around and prototype, because this is actually a really good way to learn, where you don't need to worry about creating a backend, but you can actually have very interesting products that actually have interactivity and a backend as a service. Now we're gonna dive into the code, and we're gonna basically, what we're gonna do is create a simple application. So this is the project so far. We just have a floating action button. As the previous talk, they were talking about material design. So we're also gonna use it on Android, and there is many libraries that let you use the components here. So you click on this button, and what we're gonna do is something very simple. That is just take a photo, and then we're gonna pass this photo to the labeler generator. So it gives you the labels associated with this image using machine learning. So in this first step, nothing complex. I just created a basic project where we have an activity. This activity has this layout that you see here with a floating action button, and it basically does nothing. So the next step that we will need to do in order to integrate machine learning is add the Firebase configuration. So just gonna go ahead and check out this revision. And in order to add Firebase, so the first thing you need to do is go to your manifest. As you know, because we're gonna download this model from the internet, so we need to give our application permission to access the internet. So this is the first step. The next step is adding the dependencies. So actually Firebase requires the Google Services plugin, so it actually can use, because a lot of the libraries used are embedded in the Play services, so actually Firebase uses it. And the next thing, we're gonna add the Firebase library. So first I just added the analytics one, so we can actually make sure the integration is correct. And the next thing we need to add, which actually this file you can generate from the Firebase console when you go to project settings. Since this one is already configured, I will get this configuration file. But when you don't have an app, it will just show you a menu like this, where you select the technology. And once you select the technology, it will give you a step-by-step guide. So here, the important thing is your project package should match what you state here. And if you want to use Google Authentication, then you need to add your SHA certificate, so you can actually do the authentication underneath. Once you finish this process, the output will be this file. It's a JSON file where you basically have all the metadata to connect to your Firebase, and it will allow you to use any of the Firebase services. So this is the second step. Once we have configured Firebase, the next step will be just to add the code to capture the image. So as I mentioned before, Android is a service. You can see it as a service-oriented architecture where the operative system has different services, and these services can be invoked using a message class known as intent. So in this case, the intent should have an action that is sent via the constructor, and once I send this action, the operating system does the dispatch. And basically, an intent can be either explicit or implicit. This is explicit. It basically says specifically which application I want to run this action for. And if it's implicit, it lets the user pick. And an example here that you probably experience is if I want to share a photo, the next step, it will show me the applications where you can share. That usually is Facebook, WhatsApp, or any other app platform that allows you to do the share. So here I just actually created a function called dispatch picture intent. Dispatch picture intent, basically what it does is creates an intent that basically will ask the user to launch the camera. And then once we get this image, we'll get the bitmap, and the bitmap will be basically displayed on our view. So this is just, we haven't still done anything with machine learning, but basically we have the code to just activate the camera. The next step, we're basically going to add the code so we can actually use the machine learning like code and logic. So I'm just going to check out this revision. And actually, I shared with the organizers the code that you're seeing today. This is free to use on our GitHub organization of the Android Meetup Bogota. So feel free to go through the steps by yourself. I think the best way to learn is do it yourself. And actually, the only step that is required is that you need to set up your own like Firebase account and configure the Firebase step. But I think it will be great as a step for validating and learning how this works. So as you see here, I have changed the code a little bit. So now we have the dispatch picture intent. And basically, we added another function that is called find image labels. And I pass as an argument the bitmap that was obtained as result from the intent that actually is, like triggers the camera. Once you get the bitmap, then all you need to do is call this class is a static method from Firebase Vision Image. You say from bitmap, and then what this does is basically transforms the image to a format that is actually understood by the Firebase Vision instance. So this one actually will be processes and extract the labels that we want to see. Then what we do is we create or obtain the instance of the labeler. The labeler, in this case, we're using on-device image labeler. In order to use this on-device image labeler, you actually need to add as well to the manifest a metadata. So actually here with this line 30, this metadata, what it does, it says import the dependency. So basically, once you run your app for the first time, you will sync to Firebase and download the label specific dependency so you can actually use it on device and offline. So once this happens, I get the instance of this labeler, and all I have to do is just call one function called process image, where I pass as an argument the bitmap like transform for the Firebase Vision image that I created on line 45. And this will actually have a success listener because, of course, this is a synchronous process. And then in this synchronous process, once it's successful, I will get the labels. And all I'm going to do in here, in this specific example, I iterate over the labels, and then I add these labels to a text that it will display in the console. Then, yeah, the other changes I made to this project are basically just updating the library so you guys can make sure the project is up to date and works. And now I'm actually just going to show you the demo and leave some room for you guys to ask some questions. So I'm actually going to use a technology called Scrape. So I'm not sure if you have used it before, but if you haven't used it, this is quite useful and it's free to use. It's from Genymotion, and this will help you do presentations. Just a second, this is not connected. I need to close. So you need to make sure you don't have more than one device running. So because this uses the Android debug bridge. So it will actually not work if you have two devices running. But once I have it, so this is actually a mirror display of my phone. I'm going to just kill the application to do it again from scratch. So here's the demo. When I click the floating action button, it will launch my camera. And I have here some sunglasses that I will use for the demo. I take the photo. And as you see, these are the labels that are generated associated with this image. As you can see, there are some images or some labels that are not accurate, like hat. So you can actually play with the accuracy as well in here. So when I have the label will have an attribute that is accuracy. Yeah, I think this is not compiled, but basically this label will have an attribute that is the accuracy. So you can actually, if you want to filter out some of these results and make sure you only take the ones that are 90 or 95%, depends on what you do, you can actually use this specific object to make sure you have the accuracy you want. And this is basically it. I'll give you back some time for you guys to ask some questions, and we can definitely go through any of the concepts I cover. But this is what I wanted to demonstrate today. Like, we're reaching a point where machine learning and many technologies are kind of abstracted and easy to use for us. And as you can see, we made something with very few lines of code that if you put it in the context of whatever you're creating, you can add a lot of value. So thank you so much for listening.
Thank you for that talk. It was a great talk. So next up, we've got Christopher. Oh, we wanted to do questions. Sorry, completely forgot about that. Are we getting questions from the comments? Doesn't look like there's any questions. Say, for example, how do you export a TensorFlow model from something like Colab?
I actually haven't done it, so I wouldn't be able to provide the answer.
Okay.
Right. But what I know is, I'm sure someone else has faced this problem, as we were saying before. And I think programming at the end of the day is just transforming data from one format to another. Call it machine learning or anything, and there will be more and more pipelines. So I'm sure at some point, and there will be some solution for doing that.
What about, have we looked into training models on Android yet? So you can create small models on Android and then train them and then possibly use them directly without using a computer or a laptop?
Yeah, like I have tried that, and I think still it's not there yet, because you have to have like a very powerful phone with a lot of GPU power. And it's still, like, I think at this point, what people do is basically you need to have a backend where you send the images and the training happens there. Like, this training process still requires high computing capacity. Then I think it's not there yet, but I'm sure the clever engineers then still create more and more abstraction will figure out how to do it soon.
Yeah, definitely. What about visualizing networks on Android? Is there a way to visualize networks like TensorBoard, if I'm not mistaken?
Not sure. I actually never worked with that domain.
Okay. If you have any questions, drop them in the comments, guys. Is there anything you plan on doing after this talk, Santiago?
After this talk, just relax. Yeah, no, maybe go for a cycle ride or just get some air, because I think this is also something from this lockdown. We spent way too much connected, and we forgot important things like breathe and walk and just take time for ourselves. So I highly recommend everyone to just, after the event, go for a walk, breathe, and be human as well for some time.
Yeah, definitely. So we have a question in the comments of the YouTube chat asking, is speech recognition available for free?
Is speech recognition? So actually, like, the best way to find out is definitely on the console. So if you go to machine learning here, and here we, I think in here they don't have the speech recognition, but what I would do, because if you put the custom model, then I think this will come for free. So I'm sure if you find a model on speech recognition and you add here custom model, this will do the optimization and let you port it into the phone. And if you put it as offline, then it should be free to use.
That's awesome. And what about, so I know that Google Cloud has a lot of machine learning capabilities. How would you compare connecting to the cloud versus using on-device machine learning?
So on-device is definitely limited. Like I use them both, and definitely the amount of labels you get from the others is definitely higher and more accurate. So you definitely have those trade-offs. But what I would say, if you have something proprietary or for your own, then you need to aim to have your own train model, that you are the one that actually keeps training it. Because of course, Google lets you use their models, which are definitely trained with a large set of data, but then this comes to a price. So it depends what you specifically want to do. But then, yeah, that's the main trade-off that I see so far.
We have another question from the YouTube chat asking, what are the privacy implications when you use this technology in your app, and what should you tell your users?
I think this is actually highly important in terms of privacy, but like I think the privacy is definitely around the data more than the technology. I don't think you need any, like, if the machine learning is used to give value to your product, and like if you're using private data of the user to train the model, you definitely need to get concern from the user. But if you're just using it around the experience, I don't think there is any need to get some privacy approval by the end user. So it's always, you should always be careful about the data you use to train this model and where you do it. If you do it on Google or any other cloud provider, there is always implications around data. So that's what you should look for.
Do you know any good sources to get data sets from, large data sets?
Large data sets, definitely on GitHub. There are some open source data sets, and there is one very interesting as kind of a learning case of plants. So actually, you've probably seen a plant that helps you classify different plants, and that's a very large data set that I've seen. And organizations like NASA are actually opening a lot of data sets. Of course, those data sets are for few people, because if you need large capacity to process satellite images, but I think a lot of interesting will come in the near future.
Awesome. Hannah, do you want to take this question?
Yeah, sure. Thank you, Karthik. We have another question from Ravi Sara. She's asking if there is a newer version of the on-device model available. Would it be downloaded automatically, or would we have to release a new version of the app with the newer version?
No, this is downloaded automatically, because as you've seen here on the manifest, I'm not specifying any versioning. But this is kind of the nicest thing of Firebase, which you also need to be careful. It kind of creates you like a lot of abstraction. So for instance, if you use the database, it does the auto syncing, it does the network connectivity check for you. So the syncing will also happen for you, and the newer version will be downloaded.
Thank you.
Awesome. I think that's all the talks, all the questions that we have in the chat. Thank you, Santiago, for coming on DevFest 2020, UK and Ireland. We have a lot of people watching around the world, so it was great having you. And it was a brilliant talk.
Thank you so much, guys, for having me, and I wish you a lot of success with the rest of the event, and congratulations again for putting this together.
Thank you so much. Wish you a great day ahead.
Awesome. So next up we have Chris, who's going to be doing a Flutter Q&A. So let me just add Chris to the stream. Awesome. Hi, Chris.
Hello, can you hear me?
Yeah, we can hear you.
Loud and clear.
How are you doing today?
Doing great. Thank you for having me.
Thank you
Where
for
are you
coming.
joining us from, Chris?
Sorry, what was that?
Where are you joining us from? The States?
California.
Oh, okay.
So it's
That's awesome.
the morning.
What's the weather like there? What time is it as well?
It's beautiful. It's very warm. It feels like summer right now.
Oh.
That's awesome. What time is it there?
9:45 a.m.
Oh, okay, so you didn't have to wake up too early for this talk.
Yes.
Nice. So you currently work at Google as a developer advocate?
No, I'm a software engineer
right.
on the Flutter team. Yeah, so I am not a professional speaker.
And what's the difference between a developer advocate and a software engineer? I'm just curious.
So the and again, I hope I get this right because I'm not a developer advocate, but the developer advocates are, I know as a software engineer, working on the product, we depend on the developer advocates. They sort of, well, one thing they do is they actually build Flutter apps, which I do not do for a living. And they'll build apps with the very latest versions of Flutter. They'll experiment with new APIs we introduce. And a lot of times they'll say, hey, this API is really difficult to use, which I think a lot of times as engineers who are actually building it, we don't have that perspective. And they also are getting involved with the community, doing events like this. And so I think they really hear what the community is saying and the pain points that the community has, and which they are able to communicate back to the engineers. So I sort of see them as a important connection for the engineers, which sometimes, if you spend weeks building something very intricate, you kind of lose perspective on what it is or how it's going to be used. So.
Yeah, definitely. Awesome. So, just before we actually start the session, if you have any questions, feel free to drop them in the YouTube chat. We'll be asking throughout this session. So, Chris, do you want to give us a quick intro into Flutter?
Sure. Okay, let me share my screen. And okay. Can you see that?
Yep.
All right. So in case anyone hasn't or doesn't know a whole lot about Flutter, I just thought I would introduce it. So with Flutter, this is Google's UI toolkit for building beautiful apps for mobile, web, and desktop from a single code base. So the Flutter team's vision is to make building high-quality user experiences dramatically faster and easier through a beautiful, fast, productive, and open UI toolkit for any screen. And I'm going to break down all of those buzzwords. And a client-optimized programming language for fast apps on any platform. And that programming language is Dart. So with Flutter, whereas usually you start with the question, where do you want your app to run? We want developers to start by thinking, what do you want to build? And with Flutter, you should be able to then decide where you want your app to run, or it can run multiple places. So let's break down the 4 pillars of Flutter, which are beautiful, productive, fast, and open. With beautiful, Flutter controls every pixel on the screen. So the goal is that the designs that your designer comes up with, the developers are able to actually build exactly, and that there won't be any compromises between design and the actual product. Fast, Flutter apps are compiled to native machine code, and they're optimized for whatever platform, like an iPhone or desktop that you're actually running on. So our goal is that Flutter apps will run as fast as your hardware can handle. Productive, with Flutter, I think as an engineer, the most compelling feature of Flutter is stateful hot reload, where as you can see from this little GIF, the app is running on the simulator and you can make code changes and then push those changes to the app that's running, and under a second, it'll update, and your app state will persist, but whatever UI changes that you made will be reflected in the running app. And this is really a game changer for iteratively developing on a UI. And finally, Flutter is open. That means the SDK is open source and freely available. You can look at all of the source code. You can, like if you don't understand why something's working, you can jump from your editor right into the source code that defines it. And you can also upstream your changes and file issues. So what makes up a Flutter app? This is sort of the architecture of a Flutter app. So at the top level, you have your app code, which is written in the Dart programming language. The next layer below that is the Flutter framework, which is also written in Dart. This is what defines the widgets, which are sort of the building blocks for your UI. Gestures, which are sort of how it defines user interactions, like taps and swipes. And so all of this you can jump to in your editor. You can make changes locally if you want, because it's all in the same programming language. The next layer under is the engine, which is what handles the actual rendering. It's programmed in C++ so that it will be optimized for speed performance. That includes Skia, which is the graphics library that Chrome uses. There's a text engine. There's the Dart runtime. And this is going to be compiled into machine code for whatever target platform your Flutter app is going to run on. Below that, there's a very thin platform-specific runner that just sort of glues in everything above it to the native hardware. And then, of course, on the bottom, there is whatever device your Flutter app is running on. And because of this architecture, Flutter apps are able to run on mobile. That means iOS and Android. And this is production ready today. We are in a public beta for Flutter for Web. And alpha level is Flutter for Desktop. That's Windows, Mac, and Linux. And also, there's a lot of possibilities with embedded devices. And who is using Flutter today? Well, there's a lot of companies that are using Flutter in production. And a lot of these teams also are participating on GitHub and in the open source, filing issues, contributing patches upstream. So even though Google did sort of start Flutter, it's much more than Googlers who are participating in Flutter, and maybe some of the people watching the stream do too. So thank you. That's my short little intro, and I think we can go to any questions we have.
Awesome. Thanks for that intro. So to begin with, why would you use Flutter over something like Kotlin or Java, assuming you are only making an Android or iOS, an Android application?
Okay, so if you, well, first of all, I would say that I think personally the most, as I said in my little blurb, stateful hot reload is a really compelling feature for a developer, in that you, because when you can spend like an hour coding up a new feature, and then you actually run it, and then, at least for me, almost always I'm like, oh, everything's wrong. This is not doing what I thought in my head it was going to do. And with stateful hot reload, you can leave up the simulator in part of your screen and then just start coding up changes, make fixes, change a line, push the change to your simulator in under a second, and then see, oh, that's still wrong. Okay, let me change it again. So that, for me personally anyway, that would be the biggest reason to use Flutter.
That's awesome. There's a couple of questions from the comment section. Is there a good place to find a tutorial for Flutter with WebSockets, or just Flutter tutorials in general?
That is a very good question that I don't know the answer to. I know that there are the Flutter team maintains a set of code labs. I do not believe there are any WebSocket specific ones, but yeah. But I'm sure there are WebSocket tutorials with Flutter. I cannot personally endorse one, as I haven't used one.
Yeah. Okay. Another question we got is, this is a long question, but when Google releases a new feature for Android, how long does it take to transfer over to Flutter, would you say?
I would say that it depends on how complicated the feature is, but definitely the goal, and I generally, I mean, I think like with the past release of Android, I think we got them all into stable Flutter before the Android became publicly released. So this is, yeah, and this is not specific to Android. This is the same with iOS. We put a lot of effort into testing out the like beta releases of these operating systems, and yeah, just trying our best that stable Flutter supports the newest of all the platforms that we support.
Yeah, that's awesome. Let's look through this. Ooh, why does Flutter use Dart? And what language is similar to Dart?
Well, I'll start with the second question. Personally, well, so Dart sort of is related to JavaScript. I think it was sort of started as a optimized version of JavaScript, so it is very similar to JavaScript. But I would say taking in a lot of sort of Java / Kotlin type object-oriented paradigms, and it is statically typed. So.
Yeah, whenever my friends ask me what language Dart is like, I just tell them it's like Java and JavaScript just merged.
Yes,
that's the best description.
I would say that, because definitely when I started on the Flutter team, I had never programmed in Dart, and I was concerned about that. But then it turned out not to be an issue. I found that Dart is very, if you know other common programming languages, then it'll be very accessible.
Yeah, definitely. And the other question, why does Flutter use Dart?
Yes, very fair question. And I believe that there was a whole list of criteria that the Flutter team, this is like from before I was on the team, but they came up with a whole list of criteria for the programming language that they used, and Dart was the only one that met all of them. I think the most important one was that it would be able to compile to native machine code, but also have a just-in-time compiler, which is sort of the secret sauce to how stateful hot reload works, right? Because there's a just-in-time compiler, which when you're in a debug mode Flutter app, you're actually shipping the runtime inside of the app, so that you don't have to, right? If you make a one-line code change, you don't have to recompile the entire app and ship it back into the phone or simulator. You can just compile to intermediate representation the particular change, push that, and then the app is able to sort of insert that in real time into the running app. So that's the reason why Flutter uses Dart.
Yeah, I'm really glad they chose Dart because it's such a nice language to use as well. The next question is, how can I get involved in contributing to Flutter?
So, yeah, so all of Flutter development happens on GitHub. It's github.com/flutter/flutter. And I would say the first thing to do is to start using Flutter. And then the best first contribution would be like when you're starting out, any holes that you see in the documentation or anything that's unclear, you can quite, especially if you're using like one of the Flutter IDE plugins, you can just jump to the source code, find exactly where in the source code that is, and then you can make a pull request to improve the documentation or make it more clear. The website source code is also on GitHub, so you can also, improve the documentation on the website. And then in terms of like making code changes, I would say, hey, just use Flutter and then find something that's not working out for you, or like, and then make a change there, rather than just like looking for something to improve. I think a lot of times that, yeah. And if you do want to make like a more substantial change, I would just say make a proposal on GitHub first. That way, other maintainers can interact with you and give you feedback.
Awesome. Another question is, can I use Flutter in my existing Android or iOS project?
Yes, you can. With Flutter, we call this add to app. And there is on the website, there is a guide to doing this. But basically, you can make a native view in your existing Android or iOS app that embeds a Flutter page or Flutter app.
Okay. And so Flutter's made up of widgets. How would you describe a widget to someone?
Right. So a widget, I would describe a widget as sort of the atoms of Flutter UIs. Widgets do not necessarily have to be, I don't know. I think traditionally you think of a widget as a graphical, a GUI element, like a button. But with Flutter, we have a saying that it's all widgets. So even things like padding would be a widget. So yeah, and sort of the paradigm with building Flutter UIs is composing widgets together. So the idea is that you can compose together like multiple layout widgets that will define how your UI looks.
Awesome. Next question is, can I use Flutter for Web in production?
So Flutter for Web is in beta right now. And I believe some people are using it in production, but they are, yeah. So I mean, my idea of a beta is that this is when you join a beta, you get a benefit, which is that you get to use the latest and greatest, right? Something brand new. And also you are sort of testing out the kinks in it. And and what the development team gets from offering something in beta is they get early feedback, and they get people contributing feedback and hopefully upstreaming changes. So I would say I would not build a production app today, but I would say, hey, try it out, play around with it, and see how it works.
Awesome. Another question is, does Flutter run at 60 FPS and can it run higher? Sorry, there's two questions in that dialogue.
That's fine. Yeah, so Flutter, there is no inherent cap to the frame rate of a Flutter app. So, and I'm not a hardware expert, but I'm pretty sure that there's like 120 FPS phones that are available. And yeah, so it basically, the only limitation to the frame rate of Flutter is your actual hardware. So that Flutter will run at 120 FPS if your hardware supports it.
Okay. And what about, where do you find packages for Flutter and how well developed are they?
Right. So the website pub.dev is the package manager for Dart. So it's sort of the Dart's equivalent of the NPM registry. So yeah, and I believe that in the search engine, you can search specifically for Flutter packages. And like any community package manager, the answer to the quality about them is it varies. But the Pub does have a scoring system that it measures certain across a number of different metrics, such as like conformance, like best practices and conformance to APIs. And I think for Flutter packages, it also looks at which of Flutter's platforms that it supports.
Okay, that's awesome. And can you make responsive apps in Flutter? Because I know that phones are getting all weird shapes and sizes nowadays. So yeah.
Yes, certainly. Yeah, that I mean, this is very important for the Flutter team, that your apps that, and we take quite seriously the idea of building your app once and running it on all screens. And so yeah, Flutter's widget library has media queries, and the actual like widgets, that's not my strong suit, so I actually not sure how to do it, but I definitely know that. Yeah.
Okay, right. So what specific like part of Flutter do you work on at Google?
I work on the command line tool and the release engineering.
That's awesome. Most of the questions we're getting are about like the UI side. I'll see.
Sure, you can still ask them.
Okay. How do you deal with different component styles in iOS and Android? Like, if you wanted to show an iOS widget on iOS, but an Android widget, or the version of that widget on Android, is that possible?
Yes. So this is sort of a this is a fundamental question, I think, that the Flutter app developer needs to ask themselves, because there's basically two ways you can go with your application, right? You can try to get, well, first I should start by saying that the way Flutter works is Flutter renders every single pixel on the screen. So it is not hooking into the operating system native widgets. And Flutter provides two different widget libraries called Material and Cupertino, which are sort of taking the design paradigms from the Android or iOS side. And but from there, that you could either go to having a unified UI look for your app, or to have basically two different versions of your app, one that looks like a native Android, and one that looks like a native iOS. And it's definitely possible, but I would say that sort of with Flutter's philosophy, it lends itself much better towards having one unified app, because I think you're going to inherently get more and more complexity as you build your app more by having two different apps from the same code base, although it is certainly possible.
Yeah, awesome. So on Android, we would talk on one of the previous talks. They said that it can kind of take a long time to create custom components. What's that like in Flutter? Is it possible? Does it take long, or is it faster?
Yeah, I mean, it's very. I would say Flutter is like ideal for developing custom components, and it gives you so if you use like a material widget out of the box, it's there's like no effort basically, right? You just instantiate the widget. But Flutter also provides you all of the sort of like fundamental building blocks for actually rendering that widget. And again, because the Flutter framework is open source, you can really look inside and see how the material floating action button is built. And then it's quite easy to construct your own customized version of that.
Yeah, that's awesome. Another question is, can I use Flutter to build games?
Yes, it's definitely, and again, this is sort of related to the last, or my last answer, because so Flutter uses the Skia rendering engine. I will say Flutter can definitely do 2D games. It is not because Flutter inherently is a 2D UI framework. So it definitely gives you all the primitives that you would need to render a 2D game. And I know the open source community has created several game engines such as Flame. So yeah, it's definitely possible, and definitely people are doing it, and there's some pretty cool projects out there.
That's awesome. So you said earlier that Flutter controls every pixel on the screen. And apart from being able to make awesome designs, is there any other benefits of doing that? Because it may seem slower, but if Flutter renders at 60 FPS, it should run at native speeds.
Right. Yeah, it really gives you, so even though, like, again, using the if you just like go through a code lab and build an app with the material library, it'll feel a lot like building a React app, right? It's very high level abstraction, but because of the way Flutter renders, you can really do some just like, quite frankly, I'm just blown away by some of the Flutter apps people build, and just I was like, wow, I didn't even know Flutter could do that. Again, because it gives you access to actually painting pixels, and yeah, there's some really incredibly creative Flutter developers out there.
Yeah, definitely. Do you have a favorite Flutter app or a production app that's made using Flutter?
That is, I remember that we had a contest. What's it called? Flutter Create, where to create a clock, a smart display clock faces, and there were just like some really. I wish I had the video, but if you Google like Flutter Create clock, we put together a YouTube video compiling the best of them, and I was really blown away by some of like the animations that people did.
Yeah. Also, what about animations? How do you deal with animations in Flutter?
Right. So there's, I forget what the widget is called, but Flutter provides for you the abstractions for doing animations, and Yeah.
Okay.
It's basically I did it once before, and it was like having never done UI animations before, and I found it pretty straightforward.
Awesome. So I think that's all the time that we have today. If I can just call back Manta and Hannah. Thank you, Chris, for joining us today. It was great talking to you.
Thank you very much.
Hope everyone enjoyed that. I certainly did. And I'll hand it over to Manta.
Thank you. Cool. So, quite a day, right? Let me present my screen a second. Yeah, so it was a fun event today, and there was a lot of amazing talks today. We met a lot of people. There are a lot of questions, and we also try to address most of the questions that we can. So it was amazing learning experience for 2020 so far. So that's great. Thank you for joining us. But the fun doesn't end here. We have something for you. So there is a DevFest after party. So all of the people, you can join with this link here. Go over there and somebody will let you into the party. So everybody will be there. You guys just everybody gonna just chill. You can talk to anybody you want to. There will be the normal discussions. It's like, you know, the normal after party you have after the event. So yeah, feel free to join us over there. And before that, let us know what you think about the events. So for that, there is a feedback form here. You can either scan the barcode or you can just copy paste the link. So it will ask you a few questions and just let us know how we did for this year. Thank you so much. I'm gonna keep this open. So if anybody wants to join later, yeah, see you in the after party. Thank you so much. Bye-bye. Have fun.